prove the system wrong when it fails. And so you can challenge or replace any bad sequencer with just the data once available assumption. There are different arguments for, oh, should we make data available for maybe just 10 minutes, maybe just a week? Right now we're staying with a conservative 1 month, or maybe even longer. It's already a huge leap compared to the data forever available, since we're now not paying the unbounded price for whatever it takes to store the data forever. Instead, we have a bounded limit on how much data for how long will be stored, and it can be cheaper this way. Okay, so let's talk about the rollup-centric Ethereum roadmap. It's not a new idea. This is something that Vitalik already proposed in 2020, or way back before rollups and before Plasma and before other scaling technologies. There was already something called a shadow chain, which was a chain that was derived from another chain. And so a rollup works kind of the same, where you derive the rollup data from the layer 1 data. And this enables us to decouple the execution from the data, and we can dump down the layer 1 in favor of these more advanced layer 2 execution environments. And that way we can scale our execution independent of the layer 1 bottlenecks and independent of the layer 1 ossification. This is huge because it keeps Ethereum competitive with other chains. So how do we really achieve this kind of thing, right? Well, you need to encapsulate complexity. There's no denial that there's like a growing complexity in Ethereum, and the only real way to manage this is to try and encapsulate it. So this sparked the new trend in blockchain design, where now everything is modular. All the new layer 1s, they're all modular, modular, modular. Because of the increasing complexity, you cannot keep going on this monolithic GAF fork. All the previous 2017 alt layer 1s are just a copy of GAF in one way or another, adding new consensus or adding new things. But if you don't decouple the components, it will grow in complexity and it will be more and more difficult to maintain. Okay, so let's walk you through this modular design. So we start with layer 1 today. This is where things are very monolithic. We kind of just combine proof of work and the execution layer. There's one block. There's just one thing called ETHhash that secures everything, and it's just kind of singular. Now, think about the merge. We have this proof of stake beacon chain already live for a year now. We kind of want to couple that to our execution layer and get rid of proof of stake. And we do this with the engine API, where the engine API couples the beacon node, the consensus layer, and the engine, this is the execution layer, makes them talk together, and then we can basically encapsulate these two different things. So then we'll start to look like this, small steps. It's like the first tiny thing of modularity in Ethereum, which we hope comes sometime this summer, hopefully this year, where we now have two different layers. And we have proof of stake. Okay, so now take a step back, think about layer 2. How are we really going to scale Ethereum, right? So this is the current design where we have deposits and the sequence data. You pull it, you process it, you push back the proposals and anything you need in the future to sync the layer 2 chain. This is still kind of monolithic. And now think about Ethereum today. It's kind of silly also. Like we use the execution layer to stow data into. We take one execution layer from layer 2 and we use the data availability from layer 1 that's used for call data. This type of EVM inputs that you compete with for DeFi, is really a huge ask. That's why the base fee is so high. There are too many parties that are interested in this data because it's the most naive, most simple solution. So we should really try and specialize. We can do better than this. So instead, we want a layer 1 data provider. We want a layer 2 to kind of just use the data from layer 1 and not touch the EVM at all, except in the case when there is a fault proof or some kind of validity proof to resolve the execution. Now, if you think about other layer ones right now that are trying to fix the data availability problem, they don't have an unified execution layer. They just have what we know as layer 2. They just have an execution layer, some kind of software and rollup system where you can have these different rollups chained together, but notice how there are no fault proofs or no validity proofs in this diagram. This is because they happen off-chain. They're not part of the layer 1 system. And then, well, we do have a data availability layer, and we can scale the chain by a little bit, at least. Still, we can do better. And for Ethereum, we need to do better because we want to preserve this whole DeFi ecosystem. We are not throwing away everything that we have. Instead, we want to embrace data while keeping our beautiful global execution environment. So this is EIP 4844. This is the change that we're trying to introduce data without breaking Ethereum. It's a kind of a meme where we say it's like the full sharding design developed by Dankrad, working at the Ethereum Foundation. It's called Dank sharding. And so I work on this EIP, and it's kind of like the precursor to the full design, so called proto-Dank sharding. Okay, so how does proto-Dank sharding look like, or how does EIP 4844 look like? Think about it as our consensus layer, so this is after the merge. Then we have our execution layer, so this is including DeFi. And then we have a separate layer for these data blobs, which means that we can host our data for, say, a month, for some limited amount of time. That's enough to secure the layer 2s, while also providing more capacity. And notice how we're providing blobs in a very specific format. It's just not any format. This makes it forward compatible with the full design of Dank sharding. What we're trying to achieve here is that we don't have to make any modifications anymore to the execution layer to Go Ethereum. Instead, we only, in the future, we work on the consensus layer to implement these more advanced technologies for full Dank sharding and scale even further. So let's talk about the full version. So, well, we add more of those blobs. That's the obvious one. We introduced data availability sampling, which sounds really complicated, but it's really not. It's this technology where instead of having one blob or one collection of blobs per block that you have to enforce everyone to download and to keep available, instead you can distribute it through the network. You can split the task. And to secure, you just have any validator do these random checks, requests to others in the network to make sure the data is still there. And then there are fancy data extension and data recovery techniques to increase the chances to make it like really, really secure that those checks actually map to a data being available or not being available. And like I said, it's forward compatible, so we can get away with a single layer upgrade again, even though we're scaling by another 10 times. So how does this look like? Well, it kind of looks very similar, except now we have many more blobs per EVM block. And this means that we go from like around a megabyte on average per layer 1 block to 64 times that. So now we're talking about 1.4 megabytes per second. Whereas now we have like 70, 80 kilobytes per 14 seconds on layer 1. It's a huge difference. It's like 100 times, if not more, in scaling. So, okay, let's talk about Optimism Bedrock. Optimism Bedrock is this kind of philosophy where we want to take a layer 2. We don't want this rushed version that tries to roll everything on their own, but that also not like really provide the users with what they want. What the users want is something very similar to layer 1, but faster, cheaper, and more usable. So we want to keep snap sync. We want to make sync of your node as fast as possible. We want to have a transaction pool. We don't have this centralized endpoint to submit transactions to. We want fast block propagation. We want the equivalent execution environment. You just want to run GAF, really. We want deposits that are actually nicely typed and not some hacked version on top of the current system. And we want to improve the stability on like how this layer 2 comes to exist and how it extends. So we want constant block time, cheaper transactions, and a bunch of other optimizations there. How are we going to achieve this? With modularity. So think about layer 1 today, it's like GAF. Now we're adding Prism with the proof of stake chain. And we can do better. We can repeat this pattern on layer 2, where now we have a consensus layer on layer 2 and an execution layer on layer 2, which means we separate all the rollup technology from Go Ethereum. So Optimism is just a stateless client, really easy to set up, no database, no configuration, it's just there. And it pulls data from layer 1, converts it, processes it, and forwards it to the layer 2 version of GAF. And so we get this same pattern where the beacon node talks to layer 1 GAF, the OP node talks to layer 2 GAF. And you can repeat the pattern the other way around. We have the beacon chain talking with the beacon chain, layer 1 with the layer 1, and so on. Everyone talks with their own kind. And here again, layer 2 kind of just does the same as the beacon chain, where it distributes blocks in a faster way. But notice how layer 2 is like the happy case, and layer 1 is the base case. Layer 1 always guarantees security. If the layer 2 completely fails and falls apart, you can still reconstruct it from the layer 1. So it's always there, always live in a way where you can process deposits, you can keep continuing. But we also repeat like the EVM, the sync, the transaction pool. We keep all these properties. So it will feel and look a lot like layer 1. And the one difference that we want users to take away here is that they don't have to change their systems, they don't have to change their DeFi projects. It's just going to get more and more, like it's going to get better for them, less expensive. So this is what it looks like. If the data provider and the engine kind of just have now one way to pull the data from, one way to pull these deposits and our execution activity from. Rollup node sits in between, maps everything to layer 2. And then layer 2 is this engine which processes the blocks. And well, it's all open source. We don't hide new upgrades from the world. We are here to share everything. We are here to get feedback from you. And you can go to this repository. We're planning to merge it with the other Optimism mono repo. Right now it's a separate specification repo. We have a reference implementation and a local devnet as well, so you can get started. It's all very experimental with our specifications. You can learn about all of this. And it's what we think is the future of modular blockchain and Ethereum scaling. Thank you. We have some time for questions.
Yeah, if we have any questions, we can bring the mic around to you. Come on, we gotta have some questions.
I can go back to the diagrams.
I got you.
There's a lot more to them.
All right.
So from what I'm getting, Ethereum is not going to need a separate data availability layer to just support instant data availability. A separate layer like Celestia or something like that.
So, sorry, to repeat the question, you're asking about the differences between like a data-focused layer 1 and Ethereum, right?
Yes.
Okay, so, and you mentioned Celestia as an example. So Celestia is one of those cases where software rollups are becoming the new thing. Whereas I think like we don't want to shy away from like this unified execution layer. It has a lot of value for different purposes. I think one of the main cases here in terms of security is that we can play these validity proofs and these execution things on-chain, which sounds slow, but it's only in the worst case. And so we get better guarantees for the completion of this security game. And when you think of a software rollup, it all has to happen off-chain. And so once somebody starts to publish these things, and they cannot publish it in time, or when they reveal themselves, they're more vulnerable to be like try to be censored, try to be attacked, some kind of denial of service attack. Whereas if you have layer 1 to publish to, you publish to layer 1, you have a week of time to do so in the optimistic case. And then once it's confirmed, nobody doesn't see default proof. There's no hiding of the execution. Whereas with Celestia, it's really focused to try and be purely data, and they're doing everything outside of layer 1. Also, I think another case is bridging, where if you think of all these different layer 2s, if you have like a really diverse system, you want to bridge liquidity, and you want to do so with the utmost security. You don't want to rely on centralized bridges. We all know how that goes. Like just yesterday, or like the day before, there was a $600 million hack on one of these bridge platforms. Like really, you should have a roll-up type of bridge with like the security guarantees of a system instead of any random actor that operates the bridge.
Yeah, if anyone wants a good job, they should be looking into kind of monitoring that stuff too. Like you could probably find a good job for monitoring to make sure that kind of stuff doesn't happen, because I don't think that they had any monitoring in place.
Monitoring or auditing of bridge systems is probably the most lucrative business right now, yes.
All right, we have one more over here.
Hello, thanks for the presentation. So if a relayer posts a fraudulent bundle and fraud proof happens and it is detected that it's fraud, what's the current economic cost in Optimism now?
Right. So I think the current rollups, none of them have running fault proofs yet. I mean, there's a huge reputational cost. We do enable like default proofs in the future. I think, so Optimism doesn't have default proofs enabled right now. Arbitrum has like a, what is it called, like a allow list to only have like a selective accounts do this fault proof. And then some of these ecosystems are not in production either yet. So in a way, I think we're not quite there yet in the roll-up-centric Ethereum. I do hope to get there in the future.
But once we get there, well, we're talking about millions, billions?
Sorry, can you speak up and repeat the question?
Yeah. So once this is in place, if I understand, the relayer will have to put a bond, and if anyone wants to meet the fraud proofs, this bond has to be matched. So I'm wondering, what would be the size of these bonds?
If you do execute default proof, what would happen is that the proposer is independent of the layer 2. So the proposer, you really have to think of it as a way to bridge back activity from layer 2, some kind of messaging, like withdrawals, to the layer 1. And like in this case of Celestia or these other data-centric layer 1s, you don't need these proposals if you don't have a way to, if there's nothing to bridge back to. Like the fault proof is really just about showing layer 2 activity to layer 1. And the layer 2 will not be affected by the fault proof at all. Everyone on the layer 2 will interpret the data their way, will process it their way. Just like if somebody processes a fake proof of work or does some fake voting with proof of stake, it doesn't change the system or the rules of the execution. Everyone processes their own chain. And it's really just the layer 1 that you're trying to trick with like a bad proposal. And it just purely depends on the bonding of the proposer on how much they get slashed. And we can parameterize this. We can have like a huge bond to secure this type of withdrawal.
Okay, thank you.
All right. We still have about 2 minutes. If anyone else has any questions, just raise your hand. Nobody?
Okay. If you have questions about the modularity between the data and the execution layer, and then specifically about execution, you should maybe wait for the talk from Ansgar, who is going deeper into that type of scaling.
Hello? Hi. I have a question about the latency about the data blocks. If we say one of the data blob in one shard, and then how long time it takes to synchronize this blob across the entire network?
The current EIP describes the usage of the current transaction pool, so we're not changing propagation. And so it will just be like a regular transaction where it just depends, do you pay enough of a base fee? And if yes, then your blob transaction with all the data will get confirmed.
Okay. And the second question about this is about, you mentioned the data rate to save a blob in the blockchain is about 1.4 megabytes per second. So I would like to know more about the bottleneck about the data rate. Is that the synchronization issue across the network?
All right, so we do plan to scale the data by a lot, and this of course raises network concerns. How much data can you propagate? Does it scale? It's definitely something we want to test. It's not something you can work out neatly in theory, where we have both on the exclusion layer as well as on the consensus layer this increased network activity. And so in the upcoming DevNets, we'll try and benchmark that.
Yeah, thank you.
All right, so we're going to take about 5 minutes to prepare for the next speaker. When we do have questions, if we could have people stand up when they raise their hand, that'll make it a little bit easier for us, but we'll go ahead and get the next speaker ready for you guys and be back in 5 minutes. Thank you very much. Yeah, round of applause, please. Proto Lambda. Yeah, Proto Lambda on Twitter and GitHub if you guys need to contact him. Okay, so we're going to get ready for our next talk. So next up we have Ansgar Dietrichs. His talk is on EIP 3074 and the role of the EVM in the L2 world. So Ansgar is at Dietrichs on both Twitter and GitHub, and he works with the Quilt team as an R&D engineer working with Consensus Mesh, coming to us from Berlin, Germany. Welcome everyone to the stage, Ansgar Dietrich.
Hey everyone, good morning. Yeah, so as Eric was saying, I'm Ansgar, I'm a member of the Quilt team. What we do is mostly Ethereum co-development, so it's a little bit of a collaboration between Consensus and the Ethereum Foundation. And this is the talk that I'm going to give, and I wanted to start by just giving a little bit of like a motivation for why these two somewhat separate topics. And so this EIP 3074 that I want to talk about, this is just the header of the EIP. As you can see, it's basically an EIP that the team and I, we basically created roughly 1.5 years ago already. And since then, we've been giving a lot of talks about it, just basically trying to create some momentum for it, educate people, and all these kind of things. But more recently, people have been coming up to us and have been asking things like, will the EIP ever reach the Ethereum mainnet, right? We've been talking about it for over a year now. Can we expect this to ever actually become reality? And then also, and that was what really kind of was the most interesting question to me, like in the last few months, people have started also asking, could it maybe be introduced to one of these rollups first, and then maybe later on come to Ethereum itself? And that got me thinking, and so instead of just repeating the same talk that I've been giving for a year now, I wanted to basically split up the talk a little bit, and I will still talk first about the EIP. So if you have never heard of it before, don't worry, like I'll explain it. But then in the second part of the talk, I also want to talk a little bit, like zoom out a bit and give some context and talk about why is Ethereum moving to rollups again, and what are the implications, and what does it mean for things like this EIP and for the governance of the EVM in general. So yeah, that's the plan. So let's start with the EIP itself. So basically, the one-line summary that I would give is that with this EIP, we are trying to allow EOAs. EOAs is just accounts that have a private key, so like your MetaMask accounts are all EOAs, to operate like smart contract wallets. So you might have heard of Nose Safe or these kind of things, and these smart contract wallets really have a lot of really nice advanced features. And basically the idea was, how can we bring at least some of these features to these accounts as well. And specifically, we want to address a couple UX problems. So if you've ever interacted with anything really DeFi related, you're probably very familiar with this flow where you first have to send an approval transaction, and then you send a separate transaction to actually do the thing you wanted to do. And sometimes that might even be 3, 4, 5 separate transactions you have to send. And more generally, basically, actions on Ethereum tend to be like really, why is there no? Ah, okay, I pressed the wrong button. No, I think it might be internet latency, whatever. So, and more generally, basically, actions on Ethereum tend to be one-to-one correlated with transactions underlying. And to some extent, that's just a problem with contract design, but it is also, in like a insignificant part, just a consequence of how the EVM is designed today. I hope that this doesn't keep happening. Let's see. Okay, anyway, so some other UX problems we wanted to address are that today there is not really good defense against losing access to your UA, right? If you lose your seed phrase and then your device gets stolen or whatever, you might not be able to recover your UA, or you won't be able to recover your UA. And then also, wow. But right now, you basically always need Ether, and that's really not great for onboarding new users. So that's just like a mixture of different things that we all wanted to address, and by making EOAs basically more powerful. And the root problem, and this might be a bit technical, but if you've ever like looked at a smart contract, you might be familiar with this, is that the way contracts usually authenticate the user interacting with it is just by looking at this message.sender value. To explain that a little bit, so here's, just like to give an example, this is the ERC20 standard transfer function, and in there you can see that just to determine which account actually sent the transfer, so which account do I take the balance out of, the contract just looks at this message.sender value. And more generally, basically, whenever you have some sort of smart contract interaction, so you see like the transaction starts at this gray box, and then it calls into a contract, and then calls into another contract, and all these things. So at every step, the message sender is basically set to the entity calling it. And if you look here, only in the very first step is the message sender actually the account controlled by the user, right? And so only in the very first step can you do something like send tokens or approve them or all these kind of things. So basically, whenever you have to do, there are multiple things you want to do from your account, you basically have to create a new transaction every single time. So how do we fix this? There have been a couple solutions in the past. The first one that you might have heard of were meta-transactions. Meta-transactions basically is the idea of doing like indirect transaction routing where the user basically signs the action instead of directly sending a transaction, and then the contracts they interact with know how to handle these signatures. And as you can see already, this is going to be a little bit of a meme. I've stolen that from my colleague who's been giving this presentation a lot. And so this is like the implementation. You can already see it adds a lot of complexity. That's basically the equivalent of a transfer just in this meta-transaction style. And then the question is, do they actually solve the problem? And the answer is unfortunately not really. I'm a big fan of the idea of meta-transactions, but the problem is that every contract has to explicitly add support for them, and a lot of contracts don't, and so there's not a lot of interest in building up good tooling for it because most contracts don't support it, and because there's not good tooling, most contract developers don't bother integrating with it. So it's basically like this vicious cycle where it was a really nice attempt, I think, at solving this problem, but it basically got stuck and didn't really go anywhere. Then the other approach, and that's basically coming right from the motivation of making UAs more like smart contract wallets, why not just use smart contract wallets directly, right? Smart contract wallet solves this. The problem here is that while that's true, smart contract wallets are also really, really expensive, right? So basically, whenever you want to deploy a Gnosis Safe, that's easily like $100, and then every time you use the wallet, it's much more expensive than just sending a normal transaction. So it's just really, it's a great solution, but just not feasible for most users, right? And also, and that's a little bit of a teaser for the next talk, so stick around, but right now at least, smart contract wallets can't directly initiate transactions, so you always have to go through some other account first. So then, if all of these solutions don't like fully address the problem, how do we want to address the problem? Well, that's where the ERP comes in, ERP 3074. And the important thing here is that like we don't only want to solve these problems, we want to solve it just for free. Just adding features to the existing accounts that all users already have and mostly love, or at least tolerate, I don't know. So how do we do this? Well, we do this by introducing these two new opcodes, these two new basically elemental operating steps to the Ethereum virtual machine. And basically, conceptually, don't bother reading all the details unless you're one of these people interested in all that stuff. But the conceptually, basically, the idea is the user basically signs over an action they want to perform, or multiple actions, right? Like if they want to perform 5 actions or whatnot, or sign over whatever other things they want to allow their account to be used for. So that could also be something for social recovery. They could sign over this other person is allowed to send in my name, right? So all these kind of things, you can just put that into a signature, and then a contract on Ethereum can use this magic auth functionality to verify that signature and then basically gain the right to impersonate your account and send transactions in your name. And then they can use this auth call function to send like basically like a sub transaction, but they can importantly just use that like 5 times in a row, right? To do 5 different things all within one transaction. So this is kind of the underlying magic that would make this ERP work. And just to look at how this actually looks like, right? So the user, again, is signing the message for whatever kind of use case they have in mind. The contract verifies that with the auth, and then it's actually executed, right? And this contract that does these things, that would be like a special type of contract. You can think of it somewhat similar to like your Gnosis Safe today, right? And we are calling these contracts the invoker contract because they invoke these special opcodes. importantly, basically, as I was saying, when you sign a message, you only want to allow the contract to do specific things, right? You don't want a contract to just take all your NFTs and run with them, right? You only want it to do whatever you authorized it to do. And the invoker here has the special role of actually enforcing these rules. And that's somewhat of like a problematic security implication as well that we'll talk about in a second. But just to look at how that works in practice, so say this would be like one of these messages you sign, and importantly, you basically, the type byte doesn't really matter. The invoker address, so that's basically you're only granting access to your account to this one specific contract, and that contract could be a invoker that's specialized for bundling transaction, or it could be like a contract for key recovery, or for whatever type of interaction you want to use, basically. And then in the commit, that's basically where you tell this invoker contract what you intend the authorization to be used for. And so in the commit, you could put like a hash that references a transaction, right? Like a nonce to gas call data, and then it would take that and it would actually perform that action. Or you could, in case of like a bundling version, you could put multiple transactions in there, right? So basically, the commit is your way of communicating with the invoker and basically telling it what it is supposed to do with your authorization. But importantly, with the authorization, you technically give full control over your account to the smart contract. But because it's a smart contract, there's no one can manipulate it or anything. You can read it in advance. You can see what it's able to do with your signature. So this is kind of the IP at a glance. So what's the status of it? Why isn't it on Ethereum yet? Well, to understand that, we have to kind of talk now a little bit about like how do things actually get onto Ethereum? How are they included in practice? And so just to basically give that some context, so the timeline here, we created the IP in October of 2020. We then picked the first hard fork that we hoped the EP could be included in. That was the London hard fork last year. So in March, we proposed the EP for London. Technically, there was this Berlin hard fork before that, but there was way too short notice, basically. So we didn't try to get in there. But then people had some security issues, so we also commissioned some audit reports that came back very positive for the EP. But then, unfortunately, August came along and people decided London EIP 1559, that is like already a big change. We just don't have room for non-topical EIPs. So the EIP was not included after all. Then in September, we were like, okay, no big deal. We'll just give it a new try. So the next hard fork that will have room for EIPs again will be Shanghai. So let's just propose it again for Shanghai. Shanghai will be the hard fork after the merge. But then, unfortunately, now basically people looked into what do we want to do for Shanghai. It turned out there was already a long list of other EIPs. A lot of them are really important. For example, beacon chain withdrawals, right? If you're running validators, you want to be able to, if you for some reason want to stop validating, you want to be able to withdraw your ETH out of the beacon chain. So that was important features. There were a bunch of other really important ones all lined up. And so people again said basically there's no room. And so at the earliest Q4 of this year, maybe a little bit later, we'll have this next hard fork, and again, the EIP will not be in there, right? And you can already see it's basically just one opportunity a year. If you miss it, you're kind of out of luck. But then also, maybe to take a little bit of a closer look at what's actually happening in the governance process. Actually, the governance process consists of two different steps. So the first part is the EIP process, where you basically just make sure that the proposal you have, the idea you have for changing the virtual machine or changing whatever part of the protocol you can think of, that it's well specified, right? So you create one of these EIPs, you follow the rules that are outlined in this EIP1, which is basically like explaining what exactly you have to do, and then the EIP process just makes sure that your proposal is well specified, right? That people could just take it and implement it if they wanted to, and that there are no open questions, no things you might have forgotten about, these kind of things. But there's no judgment yet in that step of the process, right? Or if whether it makes sense to do that or not, that's just a formal step. And then the second part, and that's I think where it's really interesting, that's the core developer process, and that's where actually all the decisions are made. So this is just a screenshot from the bi-weekly core dev calls. I can very much recommend, like before I actually became like a co-developer myself. I basically watched every single one of these for several years. They're really interesting, but that's basically where all the client developers, researchers like our team, all people basically involved with the base layer come together and look at, okay, there's a new fork coming up, what ERPs basically are there that we could include, and do we want to include them? And for that, basically there's this list of criteria that it's a bit of an informal list. I tried to just formulate it here, but the idea is basically a proposed change has to be worth it, right? It has to be valuable, and importantly, it has to be valuable enough to justify adding complexity to Ethereum, right? The second question then is the change safe? There's basically like a very uncompromising spirit to this step, where if there's any question about whether something could potentially break Ethereum, we will not do it. So this is like a very important requirement. And then the third one, though, and that's actually where most of the ERP end up stalling. This is like, do we actually have the required attention to go through the ERP, right? And the attention, that's actually quite a bit of commitment. So that's, you need to review the ERP, make sure that there are no edge cases left out. You have to implement the ERP, you have to do all the testing. So this is really where most of the work is, right? And so then thinking about our ERP, right? First, maybe just let me briefly shout out if you're at all interested in this code process, but you might not want to actually watch all these calls because they can be a little bit technical. I very much recommend following Tim Baker on Twitter. He's the guy in charge of the calls, and he has these amazing summaries every time after the call. So do give him a follow if you don't already. But like now let's come back to our ERP. So how did it play out in the governance process? So first off, we were on a lot of calls. So this is just like a list of all the calls that we were on the agenda for. We weren't actually like present, like it wasn't discussed on every one of those, but on the majority. So there was a lot of discussion about it. And then the verdict was basically, generally it would be valuable, right? It's an amazing ERP. I mean, that's my possibly biased take, but it's a nice ERP, let's put it that way. A lot of users really like it. It would be very nice, but importantly, people had security concerns, right? As I was saying, with the Invoker contract, it can basically take full control over your A, and then there's this commit functionality to limit it. And we spend a lot of time making sure that actually we think it's safe. But the problem is, we spent all that time. The rest of the core developers didn't spend the time yet, right? So they trust us that it's safe, and that's of course not enough, right? They have to actually work through all these ideas themselves, and there's just not enough time for that yet, right? And so basically, what we're right now, the situation is that we're in is basically we're waiting that there's enough of a gap in Ethereum progress that people just have the free time to go look at our EIP and really talk with us about exactly why is it safe and why basically can we bring it to Ethereum without breaking everything. That's kind of the position we're in. And also there were some other smaller concerns, but I think we were more confident being able to address those quickly. So but that's basically a little bit of an overview of where this is basically at in the governance process, and then to now briefly go to the second part and talk a little bit about what about rollups? Can they maybe help? So I'll have to glance over some of the details that also, like I think Proto already talked about very well in his talk just now. But basically, why did we choose a rollup-centric roadmap in the first place? So basically, the idea was the early insight, like a monolithic blockchain just doesn't scale, right? You can't have every person in the entire world validate every single transaction. So we came up with this idea, where like people in the very early days of Ethereum came up with the idea of like, let's find a way of splitting up the activity on the chain so that everyone only has to look at the parts that they're interested in. And so the first approach that people went with was just to say, how about we take 1,000 copies of Ethereum and we just call them shards, and they all run in parallel, and that way we get some scaling. Then after that, people were like, yeah, but if we are already creating new chains, why not improve them? Why just copy them? We could make them better. We could have these EWASM, Ethereum WebAssembly. We could have execution environments that basically the idea was to make them more kind of customizable. Again, this is not all that important. The takeaway here is just that this approach was just not efficient enough, right? So basically, people wanted to add more and more functionality, but we needed a way to basically to make this really efficient. And this is basically where rollups came in. So rollups, how do they work? Well, they basically have a long history of other layer 2 research before that. If you were around in the days of Plasma, you might still be traumatized from how we spent years in that direction, but oh well. The key idea that we then finally had with rollups was we can separately treat the problems of scaling the execution and scaling the data of a chain. And if you do that, basically, the idea is that for execution, we actually came up with these marvelous techniques of using fraud or validity proofs, like validity ZK proofs, to compress what the base chain has to do to like a very, very minimal amount. So execution was all of a sudden basically solved. And so the only thing, I mean solved, but at least deferred to the layer 2 teams to figure out. Let's put it this way. And Proto is smiling very brightly right now. So this is very much not a solved problem, but at least now basically we have a lot of teams looking at this separately. And then for data, this is basically now what the scaling effort on Ethereum really came down to. How do we scale data on Ethereum, right? And we have all these ideas of how we can actually do this. And this is literally basically now what we can focus on. So how did this play into our sharding design? First, we just basically realized we don't need that many shards, and maybe some of them we only need for data. Then we looked at the existing Ethereum chain, and we were like, yeah, but we already have an Ethereum chain, so why don't we just use that as the execution chain? Why do we even have to create all these new execution chains at all? So this is kind of where the merge idea came from. And then most recently, people looked at the data part of the equation and were like, why do we even need sharding at all for data scaling? Can't we do more efficient ways? And this is where, if you've heard this on Twitter recently, this new approach, dunk sharding, comes from that makes sharding really efficient, basically. And just as a quick aside, I think we should stop calling it sharding. It's really sharding in name only. We now do this more efficient way of data scaling. We should find a better name. But yeah, I assume that's probably like a lost cause. But I wanted to put it out there anyway. So what's the transition plan here? Of course, next up is the merge. That's just like a preparatory step in terms of scaling. Of course, there's a lot of other nice benefits. Then, as I was saying, at the earliest, at the end of the year, we'll have the Shanghai fork. Ideally, there's this effort of the EIP that Proto talked about, this proto-dunk sharding, basically the 4844, that would already give us a lot of the benefits of sharding, just not the full throughput yet. And then we have this fallback EIP that like Vitalik and I proposed last year that would just make the existing data type, the call data, cheaper. So in case the other one turns out to be too ambitious for that timeline, we have the fallback plan. And then after that is done, next year hopefully, or whenever we are ready, we'll do the full sharding, and then basically data will be endless and everything will be beautiful. So this is kind of the plan. And so now let me take the last 2-3 minutes that I have and just talk about the implications, and then come back to ERP 3074 and how that ties in. So first off, I think this is like, you might have heard this term thrown around, like the modular blockchain, right? And I think this is really one of the key advantages of this roll-up-centric approach, that it's important, I think, for people to fully internalize, right? With this move to roll-ups, we basically unopinionated on how to scale Ethereum, right? We only provide the tools, and then all these roll-up projects can choose what to do. And I don't want to go through this entire list, but there's a billion different choices that roll-ups can make that will lead to really, really interesting different trade-offs and alternatives in the scaling space. And in that way, basically, we are replicating all the benefits that we get with layer 1 diversity today, but we now all get that on top of Ethereum, so you have the same shared security, the same native interoperability, and the same currency on all of them. So this is really, I think, this slide is basically, I think, what rollups are all about in terms of the value they create. But in terms of the implications, and I think this is something that people haven't really talked about much, so this is mostly just like a list of open questions. But Ethereum was really designed to be a user-facing platform first, right? Like the EVM, Solidity clients, tooling, all of these kind of features. And now, all of a sudden, it's mostly a rollup management layer, right? So what exactly does that mean? What will the implications be? Will it continue to be like, will layer 2s copy some of these tools? Will they do their own thing? It's I think, very much an open question for now. And specifically, there are like a lot of open questions for the clients, for Solidity, for research. Like how does this new world work? Where basically users don't just use Ethereum themselves, but they use the rollups. And then on the VM, and that's kind of where we're tied back to the ERP3074, basically the question is, how will rollups treat the EVM? Will they just copy it, or will they modify it? And if they modify it, how will we achieve standardization, right? Or do you basically have to install separate MetaMask and separate tools for every single rollup you use? And then if they end up using the same virtual machine, right, how does it work with the governance process? Right now, the governance process, that's only layer 1 teams coming together deciding about new features. But how do we basically integrate layer 2 teams into this process, right? And so, again, there are no answers yet. But just to leave you basically with like looking at the 2 questions we started with, will the ERP ever reach Ethereum mainnet? I think, hopefully, but we will have to see. And then could it be introduced first to some of the rollups? And there, I think, basically, my motivation was just to give you a bit of a framework how to think about this, right? So I think in order to answer this, we first have to just figure out how will virtual machines in rollups even look like, and what's the path to be taken there. And this is basically what I wanted to get across. And with that, thanks. And if you want to find the slides, you can find me on Twitter. And I think, unfortunately, I don't have time for questions, so do find me after the talk outside. I think there's a break now anyway. But
yeah, we do have a break, and that's fine if you don't have time for questions. I was just going to say that my boss, Dan Finlay, this is one of his favorite EIPs, so just wanted to throw that out there. And I have him on Slack saying so.
Nice. Yeah.
I did have a quick question. So you can have a contract between wallet A and wallet B and enable like delegation and key rotation?
Wait, can you repeat that?
Like you have a wallet A and a wallet B, and the contract could be enable like delegation and key rotation? Right.
Yeah, I think that would be one of these examples. So basically, you can give control over your account to a different account that would then basically you're delegating, and then you can at any time revoke that control, right? So the nice thing is, because these invoker contracts are full smart contracts, it's no longer just an ECDSA signature. You can program in whatever functionality.
Let's go ahead and pull up the next guys. Let's pull up the spreadsheet first, really quickly. I thought my question was dumb. All right, so Christoph is next. Good, great. Yeah, let's go ahead and pull his up, and let's go ahead and get it ready, and let's walk through each one of the slides. Do it in the presentation mode, because it'll be different.
Hello.
Hey.
So I'm speaking in an hour.
Yep.
And I just realized that I cannot just put my laptop here, right?
Can you pull up this slide?
No, it's okay. I actually don't want.
Oh, no, that's fine. Pull up the spreadsheet real quick. Let's make sure we have his slides.
Hello.
Yes, I have the slides.
Wait, did I close it? Genial, no, es que traigo como una demo, quería enseñar.
Si tienes demo, pues
No, pero de hecho lo tengo grabado en vídeo.
We have slides.
Yeah. We have your slides here.
Este tiene internet, ¿no? O sea, si le doy a un link, se abre un explorador y puedo poner el vídeo, ¿no?
sí, pero es un poco...
Sketchy.
I've got my slides too.
¿Sabes usar Windows para pasar? ¿Pasaste tus slides? Okay.
We're gonna pull them up now, and they'll be ready when you come up here.
Bueno, jalas la ventana, no importa.
Podemos probar ahora.
Yeah. So just make sure that you're here around 11:25.
Can you open these ones? There should be a link.
I'm going to hold on. Cheat here. So Christoph Gajo. I know now.
There you go. One of these links.
I've
uploaded
been
into
asking
providers
people
just to
they go up, but I thought I had yours nailed.
Is there sound?
No.
And let me see here. I want to see if I have any questions.
Sí, genial. Buenos días. GM.
I scheduled it with 5 minutes before.
What's it called?
I'm good.
Oh, I'm good. What's it called? You know what it's about?
It has to be that way.
Head out, head straight towards the end. On the left, you'll see like a basement alley.
So that this way, right?
This way?
All the way
And
down.
all the way.
And then to the left, there's like a basement looking.
What's the board ape for?
Oh, the floor for Bored Apes is like, well, aside from the one that just sold for like $115.
Oh, it's longer. Oh yeah, sure. I'm gonna take this off anyway. Can you actually do some from this side? Because you've seen the presentation then. Oh yeah. Oh really? Like that. Nice.
So you see, disgusting, sexy. Because you have the background and you have the light on the side, so it looks really cool. So you want from this angle.
Oh shit, you're right.
Maybe with your
Can you
eyes
take some
open.
more?
Yeah.
This is lit. I like this. Sorry? Oh, I have 69 slides. Ha,
Yeah,
funny.
oh, I saw it. It's beautiful. It's just kind of
That's the next previous. Okay, that's cool.
very simple. I'm gonna replace your bottom.
Oh, thank you. Yeah, good. Looks good.
You walk through the slides, no problems?
Nope, perfect. Yeah. Do I? Like XR? 10. Thank you, this is lit.
the timer will be down there. Don't even look at that one.
Okay, cool.
Yeah, just don't even look at that
25 minutes for 20 plus questions or?
25 minutes, and then so
Mine lasts about 23
so we end at like 11:55.
Can still have some questions after.
Let me check one thing real quick. So,
Mine's after.
okay, all right. Yeah, so if you really want to get in questions, I would say end a few minutes early. If not, I can go a few minutes over.
Okay, that would be cool, yeah.
Yeah, yeah.
Is the live stream live already?
Yes.
Like,
And at 11:29, I will introduce you, and in fact, we can even do it, a little bit before that. That
sounds good. Well, yeah, that's fine.
yeah. Okay. Oh no, I don't like the ice cream. That's all they have. It's fucking pissing me off. I can't stand the ice ones, but it's the only ones I can get. So I've been trying to find one that's not ice. But I'm leaving at midnight. I want to be able to find a jewel, like an actual jewel pop. They don't sell them here. I can't find them anywhere. You can All right, 1 minute, and I'll introduce you. Do you have his slide? Are you recording his slide? I don't think his slides. Okay, then you just here. Yeah. Are you sure it's track 1, not track 2? Look on the ETHDubai schedule. I've got it. Just go to ETHDubaiconf.org. So I've got to introduce him in a second, and I can talk to you. It's all the way down to into the hall on the left. Somewhere. I don't know where. Yep. Okay. We're going to get started with our next talk in just a moment. Christophe Gageot is here, and he's going to be talking about why smart contracts are the future with EIP 4337. You can find him at Christophe Gageot on Twitter and GitHub. He is a project manager and researcher at Nethermind ETH. He's an Ethereum core dev working on protocol research, flashbots, account abstraction, and the merge. The only other thing I would say is no vibes, just roadmap. Everyone. One thing. He's on a good Cat Herders episode too. If you guys know Cat Herders, the podcast, go check it out. He's on there. But yeah, let's go ahead and welcome Christophe to the stage.
Hey guys. Wow, this is quite loud. I'm going to be presenting today about why smart contract wallets are the future with EIP 4337. So, as a little teaser, as mentioned before, I'm working at Nethermind. I'm a core developer. And you all probably realize what this is, right? This is a Bored Ape. Oh, almost. Not a CryptoPunk, a Bored Ape. But something I've been seeing recently with these Bored Apes is the following. Right. So as you guys can see, it quite often happens that these Bored Apes get stolen. It's important to realize, though, that they don't get stolen because of some problem in the Ethereum protocol. Rather, they get stolen because of phishing attacks. So the problem is with the UX of Ethereum. I don't think it should be this easy to lose $400,000, right? Just entering your seed phrase and seeing it go away in a flash. So this is kind of the motivation of this talk, right? I'm going to be talking about why EOAs suck, why smart contract wallets are better, the current problems with smart contract wallets, and how our EIP, EIP 4337, tries to solve this. So, first of all, what are smart contract wallets? This is a seed phrase, and this is what controls your smart contract wallet. Well, to be specific, the private key derived from the seed phrase does. And while this is cryptographically incredibly secure, there are still major problems. Instead of talking about it for a few minutes, I'm just going to let you read this amazing SKCD. So as you can see, the problem is with the humans. It's not with the cryptography. We shouldn't expect the next financial system to rely on people storing their life savings on 12 words on a piece of paper. Another problem with EOA accounts is their signature scheme. While ECDSA doesn't have any major problems by itself, it's quite restrictive, right? In Ethereum, you can only use the signature scheme for EOA signatures, nothing else, even though there have already been developed quite a few better alternatives. So, EOAs suck, we've established that, but why are smart contract wallets better? Well, first of all, their signature schemes are a lot more flexible. So an example of a smart contract wallet scheme is a multisig, right? Imagine that you have, say, 3 keys that allow you to control your wallet, but you need 2 of them to actually interact with it. So say if you hold one of the keys and someone finds it, you fall for a phishing attack, they just have that one key and they can't do anything with it by itself. Another example is social recovery wallets. What this means is that you have one central controlling key that can do basic functions in your smart contract wallet, but it's time limited and it can be replaced by a set of guardians, right? So if, say, you lose your controlling key for the smart contract wallet, you can go to your guardians and request them to replace it for you. Okay, so while smart contract wallets are amazing, they have some issues. The biggest of all, probably for the average Ethereum user, is the gas cost. You pay a very high gas overhead for using smart contract wallets, and we really shouldn't expect the average Ethereum user to be willing to pay 50, 60, 70 extra dollars for a simple trade, a simple transfer. Another problem, which is kind of the main focus of this presentation, is the following. All smart contract wallets on Ethereum right now have to be relayed with an EOA. All Ethereum transactions must be initiated with these EOA accounts. And this is a problem. This means that if you want to interact with your smart contract wallet, you either have to maintain a separate EOA filled with some ETH to be able to transact, or you can rely on some separate relayer service. So for example, Argent, one of the wallet providers, they maintain their separate relayer mechanism where if you want to make a transaction using your Argent wallet, they will use one of their own relayers and call your wallet for you. Now, there's a problem with this, which is that each dApp right now needs to develop their own relayer mechanism if they want to use it. And it's quite centralized because if it goes down for whatever reason, it's going to be incredibly difficult to transact with your wallets. This is what account abstraction tries to solve. Account abstraction has to do with trying to get rid of the requirement for EOAs to initiate transactions. So how does EIP 4337 help us get there? This EIP is called account abstraction via entry point contract specification. Well, this means nothing, so let's explain what actually happens with this. Before we get into that, this is a collaboration between us here at Nethermind, OpenGSN, with help from Vitalik as well. So the way this proposal works is that it introduces the concept of user operations. These are sort of pseudo transactions that allow you to encode whatever you want to do with your wallet, similarly to transactions. These user operations get created by the user willing to use their wallet, and these users are going to send it to a special user operation pool that lives above the normal transaction pool. This is going to be validated and then broadcast over P2P like normal transactions. then it's going to be picked up by entities called bundlers. These bundlers can be anyone. They can be miners, they can be MEV searchers, they can be you as well. These bundlers are going to take these user operations, they're going to bundle them into one transaction, vanilla Ethereum transaction, and include them in an Ethereum block like any other transaction. So an important thing to note is that the way bundling happens is that these bundlers route these user operations through a special entry point smart contract. Now, how does this actually work? So the bundler has their user operations. They call a special handle ops function in this contract. What it does is it goes through every single user operation that's being bundled, and it calls a special validate user op function in the wallet contract. What this does is that it allows the wallet to verify the signature of the user operation. It is probably going to implement some nonce mechanism, and very importantly, it's going to compensate the bundler for having bundled these operations. After it's gone through the validation for every single user operation, it's going to execute them one by one. But with this EIP, we also introduced a special new capability as well, paymasters. So instead of having to rely on your wallet paying ETH every single time, you can have your user operations sponsored by a paymaster. With this flow, what would happen is that first, the signature would be verified by the wallet contract, but it would not pay. Instead, a stake would be deducted from the paymaster, and it would be relied on to pay for the user operation. Afterwards, the user operation gets executed like any other, and then a special accounting function called post-op is called on the paymaster. So if you want to actually implement this interface, what do you do? Well, in your wallet, you have the validate user op function. This takes in a user operation, the request ID, which is kind of like a hash of the operation, and the required pre-fund. What you're probably going to want to do is validate the signature in whatever way you want. Important to note is that you can do any signature validation, right? An example here is ECDSA, like with normal EOAs, but you can use any verification that you want. Next, you're going to increment the nonce, and then transfer the required ETH to the bundler. Okay, when this validation happened, then we're going to go back to the entry point, and it's going to, after a while, call the wallet again. Specifically, it's going to call the exec from entry point function, and here you can encode whatever you want. You can encode multiple batched operations. Basically, this is up to the wallet what it wants to do. If you want to include a paymaster, then it's slightly different as well. The paymaster is going to have to write a validate paymaster user op function. This simply decides whether the paymaster actually wants to sponsor the operation or not. If you don't want to, you just revert. If you do, you let it happen, and you don't do anything special. And finally, the post-op would take care of any extra accounting. So in the case of the token paymaster, as you can see here, we're allowing the wallet to pay with special tokens. So in this case, for a validate paymaster user op would check whether the user has enough of the tokens, and the post-op would deduct and swap the tokens for ETH and pay the bundler with that. So why is this good? Why does this solve the problems that we've outlined before? Well, most importantly, I think, we get account abstraction now. As Ansgar mentioned in his previous talk, there are lots of EIPs that are going to be included in the future forks, and there's very little space to play around with these sorts of utility EIPs. This means that since this EIP doesn't require a consensus change, no hard fork required, we can include it right now without having to rely on core developers to implement the proposal. We're going to incentivize smart contract wallet adoption. As mentioned before, EOAs suck, right? So the more UX benefits we can bring to smart contract wallets, the better. And we believe that this proposal is going to allow for lots of amazing composability. Following on that point, this provides a universal and widespread interface. What this means is that special dApps can now make their own paymasters, and they can interact seamlessly with but wallets that implement the interface as well. This means lots of sponsoring and lots of cool new use cases for Ethereum users. Custom signature schemes. As mentioned before, whatever you can code in Solidity to verify the signature, it can work, right? So instead of relying on ECDSA, we can already rely on more amazing signature schemes like BLS, or even post-quantum safe ones like, for example, Lamport or Winternit. Paymasters. So paymasters are remember, are the things that sponsor user operations. They allow for lots of cool use cases. As shown before, you can pay with tokens instead of ETH if you use paymasters. You can also withdraw privately from ZK mixers. So Tornado Cash right now relies on their own relayer system to allow you to withdraw anonymously, but they are looking to move away from that as well, and this is a great mechanism for that. You can do very wacky use cases as well, like paying off-chain with a credit card. So imagine that you have a paymaster which holds a special private key behind some cloud server. And if you go through their Stripe API and pay for the user operation, they'd be willing to sponsor your operation for you, right? So you wouldn't even need to hold any tokens, or let alone ETH, to transact on Ethereum. This would be very useful for interfacing more with the current financial system as well. Since we're working with smart contract wallets, we can do multi-operations. So right now, if you want to do a Uniswap swap, you need to first approve in one transaction and then do the transfer and swap in the other transaction, right? This is quite UX unfriendly, as we know. So if we use smart contract wallets, this all goes away. Decentralized. So since user operations are propagated using a P2P layer, there's no one central entity that's required and that's trusted for this to work, right? It's quite in line with the ideals of Ethereum, and we quite like that because of that. Incentive aligned. So bundlers, important to note, they get compensated for bundling user operations on chain. What this means is that we don't actually need miner support initially to make this proposal work. Instead, we can just rely on MEV searchers to take care of most of the work, right? So as we all know, if you've been to the Flashbot searcher Discord channel, they will devour any sort of profit opportunity the moment it gets there. So they're quite reliable when it comes to working in their own self-interest. So they're going to be good tools for this. Following on from the previous point, it's very possible to do a slow rollout. On Ethereum mainnet, miners are very hesitant to adopt new changes to their client architecture. So we wouldn't expect them to adopt this mempool logic and all this P2P logic initially. Instead, as mentioned before, we can get started with this proposal on mainnet with MEV searchers, and then as miners see that, oh wow, this is actually pretty cool, and we should use this because we can make money, it's still going to work. Future-proof. Ethereum, there's a vision in Ethereum to move away from EOA wallets eventually. As mentioned before, they're very restrictive. You need to pay with ETH, you need to use ECDSA, and smart contract wallets have kind of been in the vision of Ethereum from the start. This EIP provides a very good stepping stone for that. So imagine eventually if we replace all currently used EOA accounts with a default upgradable smart contract. Well, that eventual smart contract could follow the interface of this EIP and be incredibly composable from day one from its launch. So there's been a lot of talk about this EIP, but let's actually give an example of how you might use it. Say you have 1,000 DAI in your Tornado Cash, and this is what you want to pay with your transaction for. You have your wallet, which has 10,000 USDC, and you want to swap it for a Uni on Uniswap. Okay, so you craft a user operation and you send it to one of the compatible nodes. Right, it gets propagated using P2P, and the bundler picks it up, sees that it's profitable, and wants to include it on chain. Great. So they're going to call the entry point smart contract, and this is going to validate, first of all, that the signature is correct, and that the Tornado Cash is willing to pay for the transaction. Great. So now it's going to execute the wallet. Whoa. RIP. It's going to execute the wallet. Now your wallet is going to do its swap as it would. It might first approve the transaction, and then it's going to swap using Uniswap as you would normally. Then we see that this has worked. We did what we wanted to do. We swapped USDC for Uni. Now, remember, we have to pay the bundler for having included this user operation on chain. Okay, so the entry point calls Tornado Cash and the paymaster. And it's going to do another Uniswap swap to swap DAI for ETH, which is what the bundler needs. So we're going to get back ETH, and we're going to transfer it back to the entry point, which is going to compensate the bundler for their actions. If you think about this, this is like 10 or more separate operations. If you wanted to do this with EOAs, it would take you a lot of gas and a really bad UX experience. So this is kind of trying to show how much of an improvement smart contract wallets can give to the average Ethereum user. But what is the state of the EIP right now? Well, the EIP has two main parts, right? It has the entry point contract first. So the entry point contract already built. OpenGSN has done an amazing job with that. And it's currently undergoing an audit by OpenZeppelin, which should finish this week or next already. We're launching on mainnet straight after. We also want some software to support the bundling of user operations and the mempool behavior that we mentioned previously. So here at Nethermind, we've been working on supporting this EIP for our Nethermind client and for Geth as well. We have already built that, and our Gurley validator is already bundling user operations as we speak. So you can already test out this proposal right now. Okay, so we've talked about why EOAs suck, why smart contract wallets are better, the problems with smart contract wallets, and how EIP 4337 solves these problems. So what can you do? Well, if you're a smart contract wallet dev, consider trying to adopt this proposal and making your wallet compatible already with these interfaces. If you're a dApp dev and you want to sponsor users' transactions, consider making a paymaster, which suits your use case. For example, you could make it so that the first 10 transactions that a user does with your dApp get sponsored by you. Or you could make it so that they get sponsored if they hold enough of your special token, or if they stake some NFT with you. There's lots of use cases, and it's very custom because it's all written in Solidity. If you're a tooling dev, consider trying to implement some of the verification and mempool logic that we've developed in your libraries. And finally, if you're an Ethereum user, consider trying to pressure our friends over here at MetaMask and other wallet providers to start adopting smart contract wallet designs. And also, consider switching to smart contract wallets yourself. You might think that there's this extra cost that you're going to have to pay, but in the long run, if you hold any significant amount of funds in your wallet, it's going to be worth it. You don't want to end up like the people that I portrayed at the start with their bored apes that have been lost. So we're hiring at Nethermind. If you're interested in this sort of stuff, we'd love to have you interview. And yeah, I'm going to open up to any questions. Thanks.
All right, so if you guys can stand up and raise your hand if you have questions. Anyone? Okay.
Regarding the entry point contract, who deploys that? Or like, yeah, regarding the entry point contract, like who deploys that? Or will there be only one entry point contract or multiple?
Great question. So the entry point contract is going to be a singleton. We expect that there's only going to be one deployed on any specific chain at a time, because this results in better network effects for users, right? Since all smart contract wallets are going to be specific to a specific entry point, we want kind of composability with that, right?
Hello.
Thank you for the presentation. I have a question about the security issue. So if I was a Dev developer and then would like to use the entry point to sponsor my users, then so in that case, how if then some malicious people and just create some dummy or utilize applications and to, for example, drain some tokens or drain some sponsored tokens from this?
So you mentioned the security issue, but I didn't quite catch what specifically you were referring to.
Yes, like the Sybil resistance.
Sybil resistance, okay. Yeah. So that isn't that big of an issue, right? Because like if you want to, I'm not sure quite what you mean with that, right? Because what happens with this is that you would make your user operations specific to one wallet and one paymaster if you choose to use one. There's no real Sybil resistance. We have several security mechanisms that we put in place to stop DOS attacks, especially during the validation phase of the entry point call. But when it comes to Sybil resistance, I can't think of anything that might be of concern.
Hello. So what do you think are the incentives for big wallets like Argent or Genosis to adopt this proposal instead of running their own relayers? Because in this proposal, you need to pay an extra transaction fee to the people that are including the transactions in the entry point. So what is the benefit of Argent, for example, to include this EIP?
Okay, so one is more resilience, right? If they're maintaining their own relayer system, that's very risky for them. Second of all, maybe more importantly, it's the composability, right? Composability with other wallets and especially with paymasters. If Argent ever wants their user operations to be sponsored, or then they're going to have to adopt the interface, and this is quite a good UX bonus for the users.
I have a question on the scalability, or at least the increase in efficiency in these bundled transactions. Does it take less gas to make these more complex operations than doing them independently?
Okay, so you asked about the scalability of bundling multiple user operations. Yeah, good question. So right now the overhead per op is 26,000 gas. But there's also 28,000 shared gas in the whole bundling operation, right? So this shared gas would be divided by as many user operations as are bundled by the bundler. So there's a very good incentive for users and for bundlers to try and bundle as many as they can into one batch.
Who else had a question? Oh, you. Okay.
For a regular Ethereum user, what are some sample smart contract wallets that one can try today?
Oh,
it's louder and clearer.
Okay. What are some of the smart contract wallets a regular Ethereum user can try today?
What are some smart contract wallets that we're trying to?
No, smart contract wallets that we can try today. In case I want to try some of these, what should I look for?
I'm not sure I understand.
What smart contract wallets exist right now that you could play around with to work with this?
Yeah.
So none yet, right? Because we haven't completed our audit. But people like Argent and Gnosis Safe, they're already hacking on proof of concepts with this ERC. So you're probably going to see some soon.
Okay, that's all the time we have for questions right now. In a few minutes, we're going to have another speaker up, so we're going to change over. And yeah, just wait a few minutes. Thank you very much. Give him a hand, please. Thank you very much, Christoph.
So should I run all the way or just a couple?
Yeah. Just make sure. Did you say you had any links or anything?
Yeah.
You do have some links
Yeah.
you're going to open up?
Yeah, looks good.
Okay. And have you tried opening the links already?
Yes.
Okay, great. Yeah. Yep.
Oh, should I try to open the link now? Do you know how the control tab works here?
I think these windows are a long time. Not that one. Control tab. Yeah. It looks like you got it.
Yeah, but so to...
If you want, you can close that one right now. That spreadsheet, if you want. If it's in the way, you can close it and you can open it back up. If you want, you can close that.
Completely?
Yeah, yeah. I can open it back up.
Okay, but the thing is...
Guys about the road ahead for Ethereum light clients. He's an ETH2 core dev and contributor at ChainSafe, Lodestar on Ethereum consensus implementations in TypeScript and other things. He's an OG dev over at DAppNode and OS and hardware to advance decentralization, taking the complexity out of hosting nodes and dApps, amongst other things. So please welcome to the stage, Dapp Leon. Thank you.
Hello, everyone. So thank you for the... It's good, the audio? Thank you for the... Oh, sorry. The presenter mode is kind of broken. But it...
Sorry, guys, we have a lot of windows to manage here, and it's a little bit difficult.
Otherwise, I can try to survive with only that.
Just give me a minute.
It's okay.
I did have a question. How many people here in the audience are Web3 developers? Good. We had a bet, and I think I won.
Yeah, no. We are supposed to be the smart ones, right?
Yeah, exactly.
Hey, can't pull this.
What's the matter?
We lost the thing close to accidentally. No, we need to.
Go back down to here because you have to be on his, right? Just type in docs.
It's not in Google Sheets, Google Slides. For the spreadsheet, right?
Yeah.
That we closed.
Yes.
Maybe in history.
Yeah. Open up Chrome again. Open up Chrome, right there. Select him. I'll type it in. It's not there.
It's Google Spreadsheets.
Yeah. Go to docs.google.com.
Just give me a minute. We actually bookmarked it.
But where is the bookmark at?
Yeah, this one. Yeah, okay. Just give me a minute. I should be able to pull it up for you.
If we need, we can go a few minutes over because this is up against the lunch, so don't worry about it.
If needed, maybe don't do the link. I don't know.
Yeah.
Okay.
All right, I think it looks like we're good to go.
It's good now?
All right.
Awesome. Thank you for the patience. Yeah. So yeah, I was actually going to do a demo, and this is why everything is broken, so we'll have to skip that. Anyway, thank you everyone for being here. Dub Lion, I work at Lodestar. It's an Ethereum consensus client from ChainSafe. And I'm going to talk today about light clients. So I want to start by providing an example. So today we have a lot of L1s, and usually what they promise is this blazing, fast, scalable, decentralized future. But what we usually find in reality is this set of sporadic, non-committed users, which they connect to one single sponsored JSON RPC maintained by the foundation, then connects to this small network of validator cartels. Then you have to wonder, is this really the future of finance or just a replica of traditional power structures? Like, at least it's okay for now, in my opinion, but we definitely can do better. So what we are fighting for, decentralization, it's critically important because it gives this amazing property of collusion resistance. And to achieve that, we need to have a broad base of power distributed in different stakeholders, be users, exchanges, infrastructure providers. So if we don't achieve that, essentially the industry will start to condensate in these very strong, small cartels, and then bad things can happen. We are seeing this now, unfortunately. I'm not going to name what this represents, but you can imagine. So yeah, decentralization is really important, and to achieve that, we need to enable anyone to participate, anyone to fully verify the system, and anyone to fork the system. This one is critically important because in case that something like this happens, you want to be able to fork the system and reject this hostile takeover of power. So this sounds very dystopian, but Vitalik has been talking about this for a while. There is this amazing post he did, and he brings this example of the fork wars. So the majority of miners, exchangers, and explorers, they collude, and they then just mint this insane amount of tokens to a dev address, and they will maybe brand it in Twitter as developer fund to ensure the sustainability of the protocol or something like this. But it definitely goes against the will of the community, and it has to be rejected. However, if they control the majority of the stake or the power of the providers, they can disperse this value into the DeFi ecosystem, and it will be really, really, really hard to undo. Like for those OGs that you remember the DAO hack, we were really lucky that the funds were locked in a specific set of accounts for some days, so we could do a hard fork. But in this case, this would not be possible. So how do you prevent this? With more validation, people running nodes, and distributing the power such that this thing is actually impossible. And if it's possible, you want to create so much chaos that they will have to revert and return the power to the community. So it has actually happened, this. Who is familiar with Justin Sun and the Steam blockchain? Like, in my opinion, this is the most epic thing that has happened in crypto ever, so please look it up. In 2020, Justin Sun bought Steam, the blockchain, which is a network for content, and he took over some significant share of the network stake, about 20%, and then collaborated with exchanges, specifically Binance and Huobi, to take over users' funds and then get a majority of the stake on the blockchain. What they did is then boot all the witnesses that were not loyal and effectively control completely the blockchain. The community had no other in-protocol choice, so they just completely forked the blockchain into Hive and replicated all the dApps, all the providers, and everything, but they just left over the balances from Justin Sun and everyone that participated in the attack. Like, this is a really, really serious attack that, thankfully, it was survived, but it's a stark reminder that these things can happen. And we can think, oh no, Ethereum, we are better, we are really decentralized, and which is true, but Binance has a non-trivial share of balance in the Ethereum Beacon chain, so yeah, we just have to be vigilant. So yeah, you can participate. We must protect Ethereum, we must do our part, run nodes, evangelize for decentralization, stake at home, so all these things are really, really important. And what I'm gonna shield today is exactly that with live clients. So yeah, just food for thought. If Ethereum was under attack, like the one I saw with Justin Sun, where would you go to check the correct state of the network? I would go to Etherscan, but would that be part of the attack? I don't know, so yeah, run your nodes, do your part. However, running nodes today is quite expensive. Running ETH takes a significant amount of resources, be it disk, bandwidth, etc. And what most people end up using is connecting to a remote RPC. So in this chart, you can see cost on the vertical axis and security on the horizontal. Full nodes gives you the maximum amount of security. You validate all the blocks, the state transitions, so you cannot be fooled. With remote RPCs, you are just eating whatever Infura is throwing at you. So it's a huge trade-off. What we want to foster is this middle area where you have to pay a small extra cost or some extra cost in exchange to having a greater level of security. So this is how I think it looks like today with the stakers I'm talking about. You have stakers, exchanges, explorers, stakeholders that are really concerned about the network. They will run full nodes. And then the sporadic users, the ape boards users, they will just connect to the remote RPC. And then you have these super users, dApps, that they should be invested in being in this area, but currently they are not because it's just not possible. So what can we do? Oh, and by the way, we are still doing better than traditional finance. So no security and still costly. So I'm going to focus now on browser-like clients, which we are trying to fill this bottom space. So give some extra security to a remote RPC at not a high cost. So what is a browser-like client? When you connect to Infura, you are using the JSON RPC and just assuming everything you want. But if you want to validate all the data, the first thing you have to do is come to consensus on what's the head. This is what I call here with consensus, and it's the activity of acquiring a safe head. Once you have that, then you would navigate through consensus layer and then through the execution layer to get data, all the fun stuff, which balances, contracts, calls, and even go into L2 for sharding, but that's for the future. So you would use all these awesome in-protocol teams that have existed since Genesis to make live clients possible. If you are not aware, all the Ethereum team and even Bitcoin have worked really hard to make live clients possible. They have not materialized for reasons I will address later, but they are possible, and it's thanks to these things. So first things you want to do as a browser-like client is to get a safe head. Post-merge, the mechanism that we have to do that is with the sync committee. So if you want to track the head in a normal full node, you would have to follow the entire validator set, which is very expensive. But instead here you follow this 512 committee that rotates every day, and you can do that extremely cheaply with only 25 kilobytes per day. The committee shuffles in a way that it makes it really hard to be corruptible, and then when you sync, you can just jump from one to the other and get to the head. Then once you have a safe head, you can actually follow it with also a very low cost, about 81 kilobytes per hour. And tracking participation, you can also be somewhat safe from forks. So yeah, very low cost, high security. This is what we want. This is what live clients are about. So once you have a safe head, now you go into the consensus layer data, and you can get fun stuff like the latest execution head. You do that with Merkle proofs. And then you can repeat the same with execution layer, with state proofs. You can do fun stuff like get the account balance, the account nonce, any contract storage. You can also get proofs for blocks, and you can get logs and transaction receipts. So essentially, it is possible to cover almost all of the JSON RPC with these sorts of tricks. So to recap, a browser-led client, the first thing it has to do is consensus, get ahead. Here is the first step. This is the weakest one. It has a honest majority. You are not validating state transition. So if there is an attack, that the one I said before, you can be a victim. But the data size is bounded. And this is where, so far, we have only a transport for a REST API. But we want to build a P2P layer on top of this. Also, when statelessness lands, this assumption will drop to only one of them. So that's really cool. For CL data, Merkle proofs, you can be censored, but not lied, so it's a one-of-n assumption. However, the data here is really high, and it's unbounded. So we are providing a REST API, but we hope that in the future, Portal Network will help decentralize this layer. And the same applies with EL, where here the data is even bigger. So far, in Lodestar, we have built a REST API. This is done. We have a demo, the one I'm not be able to show. But we are lobbying for adoption in most clients. There is also a PR started by Status to have a draft on this P2P network. It's implemented. We're going to have some tests soon. And how it's going to look, maybe I'm going to glance over the details, but these are the routes. You can get snapshot to get started, some committee updates, and then you track with server-sent events. PR, we don't have EIPs in consensus, we have PRs. And this is how it looks for the peer-to-peer version. We have one gossip topic and a bunch of reg resp that cover what we said so far. For CL data, here we have only delivered an API. This is the route. You can get a proof or a multi-proof at any point of the state, at any state ID. The same for EL. There is the ETH proof with the IP. It's only partially adopted. So far, it's only Geth and Ethereum.js. But with this and Portal Network, yeah, the JSON RPC could be fully covered. But it still needs a specially tooled EVM where the async S-load. But I'm not going to go into the details. So demo time, you can imagine here we show a browser where we do this flow. You start with a trusted root. Then you go into consensus. You get some proofs, and eventually we show the status of an account.
We can get you to do the demo real quick.
It's okay, it's okay.
You sure?
Yeah.
All right.
So this is browser.clients, but there is even more fun stuff going on in this direction. On the top side, I put here statelessness, and this is the Ethereum 1x research that it's already included in Vitalik's roadmap. All these fun names, the merge, the Birch, the Splurge. So this is the Birch section. And what it's going to do is currently, if you want to validate the state transition, you need a block. In green, that's provided to you by the network. In red, it's provided by you. So this is why nodes are so expensive. They need so much cost. With witnesses, we will just shove some data into the block. So it will be a batteries included scenario. And you can validate a block only with the block. So the state requirement will be dropped, and clients could choose to either hold no state, some state, or all the state. So how it works is with some crypto voodoo magic. So before we had to get all the data, all the blue one you see here, not anymore. Now we have a Berkel 3 proofs with commitments and all this crypto stuff, so only one proof. And then, yeah, about the Portal Network. So this is a project by Piper Merian. It's a collection of DHT networks that will enable lightweight protocol access. This is critical for both statelessness and browser-like clients, and it's the solution we all hope that will decentralize the data layer. So how do we drive adoption? We have, again, this chart with these different users. What I want to see is to take these sporadic users from this shitty corner at the bottom to the right, give them more security, and then for stakers and other dApps, bring them down the cost such we have more participants. So yeah, what I'm fighting for is the progressive decentralization of the infrastructure layer. how it works now is we have all these wallets, which is cool. We have diversification, but there is still this huge trust implication here, and we want to drop it. So this is what I'm looking for. DApp developers, they are going to Infura, Alchemy. It's cool for now. This is not what we want. Stakers, please don't stake with Coinbase, don't stake with Binance, stake at home, but I know it's expensive. We are working on it. Same for users. So the blue lady is not happy, okay? She's not happy. And when to do this? So I think it's very important to remind people that decentralization is this thing that you don't see, but it's slowly going away until you have like this catastrophic failure, and then it's too late. So yeah, the time is now to do these things. So again, Vitalik did this great post. If you're aware, the Ethereum ecosystem is moving to a future where there will exist proposer, builder separation. What this means is that block production, it's okay to be centralized. We accept this. But this means that verification has to be more widespread than ever. So running nodes, having like clients, having as much nodes as possible, it's critically important. And yeah, statelessness, browser-like clients are essential to try to drive adoption and move as many people out of these untrusted remote RPCs as possible. So yeah, the end game is let's one-up our decentralization. And who are you gonna be? The Virgin or the chat? Just pick yours. So yeah, this was my presentation. Lodestar is hiring. Also, Lodestar is mainnet ready. It has been for a while. We proposed our first block in November. Now we have 151 blocks proposed by our own validators, also being run by the community. Really happy, good performance. You see that number, 99%. It's good. It's a happy face. So you can try Lodestar now. And yeah, if you want to subscribe to updates from Lodestar, screenshot this, or I will leave here for the YouTube stream. And thank you so much. I'm DappLion. Follow me on Twitter or GitHub. Thank you so much.
If you want to go back to the last screen real quick, just to give people the chance to snap a shot of that. And do we have any questions from the crowd? If you do, just stand up and raise your hand so I can see you. You would need to stand up. Yeah, okay, here we go. As well, if the demo slide is something that people can try out themselves, you could also go back to that slide. That way people can see the URL. Where are we at?
Hey, so about that thing of block production can be centralized, right? How centralized does it have to be? Because I'm thinking if they get censored, if they are stopped essentially. So it seems like a centralized block production isn't really that great either, even if you can validate it entirely.
Sorry, the problem is for here there is a lot of echo and the sound is coming from there, so I'm not hearing anything. Can you crank it up to the maximum? Put your mic on your mouth, literally.
Okay. Basically, I was just asking if centralizing block production can lead to other issues, for example, being censored by governments, by whatever, and whether that can be protected somehow by the fact that you validate the centralized way.
Yeah, I'm sorry, but it's impossible to hear. Maybe you can ask the question and I can stand in front of the speaker. Yeah?
Again, so is centralizing block production really that great? Like, can it suffer attacks from censorship, from stuff like that? So just there are no more block producers and there's nothing to validate. Okay.
Cool. Sorry so much. So the question was if block production risk the point of having centralization and censorship and no more blocks. Yes, that's correct. The thing is, the way block production would work is similar to how MEV is now. So block production will be delegated to some bundler, and as long as you only have one that is not corrupt and honest, the blockchain can progress. Like, there is active work on this, and I think what can happen is in the short term that could be some censorship, but immediately the blockchain could respond to that. It could see who was the bundler that caused that block to be missed, and it could reject from the set and switch to another. If all bundlers go rogue, then yeah, the blockchain stalls, but you only need one to be correct. And actually, the bundlers, they would optimize the network for a bunch of things, MEV, L2 stuff, but if they cannot participate, the validator could still propose blocks. They would be suboptimal, but the blockchain could still chug along.
Yeah, quick question around light clients and the impact that would have on the full nodes. So if everyone kind of moves over to light clients, who's running the full nodes, and then are there any security concerns, et cetera, with not enough full nodes being online, et cetera?
So the question was, if enough people move to light clients, is there any problem with not having enough full nodes? Yes, that could be a huge issue. The thing, I think what we are good is that now with proof of stake, there is a huge incentive by a lot of parties to run full nodes, and we are still really, really, really far away from having a distribution where we have too many light clients. So I would like to first get to a point that we say, oh shit, we have too many light clients, then what can we do? Because we are way, way, way away from this reality.
Any more questions? Right here? And if we could turn up the speaker's microphone just a tiny bit.
So do you think there will be in the future a trend with, for example, wallets integrating directly light clients? I think maybe 2 years ago there was a project called Mustekala, something like that. I think it was from some guys from MetaMask, but it was dropped. So it is something that could happen in the future. Do you know any projects already going on in this direction?
Yeah, so there are some initiatives. At the wallet level, I don't think so. This is what we are working on. I don't think there are the tools yet to make it a reality. Pocket Network, they do have some clients. I think one is the ultralight client, which can run in browsers, but they are still very dependent on constant connections with peers. So what I would like to see first is taking the centralized model of connecting to one single server and adding trust to it. That way you can, projects like Pocket Network, where it's still trust, but you have a multiplexing. So you connect to a random set of nodes. So being full here is harder. There is also a watchdog scenario. So if you can add these Merkle-proof strategies that could have greater resilience, then the next step is taking this to P2P. And that's where things get complicated. But Status team are working on it. There is a web RTC working group that could make a reality. So yeah, I would say first give a bit of trust to the centralized model and then move to P2P.
Any more questions? We have enough for one more question maybe. I don't see anyone standing up. Okay, great. Thank you very much for working with us. Sorry about the technical difficulties. We do have a panel coming up very soon, but we have to switch the stage over. So if you guys want to hang around or come back in about 10 minutes, that will be ready.
Thank you.
Yes. Thank you very much. Sorry, 5 minutes.
Do we have the next talk now?
We can go ahead and get the next one pulled up. No, let's not talk too loud. We'll go ahead and get the next one pulled up. But right now we have a... Yeah, close that one. Go ahead.
I'm going to actually make a Chrome shortcut for that page so we don't end up doing this. Okay.
Yeah, let's go ahead and do that. So that's on the desktop? Worst case scenario, you could open up a notepad on the desktop, but there should be a way to save it as...
Yeah, now it's fine. So Austin has he come?
Yeah, so, yeah, you're right. But you can go ahead and open that one anyways because, can you go back to the speakers real quick? Let's just look here. So we've got lunch. Panel 2 is at 14. 12:30.
This venue is
The panel is at 14?
That's 2 o'clock.
Yeah, but it said...
Okay, so the panel will be at 2 p.m. Sorry, guys, I cannot tell military time. I'm from America, so very sorry about that. But the panel will be at 2 p.m. So if you want to go ahead and grab lunch, that starts at 12:30, and then we will be back here at 2 p.m. for a panel, followed by Austin Griffith. Yeah, give it up for Austin Griffith. He's not even here, but give it up.
philosophies in the blockchain space right now. There's the modular blockchain design, monolithic blockchain design, and succinct blockchain design, which probably falls into the monolithic. So there's kind of these battles going on, and that's the state of the industry. And I think we all agree here that the modular design is the way to go. So that's kind of the way we see it, is we're focusing on the modular design, at least on this panel.
Hi there. My take is quite simple. I am from the ZK school, meaning we have to use ZK to do what we need to do. So we are constrained by all the mathematical constraints. So we have to play by the rules of physics. Essentially means the size of the proof and how much you can compute and how much overhead there is. So if there is a real breakthrough, we will have a real improvement. I don't foresee, I've been around for a while, 6 years in this BS of ZK. So I haven't seen, there have been lots of breakthroughs, but I haven't seen like breakthroughs that go, wow. So if something like that happens, yes, that'll be a huge change. Otherwise, same progress continues.
Hello. So whereas he's from ZK, I'm from an optimistic roll-up. So I take the opposite side. I do think that we realize very well that what the scaling bottlenecks right now are, and that we should contribute back to layer ones to improve data availability. At the same time, like the pressure today is usability. So it's a matter of staying closer to what users want, what they try and are familiar with. So I do think platforms that serve EVM in like a vanilla way, that's the thing to have.
Yeah, we are really excited with the whole Ethereum roadmap, right? Providing support, explicit support for rollups. Because once you start to scale data availability, right, provide great data availability, and combine that with the execution scalability of rollups, right, of these different execution environments, you start to have the possibility of creating amazing apps that were not possible before, right? That either need CPU-intensive computations or that deal with a lot of data. So really excited about the future. Yeah.
Sounds good. Let's move on to our next question. What are some difficulties and obstacles roll-ups still have to overcome? I guess this time we'll go from the other end.
Sure, yeah. So I think a big obstacle is composability. And people have been discussing about that a lot. Not only composability inside a single rollup, but also communication between different rollups, and the ability to like aggregate out outputs maybe, right? And try not to fragment liquidity a lot, because you have these different silos of applications, and they all have like money inside, and then you lose liquidity around. You have a lot of friction moving around stuff. So I think that's a lot of research to be done there, and that's a big obstacle.
Right, so with composability, we got ever-increasing complexity. And to solve for complexity, you cannot really always commit to an easier design or simpler option, but you can try and go for encapsulation instead. And I think this is where the modular blockchain design trend is coming from, where everyone realizes that all these Lego blocks fit together, but then once you try and build a giant castle of these Lego blocks, you're trying kind of like have a maintenance burden, and you want to limit how much of a burden that gets.
So I'm going to be the cynical guy in the crowd. I would say the market adoption thing normally gets really swept under the carpet. You can have the best tech, but generally speaking, because not all L2 pools are identical in that sense. The inter L2 is a very open problem. So there's this open market question. The biggest one wins in that sense.
Yeah, I would say just like the other guys, composability is pretty important. Standardizing on a ZK format, or so the ASIC market starts to form, and then just general adoption issues with UX, I think.
Yeah, so actually ZK in itself, it's super complicated, and just making it work like a full EVM, it's very complex. And then we have recently switched from a mindset of, is that even possible, to it's a matter of time, which is already a lot. But then again, I will also add that making it actually decentralized, it's a challenge, because even if the protocol allows for it, if you need crazy hardware requirements, it's again challenging as well to onboard operators for doing that. And then again, like if you have a lot of users, definitely there are going to be fees, and it will be profitable, and this probably will happen. But yeah, it's kind of a network effect thing.
Yeah, so one of the major challenges we're still facing is the cost of call data as well, to add on to what's been said. And that's where things like EIP 4844, which we'll be talking about in a moment, come in, but also data availability platforms like Celestium's from Celestia come into that space. And those are just now starting to reach maturity, and we'll see what happens there. Additionally, general purpose EVM compatibility is still kind of open. Optimistic rollups have yet to provide fraud proofs, and ZK, with the ZK side, ZK rollups, there's still the situation of reverting transactions and accessing things like message.value. So these are all open questions that are still being solved right now, and they're definitely technical blockers.
Thanks for your input. Since we have an audience of developers here, right? What are some unique propositions of layer 2 rollups that may appeal to interested developers? Or how would you recommend to a developer on how to choose which chain, which layer 2 rollups?
From the side this time? What are you doing back and forth?
I guess I'll come back to the side then.
Sure, yeah. So layer 2s and rollups are a way to experiment with alternate execution layers and execution platforms without sacrificing the security that Ethereum provides. If that's something that's exciting to you, of course, like jump right in. Definitely look into ZK rollups, optimistic rollups, and all the solutions available. One thing to note is that if, there's a lot of die-hard Solidity fans, and if you think that Solidity is the last word in smart contract development, I think we need to look at the general world of software engineering and see how things like Rust is currently upsetting C. There's a lot of disruption happening there, and there's a lot of improvement to be happening in that space. I myself work on the compiler for our language, so I see a lot of that space, and yeah, definitely pay attention to the trends and dive right in.
Yeah, so I would say that we are kind of in the opposite side. So we are actually going to opcode level compatibility with the EVM. And that basically means that developers will be able to use the tools that they are familiar with. So, Solidity compiler, Remix, like the RPC and so on. Which then again, I mean, definitely there are the space for alternative stuff. But on the other hand, by doing this, it's quite easy to migrate from layer 1 to layer 2. And yeah, we are also taking advantage of like the gas model and so on, that like beyond the programming language, it has a lot of security implications, and this has been battle tested.
Yeah, so I think the developers should start focusing on layer 2 UX, right, usability, and in that model you'd have to figure, like whoever's going to come up with the Web 2 usability, but in the Web 3 context, applied to layer 2s, is going to come up with some really cool stuff that's going to be worth a lot. So I think having the paradigm of Web 3 and layer 2 with EVM compatibility, the builders can start building in the UXs now, knowing that ZK EVM, a native ZK EVM is coming, and when that does happen, that all of their code will start plugging in. Like our partner project Mute, they started working on the ZK, an AMM, but they built the UX ahead of time, knowing that even though ZK Sync isn't released yet, maybe in the future it will be, because it's going to be Web 3 compliant. So all of their work will just work out of the box. So I would urge developers today just to start adding in the UX, thinking of layer 2s. So any layer 2 that's EVM compatible will just be composable off the bat.
I'd probably say something slightly different. Like, know your use case and know what you can do and what you have access to. A lot of the things that everybody says you can do, you can't do. A lot of the stuff I'm not going to name names and go through stuff, but I can tell you, as somebody who's played around with most of the things out there in ZK space, what you hear is not what reality is. That you will only understand that when you actually start using it the first time. Okay? And that learning curve is an incredibly steep learning curve. So look at things which are easy. Somebody has done it. Lots of things are using it. Libraries are available. The curves are supported. The size of the proof are the right kind of shape. And what you want to do, this is the most important thing. What is it that you really want to do? That the characteristics really map up to whether it's ZK or optimistic or whatever it is. And that should be your deciding criteria. And then, do you really understand it? Do you have the resources? And the rest of it should guide you to where you need to go to.
Yeah, I think you make a good point there, where there are really different use cases for layer 2, and not all use cases need, for example, a specific cryptographic property, or maybe they need some specific cheaper transaction format, or they need more data. There are all kinds of different use cases, and I think there are like programs like Layer 2 Beats and other websites that try and make a good comparison of everything that's out there. Shout out to Layer 2 Beats, by the way. They really try like compare security, compare the properties that all these platforms have. And over time, I hope that all these layer 2s improve. And I think that optimistic rollups, they will try and fit a use case that's more meant for like latency or like these faster computations. I think it's closer to what a machine bytecode looks like. Whereas ZK rollups, they may focus on faster liquidity event bridging.
Yeah, I also would like to echo this. I think it's very use case dependent. So like if you want to do a fast payment system, then probably ZK is for you. If you want to port an existing DeFi protocol that is running currently on Ethereum layer 1, then probably you should find an EVM equivalent layer 2. At Cartesi, we're trying to focus on CPU intensive computations. So all our technical decisions were focused on providing support to that. So we're optimistic. We have interactive fraud proofs. We actually have our own VM as well. So we wrote a deterministic RISC-V VM. So the idea is that you can actually, so the VM can boot Linux. So you can actually use mainstream software and all the libraries that you couldn't before, right? So if you're looking for flexibility, if you want to like do specific dApps that need those resources, then yeah, then Cartesi. But if you want to port something existing to the second layer, then maybe Optimism, maybe Arbitrum. If you want to do payment systems, then ZK. So it's very dependent on what you want to build. Yeah, there's a place for everyone.
Thanks for the input. And then the next question here is, so one of the more recent EIP that's being talked about quite often in the Ethereum community right now, it's EIP 4844 shard blob transactions. What are your thoughts on it?
So yeah, we are all super excited about the EIP, I guess, right? So it's a huge cost reduction for data. And it's exactly what rollups need, because rollups, they need the data availability, but for not necessarily forever. They only need to ensure data availability under layer 1 consensus for a period of time. So people can sync up, and you can like generate your fraud proofs. And after that, okay, if you need to sync up a dApp that is 6 months old, then someone can provide you that data off-chain. You don't need it to be running on everyone's node all the time. I also love it that it's compatible with, forward compatible with dunk sharding. So I'm really excited about the future of Ethereum, and thank you for the efforts on that EIP. Yeah.
Yes, so I won't show my own EIP too hard. I'm co-authoring it. Of course, I'm looking forward to data availability and increases. Like what we're all here for is increases in capacity. We are all specializing in these different use cases, all these kind of like Cartesi or like the ZK rollups. We all have like our different use cases, and I do think that once there's enough capacity, they can all scale a lot further and all like basically grow this Ethereum ecosystem that we're building. And then if you really want to talk about the EIP technicalities, you can find me after this talk as well, and we'll do more presentations about that in the upcoming DevConnect.
It's incredibly hard to actually talk next after the guy who proposed an EIP. So I say, thank you for actually putting the proposal and walking it through. I mean, I don't think I have much to add. The guy says, creates the EIP next to you, tells you what it is. There you
go. For me, I think what the context is, it's breaking down data availability into a proof of replication, which is what like Celestia is doing, and the archiving, right? And in the context, what we're saying with EIP 4844 is that the proof of replication needs consensus. You need to know that the data's been reached consensus on the data, that it's in an opcode, that the hash exists, and maybe there's a proof on that. The archiving, we're saying, it doesn't need consensus. When you store the data, anyone can store the data, and you can pull it up for censorship resistance. It's breaking up the problem into two separate parts. An order one assumption, one of n, that anyone can store the data in the world. It's the same assumption as you syncing up to a Bitcoin node, assuming there's going to be at least one honest person there. And so only the replication is used with layer 1 security in mind, which is really important. It's the devil's in the details there. So you don't want to assume an honest minority assumption off a separate ledger, but you're putting this on layer 1 and doing the replication proof with the assumption that archiving could happen, anybody could store. So that's the main thing. So I'm super excited about it because I feel like I don't even think sharding is needed. I think this is going to give enough bandwidth for hundreds of thousands of account updates per second, and potentially way more transactions per second. So for me, this is holy grail stuff, and it's going to open the doors to many new use cases that we've never thought possible before. Probably within a year or so, I'd say.
Yeah, I fully resonate with what you said. I mean, certainly there are many storage solutions like decentralized, but it's tricky to bring them to Ethereum in a trustless way. And so this construct is just fantastic. And furthermore, I would add that if this happens before, like if we don't have for the full Ethereum sharding, that would be great. Because, I mean, definitely rollups rely on cheap data availability to actually scale, or well, to make, I mean, it's like a storage, like more storage give you more throughput, cheaper storage give you like cheaper transactions on layer 2, and I mean, so yeah, you get the scaling there.
Sure. Yeah. To echo some of the sentiment that the others have said, it's obviously a great thing for rollups to have cheaper data availability. However, one thing that hasn't really been mentioned and hasn't really been talked about is that this does increase block size, and when you have an increase in block size, you also have an increase in centralization, i.e. a decrease in decentralization. This might not be a particularly egregious infraction there. However, we really need to decide where our priorities lie with trading off centralization, decentralization for transaction fees. So, yeah, I think it's an open question there. EIP 4844 is great for rollups, but we should start kind of asking these hard questions before it gets too late.
Well, that's about all the questions I have.
With time to spare.
Yep. Anyone got any question for the panelists? Oh, we got one over there. Let me run down.
First of all, thank you. My question is on offboarding from layer 2s. What are your thoughts on offboarding from layer 2 to the real world? And like, what solutions have you seen for that?
Is this a question specifically about bridging, or more so about liquidity providers to provide this fiat gateway?
Yeah, more on the second one. So how do you convert from layer 2 to fiat, basically? Yeah.
It's a difficult application layer question for the protocol devs. Great. So I do think that essentially all these layer 2s we're building with Ethereum in some capacity because we are trying to work with a more secure bridge to mainnet where all this liquidity lives. And as use cases grow, I think these gateways will generalize and like provide this gateway to every layer 2.
I think Anisha, something. Anyone have anything to add?
Any more comments? Well, I know like Bybit is opening up a fiat gateway with ZK Sync, and a lot of the exchanges are, there's a lot of money they can make. So I found the exchanges are just plugging them in, and as they come, they'll plug them in because there's so much incentive. There's going to be like a big, when ZK Sync comes out, it's going to be huge, and then they're going to plug in Optimism and Arbiter and plug in. They're already on exchanges, so I feel like the exchanges are, it's easy for them to see value and start plugging in these as deposits and withdrawals.
Yeah, and anyway, if you can make like fiat go to layer 1, Actually, rollups can achieve very nice bridges in the sense of that they can be fully smart contract based. So if you get your funds on layer 1, it should be quite secure to go to layer 2, and it shouldn't be quite complicated.
We have 1 minute left. Should we take one more question, or anyone got anything more to add?
Come see my talk later today.
What time? What time?
That's a good question. I think it is at 3:30 to 3:55.
Okay, I guess we can wrap up our panel here then. Thanks everyone for attending. And thanks to all the panelists, of course.
All right, all right. Yep, let's give it up for them one more time. Come on. All right, so we have another talk coming up, Austin Griffith, in about 5 minutes. We're troubleshooting one last little issue, but it will happen one way or another. So just give us about 5 minutes, and we'll start with that. All right.
Wow.
So. All right, so we went through a lot to try to make sure that Austin can present today. So give technology a big round of applause right now. So Austin Griffith is going to be talking about Web3 for front-end devs. He is a builder of Web3 hotness. You may know him from Speedrun Ethereum, Scaffold ETH. You're supposed to clap when I do that. Scaffold ETH. Nifty Inc., Biddle Giddle, ETH.build, Punk Wallet, and who can forget Gallias. He works on the Ethereum Foundation focusing on dev onboarding, mentoring, and tooling. And as a dev entering Web3, he is or should be the first person that you follow in Web3. You can check him out at austingriffith.com. And so now he's going to present from over here, but I'm going to hold the mic for him so that he can speak to you and run the computer at the same time. So give it up for him.
Yeah. Hearts.
Speak loud.
Thank you guys very much. Can everybody hear me? Can we do something here? Let's see if we can do a live demo. So what I want to show off is Scaffold ETH. So Scaffold ETH is a repo that helps you get started quickly building applications. If you go to the repo, you can go to, if you just Google Scaffold ETH, basically you're going to find it here, Scaffold ETH, right? And that is the repo. It's just, it's a dApp package that comes with everything you need with Hard Hat and React on the front end. So what I want to do is just basically build a quick little app. But before I do that, just to make sure that everybody knows, like the most important thing here is Speedrun Ethereum. I'm on Eric's laptop here, so hopefully all this works. There we go. Well, okay. So most important thing of the talk, if you know developers that are thinking about getting into Web3, if you are a developer thinking about getting into Web3, if you are a mobile developer, a DevOps guy, whatever it is, go to Speedrun Ethereum. It will help you onboard quickly. A couple of weeks, you can have the whole Web3 mental model. There's an intro video, and then you'll use Scaffold ETH to go through building a simple NFT, a staking app, a token vendor. Then you'll build a DEX, and it'll kind of get you into this little social network of other builders.
Full screen it.
Oh, wow, pretty wide. Cool, no, that's pretty good. The point here being, I spent a lot of time in mentorship sessions with a lot of developers from around the world, and I found what works and what doesn't, and what is a good way to teach the mental model for Web3. I think that this is a really good example. The staking app is probably the first challenge you'll take on. It's not going to be tutorial hell where it like guides you through everything. You're going to have to think for yourself and build a smart contract yourself, so you will need a little bit of Solidity knowledge going into it, but you can get that kind of up here and it kind of explains it. But building a decentralized staking app really is a superpower of Ethereum. Getting people who don't trust each other to coordinate, right? Getting jerks to coordinate financially is something that you can do with Ethereum, and this is going to teach you how to do that. It's just a few lines of Solidity. So, most important thing, if you're a developer, if you know developers, tell them to speedrun Ethereum. Okay, now that we've got that out of the way, we've got an extra 20 minutes. I can try to deploy an app, and we'll see how we do here. So here is when you get Scaffold ETH downloaded, you'll fire up Hard Hat with Yarn Chain. You'll fire up a React app with Yarn Start. And then you can just Yarn deploy all you want, and you can YOLO your app to localhost. Let me see if I can make that way bigger. There we go. So we're just deploying an app. Now if we go over here, here's our front end. So let me do that deploy again. Yarn deploy. I think I need to do a -- reset for, there we go. Let's force it. All right, so yarn deploy. And we're going to deploy another smart contract, and we'll see that show up right over here. So the second smart contract shows up there. And let's try that one more time. Okay, yarn deploy again. Now watch over here. We should see that. There we go, a new contract, right? So is that audio okay? Is that okay? Oh, get that mic out of here is what he said. Okay, So we're able to quickly deploy a contract, and then we can use an app to interact with it, right? So let's dive in and look at this contract real quick. We've got a string purpose, just some arbitrary purpose, and then we have a function called set purpose, right? And something really neat in there, thanks to Hard Hat, we've got a nice console log in our smart contract. Woo-wee. Okay, so then over on the front end, I'm going to grab some funds from the faucet. You'll notice that we're not using MetaMask yet. We're on localhost and we're using burner wallets. No worries about chain IDs or nonces or even using some of your insecure MetaMask, production accounts, right? We're just making a burner wallet and we're using it quickly. So I can say hello world here, and we are setting the purpose. Okay, so let's start writing a smart contract. Let's get into it. Let's see, what can we do here? Oh, let's show the console log real quick, right? Let me show that console log one more time. If I say, hey, 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 yeah, boom, and then we see the console log over there. That address said, hey, hey, hey. Okay, another thing I want to show is wallets. If I open an incognito window and I go to localhost 3000, I'm going to go to the app. You'll notice we've kind of got green guy over here, and then we've kind of got like old pink guy over here. Look at that smile. He's really smiling about something. Let's go ahead and grab him some funds from the faucet, and let's go and say, hey, I'm pink guy, right? Woo. Okay, and pink guy is also interacting with the contract. Green guy can go read that. So we're just showing that this is kind of like this massive multiplayer kind of vending machine that we can interact with anything. And also I want to just show that those burner wallets work that way, where if you spin up a new browser, you'll get a new burner wallet to interact with your app. So the key here is that you're able to make small changes over here in your Solidity and have kind of big results happen and be able to tinker with it over here in the front end and just kind of get a feel for things. So I would like to, I don't know, let's make a token. Let's see what happens here. Contract, I probably need to go to, let's see, Open Zeppelin, right? Token, contract, something like that. Let's go over here. I'm going to do lots of copy and pasting. The best developers do lots of copy pasting. Oh, this isn't going to take me to the GitHub, is it? Here we go, here we go. What I want to do is just bring in some token, and let's see. Oh, let's go, here we go. And then copy that, right? Okay, so, ooh, almost. Something like, oh man, I did it totally wrong there. Something like that, I think, is going to work, right? Oh no, Eric. Thank you. Okay, here we go. Now let's save that. What is this? Like is ERC20, and then we do like a little ERC20 over here, and this is going to be like Dubai coin or something like that. And DBC, huh? DBC. Okay, something like that, right? Let's see. Uh-oh, it's not liking that. Let's go ahead and yarn compile or yarn deploy over here and see what it yells at us about. Did I save that? I think I did. Okay. Oh no. Oh no. What did I do wrong? Oh, here, I'm sorry. There we go. Please work. Oh no. Here we go, here we go. This is gonna be it. Make us a token, please. Yes, okay, so now we've deployed a token, or we deployed a token locally. Thank you. It's 2020 and we deployed a token. So what you'll see here, though, over on the front end is that, a lot of this interface has changed. That dynamic interface has changed to have some new functions here. And that's pretty cool. What I want to do is maybe build like a mint function, and we'll make it payable, right? And we'll say something like, actually, no, let's just have people pay the gas, right? Let's just have a mint function that anybody can call. We're not going to set a purpose. We're not going to do that. But what we're going to do is have them mint something, right? We'll just mint to the message.sender, maybe like 1 ether, right? Something random like that. And then let's go back over here and deploy that. And you're kind of iterating back and forth. You're tinkering with your Solidity, you're kind of learning, you're testing your assumptions, and then over on the other side pops out another mint function here somewhere. There we go. And if we call mint, there we go. Now we can see that total supply going up as we're minting, right? Okay. And then let's see. So we're allowing people to mint. How long do I go for here? Oh, no. Depending on how much I'm going to. Okay, so we got about 15 minutes. Okay. So let's see. What else can we add to this to make it more interesting? Maybe like some require function that only lets people like mint today or something like that, right? Is the block.timestamp maybe needs to be what, like less than, we're going to have a now, right? We're going to have to track some uint 256 like public now or deployed, right? And we'll set deployed when we deploy it to the block.timestamp. Okay, and then we'll have to make sure that block.timestamp is less than like deployed plus 3,600 times 24 or something like that. Totally just dogging this out. Who knows what'll happen? You know, happy little trees and whatnot. Just kind of putting something together here. Just showing you that you as the builder, you don't have to be a genius. I am not a genius. You can just get in here and start tinkering around and kind of learn Ethereum as you go. So now, I'm guessing that our mint function is only going to work for the day. We let people mint something. All right, let's go back to that idea of that purpose and setting the purpose. So I'm going to redo that. You know what? I'm just going to do this. This is going to be crazy. I'm going to undo a whole bunch. Boy, I hope I don't mess this up. I want that set purpose function back, actually, now that I'm thinking about it. Oh, please don't mess up. Okay, what I want to do is I want to have maybe a set purpose function now, and I want to set it up so the user has to burn, right? Let's see, let's have them burn from message.sender one of those tokens. Okay, so you can go to the contract and you can mint some for just basically spending the gas. And then anytime later on, like this is only going to work for a day, but then anytime later on, we allow someone to get in here and burn one of their tokens to set the purpose. So we have like this, maybe like this attestation machine that we're building here that we charge people some tokens to use. And let's see if that works. I probably am not going to add anything more to it. If I had my own laptop, I would probably have some other examples that I could copy and paste in here and do things a little bit wilder, but I feel like just to be safe and make sure I get this thing all the way to production, I think that's about the end of what I want to go with. But let's test it first locally. I should be able to mint a few. We should be able to grab my address here and check my balance of. You'll notice how like there's this nice blocky preview here, and when I click that, I can see the result. You probably can't see it, but it says 3 ETH right there, right? And if I go mint another one, so we're going to allow people to mint for a day. If I wrote the code right, not sure if I did, but they should be able to mint for a day, and then at any time in the future, they can go to the set purpose function, and they can say hello, and it should burn one of their tokens when they do that. So now my balance should go down, and let's make sure that works. Ooh, yes, very nice. Okay, so our app is working. Now, you wouldn't normally give your users this clunky interface. You would spend some time building out an example UI. You'd spend some time like creating controlled state within React. We'd probably show your balance and do a lot of other things. I'm just going to assume that there's a lot of React developers out there and you could shred through this and whatever you want, and I'm just going to give us this ugly UI to play around with. But we have our set purpose and we have our mint. I wonder if I could even, nah, it's not even worth it. Okay, let's put this thing out into production, okay? So what we need to do, so now that you've tinkered around and you've got your app ready to go, it's a really kind of a short step to go to production from Scaffold ETH. We'll need to yarn generate an account real quick. What network are we going to go to? That might be the other question. I need to have some ETH on some network. I might actually just try mainnet, unless anybody's like, hardly against that. Any hard no's on mainnet, or should I go for it and see what happens? Okay. All right, so here's yarn account. So what I did is I did a yarn generate. Now, I saw a demo yesterday where they were passing around private keys. You really shouldn't be passing around private keys. Scaffold ETH will create a mnemonic for you within your directory. When I do a yarn generate, I've got a mnemonic here. All right, now I'm going to use a Punk wallet. Punk wallet. If you've ever been to punkwallet.io, you get a little nice, cute little deterministic punk. Here, let me show it. Punkwallet.io. You get a nice, like, deterministic little punk here. Look at that. And then you can kind of scan that, and when you scan that with, let me try, is this going to use my camera? It's going to use your camera? All right, here we go. Oh, you have to do, hello. Hi, everybody. Hearts. So here's my Punk wallet, and if I show it, there it is. There's my little zombie. So we can see that I'm sending some money from this Punk to my little zombie. But what I'm going to do is I'm going to do that same thing here. I'm going to scan this QR code, and I'm going to send like $150 right now. Boom. Okay. Just send $150 on mainnet Ethereum. Okay. Now I'm going to assume that will go in a little bit. We'll wait for that block to get mined, and then what do? You yarn deploy -- network mainnet, right? Mainnet. And let's be a little bit more surgical about our gas usage too. How do I see the files here?
Top left.
That one? There we go, got it. Let's get into our hard hat config, and I think there's like a mainnet. What's mainnet gas at? Anybody got the mainnet gas going on right now? Maybe like 40 gwei should be safe, right? All right, here we go, ladies and gentlemen. Yarn deploy mainnet. A contract that we just wrote out. I just installed Scaffold ETH on Eric's computer. We just wrote this contract out. Now we're deploying to mainnet. We've got a transaction hash. That's a good start. All right. So you'll have to make one other change. We did that -- network. Now what we need to do is our app is still pointed at localhost. So we need to make one other change here, and we'll change our front end. We didn't spend a lot of time in the front end, but the front end is here, and you can spend a lot more time getting your UI looking right. But the one thing I'm going to change is I'm just going to point our app at mainnet. And before I do this, I want to come back over here and talk about this for a second. So see this address? This is an address component in Scaffold ETH. Anytime you build a decentralized app, you're always going to have addresses that you want to display. Anytime you display an address, it has that nice blocky preview. It has a nice copy. But this also goes to a block explorer. I have no idea where it goes on localhost. Actually, it goes to Etherscan. This isn't going to be a very good demo. If I were to switch to Optimism or something here and hit save, I'm going to hit save, and it's going to go to mainnet, and nothing's going to change because it was already going to mainnet. But if I were to set this to Optimism or Arbitrum or Polygon, and then I were to click this, it would take me to the Polygon block explorer. So by changing this one thing in your app, you point your whole app at that new network, and all of the address links and all the things that are network specific switch over to that new network. Okay, so our app is actually ready, and it's on mainnet. I'm guessing our contract is on mainnet. There she is. Woo-wee. Okay, so we're halfway done, right? If you're cool enough that you can deploy a contract and people will come interact with it on Etherscan, like if you're DOM level cool, but most of us are not DOM level cool, we need to also build an app that goes along with it, right? So how do we get this app into production? Well, we need to yarn build, right? We need to get a static version of our app going, and then I'll push it up to Surge or something, and then everyone out there, if you want, you could get on and actually mint some of these tokens and hit our attestation machine. So let's see. Maybe I'm going to give this burner wallet a little bit of mainnet ETH also. So let's jump over to, unless we want to use MetaMask. We'd have to use your MetaMask. I don't know.
I got Flask installed. It's a test.
Oh, okay. Let's not mess around with it then. Let's go all burner wallets. Shout out to MetaMask though. At this point, you really want to use MetaMask. You should not be YOLOing ETH on mainnet with a burner wallet. It's just not, like, it's just made for not mainnet networks. But we're going to go for it just to see what happens here. Okay, so if I send like $65, sure, go. I'm going to send $65 for my Punk. Oh, I've got like a base fee error. That was super weird. We may have to use a MetaMask. Let's try that again. Not 1,000. It sent fine to that other address. I'm not sure. I'm getting like a base fee error now. I wonder if
I've done something really wrong here. Do you have mainnet Ethereum in your MetaMask? Should we connect it? Let's try it.
You need money in it?
Yeah, I can send money. Well, I thought here. Yeah, can you type a password real quick? No looking, no looking. Sound it out. How are we doing on time here, too? 7 minutes. 7 minutes.
You can take a few minutes, actually.
Doxed. Sorry.
This is in my test wallet.
Okay. And it's like, oh, it's like this nice little, hey, you have the wrong network selected. You need to be on mainnet. Cool. We'll prompt you to go to mainnet. Awesome. Do you have any mainnet? You don't have any mainnet dollars? Let's try. Let me try sending you some. Let me try redoing this. I don't know why it didn't let me send it at first. Let's try sending another hundo. Please work, 4th try. I think it did. I didn't get an error that time. Yeah, there we go. Okay, so we got a hundo coming in here to your MetaMask. I'm just going to assume that's going to happen in a little bit. Okay, so what do we need to do? We need to call the mint function. So as soon as we have some money, we're going to call mint. Oh, our app is ready. Okay, so we did a yarn build. Now I'm going to do a yarn surge. -- domain. What do we want to call this thing? DBC coin. Oh, man. Dubai coin. AI coin, surge.sh. All right, now normally you would also push this to IPFS. It's not really a decentralized app if it just lives on Surge. Super secure password. Let's see if this works. All right, now our website is actually uploading. You would want to upload to IPFS and other places. You would want to give, uploading to IPFS and giving everybody the IPFS CID would be like the way to go here. But we're going to also upload it to Surge, and we're going to have the website ready to go for anybody who wants to visit it. So now you should be able to go to dubaicoin.surge.sh on your phone or laptop or device of choice, and you should get the app that we just built in the last 20 minutes on Eric's computer. There it is. Okay, let's connect in Eric's MetaMask again. Okay. Actually, no, let's do Wallet Connect this time. Let's Wallet Connect in. Here we go. Connect, Wallet Connect. Let me bring in my rainbow. Let's just open up the ecosystem a little bit here. And let me scan. After I send $100 to your wallet. Let's see. So it's thinking. Pedro, it's thinking. Pedro, it's still thinking. Wallet Connect. Uh-oh. We might be switching back to MetaMask. It might be the internet, though. It might not be. Let's see, turning off Wi-Fi. Let's try that one more time.
You can take a few extra minutes if you absolutely need to.
Sorry, bro.
No, it's fine.
Here we go. Let's try connecting in with Wallet Connect. And let's use our rainbow. Please work 2nd try on a different network. It's still loading, Pedro. Somewhere between Mike Demarai and Pedro, I shaky my fist. And probably just the internet, right? It's probably not either of their faults, but it's fun to throw blame around, throw shade. Okay, I can't get it to work. Let's go back to Eric's MetaMask. And there's $100 on it. Let's go. Oh, I didn't even need to type in a password. Why didn't I just do that? Okay, so now we are at dubaicoin.surge.sh. We have our ugly UI that we could make look a lot better. Eric has a balance of 0. Okay, and let's go down here and call the mint function and pay some gas. All right, what's it going to cost us? Woo, $6. Totally worth it. Totally worth it. All right, so you have the next 24 hours to mint Dubai coin at dubaicoin.surge.sh, and then you can use that Dubai coin as an attestation coin to get back onto this website and go to set purpose. And each time you set the purpose, it's going to burn one of your Dubai coins and set the purpose for everyone to see on dubaicoin.surge.sh. And we were able to do that really in about 20 minutes. So this is for rapid decentralized application prototyping, right? There's so many times I spent weeks or months building an app, working on getting a smart contract just right, handing it over to a front-end developer. They spend another few weeks getting the user experience and the UI right, and then you give it to your customers and no one gives a hooey about it. So you really want to get your product to market and get it in people's hands first and see how it's used. Right now we're spending a lot of time with DAO tooling. DAOs are decentralizing and they need sufficiently decentralized tools and they need them yesterday. So we're building all sorts sorts of weird things to like give tips out to everyone in the DAO, or buy a beer for everyone who signed on a multi-sig. All sorts of like little tools that we need to make decentralization work and make DAOs work. And so that space is just growing rapidly. And instead of spending 6 months in the dark building a DAO tool, you should be spending 6 days with Scaffold ETH, building a couple different prototypes and see what people need. Okay, did our transaction happen? Let's check and see if we have a balance now. Oh yeah, we got one. All right, here we go. I'm going to set the purpose to the most important thing here is speedrun Ethereum. If you have developers that are interested in learning about Ethereum, if you have Web 2 developers, anybody who's good at programming, they can go to speedrun Ethereum and within a week have most of the mental model. And it's a very straightforward, quick curriculum. Let's see old speedrun Ethereum one last time before we're done. Remember speedrun Ethereum. I'm memeing it into existence. You're hearing me. You're getting sleepier. Speedrun Ethereum. Okay, awesome. I bet that happened. Oh, we're still waiting for the purpose to get set. But holy moly, we just built and deployed a smart contract to mainnet, and then we built and deployed the front-end application that talks to that mainnet contract and put it on a public URL, so anybody in the world can now go to that for the next 24 hours and mint that coin, and then use that coin for an attestation for some reason. I think there it is, it's set. Speedrun Ethereum, the purpose is good. All right, I think that's it. Thank you guys.
Give it up for Austin Griffith.
Thank you guys. Hearts, hearts, hearts. Speedrun Ethereum.
Yes.
Scaffold ETH.
I do want to say something real quick, is that I started working in Web3 back in October, November, and the first thing that I did was watch a few of his videos, a couple of Nader David's videos, and I hit Speedrun Ethereum and started just working through all of the different examples. And hey, I got a job at MetaMask, and I built a dApp for ETH Denver, and built a workshop for here. I mean, he's not kidding when he says if you don't have a lot of Web3 experience and you go and you spend some time on ETH Speedrun, that you really can get up to speed in like a week or so. It's not a joke. So again, just one more time for Austin Griffith, and we're going to take about 30 minutes break so all of you guys can do what you need to do.
There is a QR code for the app we just built.
Yep, that's the QR code for the app that we just built. Also built on ETHBiddle. If you want some entertainment when you leave here, go onto YouTube and search for Austin Griffith ETHBiddle and watch the little demo. It's like 5 minutes long or something, maybe even less than that. And he runs through how to use this thing, and it's amazing. If you think what he was just doing right now is pretty cool and that he's a funny guy, you'll leave that video having a lot more, I don't know, you'll think he's even cooler.
Thank you,
A
Eric.
Dawn, right?
Thank you so much.
All right.
Thank you, Patrick, too, for having me.
Yep. Thank you
guys.
everybody, and we'll be back here in
guys.
30 minutes.
Thank you.
Hopefully with someone presenting up there. Whoever lent me their dongle, if they want to come up and get it, if they haven't got it already, I think I have it up here. Hey.
Check, check. You still have 3 minutes.
All right. Hello, track one of ETHDubai. So we have another speaker coming up. He's going to be talking about Web3 front-end pitfalls, why wallet connector hooks are tanking our code quality. His name is Gabriel Rodriguez. You can find him at Grad220 on Twitter and GitHub. He's a core dev at Sushi. He's a connoisseur of degen wine and something of an influencer himself in the Ethereum community. So joining us from, I think, Berlin, let's welcome Gabe Rodriguez.
All right. Howdy, folks. Yep, my name is Gabe. I'm one of the core devs at Sushi doing all things front end. So for those of you who are developers here, this is going to be more of a kind of technical talk. So if you like things like related to React, state management, React hooks, and the pain associated with it, this talk is for you. I have a theory. Depending on when you created your web app, the distance from when DeFi summer began determines how happy you are with the app. If you're me and you're working on one of the OG protocols, our web apps are quite painful. And here's the ultimate question I'm trying to get at here. How do we make our Web3 apps more sustainable? How do we make it so that when we're creating apps, they have longevity to them? The developers want to work on them for long periods of time, and this is what this talk is essentially going to be about. Kind of a quick aside, in the Ethereum world, we're really obsessed with client diversity, right? But us front-end devs, when we go to grab a framework for a Web3 app, what do we grab for, right? React, right? And not just React, we're probably using Next.js, and probably not just Next.js, we're probably deploying Diversal. Huge diversity here. Actually, I wanted to verify that in some extent, so I went through the top protocols on DeFi Llama down to the top 100, and yes, indeed, 84% of us are using React apps. Now, we could probably go through the implications of what that means is that there's not a lot of diversity with our web apps. However, for the most part, you can rest assured if you're a front-end dev in this space, you are experiencing pain in the same way that many of us are. Kind of as a side, I actually sent these apps to the Build With API, and there's not a ton of diversity as it relates to hosting, and even worse when it comes to DNS. All right, let's get back. You're starting a Web3 app for the very first time, and I have a theory, which is the destiny of your web app is highly determined by the conditions and the defaults that you set as you actually first bootstrap it. A lot of us are using, what, CLIs, right, to bootstrap our Next.js app. We're adding some TypeScript to it. If you're developing without TypeScript nowadays, you're probably doing something extremely reckless. However, read the fine prints, please, in your boilerplate code. TypeScript strict mode is very often off by default. TypeScript strict mode. If you're not familiar with this, this is a whole collection of rules that basically make TypeScript TypeScript. And the fact that this can't even be off astounds me. But this one specifically, strict null checks, is one that you really, really need to have. Here's an example. We have an interface, dog. It's got a method bark. We're instantiating it, and we're calling bark. Should this compile? Any thoughts? You know, without TypeScript strict mode, it will happily compile. With strict mode, of course, it should blow up, because this should be possibly undefined. Please set very strict defaults, the strictest of strict defaults as it comes to your Web3 apps. This is a riveting talk. I got one like on this. You could be the second. Please, when you're bootstrapping your Web3 app for the first time, use the strictest of defaults. This will come to bite you if you don't. It's very simple. Go to your TS config, add in true. When I first joined Sushi, I did this, and boom, the whole thing somewhat exploded. 1,500 type errors in our main app. These are 1,500 runtime errors, bugs. How do we fix this? Well, we can go one by one, right, through each one of these, spent an entire engineering month to fix this, or we could do kind of what we did, go through and spend an entire day commenting out the code with something obnoxious that says, please, please fix this to get our app to compile. At the very least, this ensures from that moment on, these type errors won't creep in. Please get some strict defaults. All right, for the rest of this talk, it's going to be Gabe's rants on why he hates hooks. We'll get this. However, let's go back in time to the MVC world. Does anyone even know what that means anywhere? Has anyone even worked on a Django or PHP app in here? Okay, someone knows what that is, right? So the back end was this like atomic unit, right? The unit of which all of the business logic in our app was contained, right? And it did things like call backends, call the database, and then you have the view layer, right? This very thin layer that's only job was to collect data from the back end and display it. Now in the Web3 world, we have our back end, smart contracts. Why would we need anything more than this? And we have what we would call a small web app view layer, right? It should be only responsible for querying the blockchain, sending transactions, rights, requests. It shouldn't be big. Should it? Should it? My God, our web apps in this industry are colossal monsters. They're single-page, client-bloated nightmares, let's be honest. We're not in the best of states. Now, what are we trying to do when we're creating a Web3 app? Yeah, we're trying to query the blockchain. We're using some of these libraries. We're using some of these providers, these web wallets. We want to authenticate transactions by sending authenticated requests to the blockchain, and we have these helper libraries. In fact, some of you might be here working on some of these helper libraries. Thank you for that. But this is a new authentication primitive that only we in the Web3 world, in the front-end world, are currently dealing with. It's something new. And authentication in the back-end old world, MVC, was something more simple, right? We get a login page. It gives us a cookie back. We then send authenticated requests with this cookie, and our back-end says, yep, this person can actually get the data. Somewhat simple. But now we've got, in the smart contract world, this little sidecar attached to our applications, a client-side authentication primitive of which we're deriving the wallet state. We're issuing queries. It's serving as our transport and authenticating the user. It kind of gives us a logged-in state. So we have these helper libraries that us front-end developers are using, and they're exposing something with it, right? They're exposing React hooks. Well, let's talk about React hooks. If the central primitive of which all app state is being derived from a hook in your application, and you might know anything about React hooks, only hooks can call other hooks. So you have hooks calling hooks, calling hooks, calling hooks, and your entire application then becomes a state monster basically derived from the central primitive, authentication primitive of a hook. Why is that a problem? There's a lot of reasons why that is a problem and why Gabe has a beef with hooks. One, it's making us into worse developers, honestly. It's introducing new and odd programming patterns that we've never really had to deal with, and it's a little bit unique to Web3 that our authentication primitive is making us do this. What you can't do, this is an example of what you can't do, right? You can't conditionally call it. You can't put a hook in an if clause. You can't loop over hooks. We find some very odd patterns for us trying to get away around this fact that we can't loop over hooks. You can't do this. You can't put it in the JSX. It can't be called when you want it on demand once. It has to be at the top level member of your component, and in theory must be running every time it re-renders even though you need it once. Very odd patterns. It can only be used in React context as well. You can't use it in your state manager. Another reason why Gabe doesn't like React hooks. Here's an instance. Yep, this represents a value of a token that we're trying to get, and if again, it's hooks, calling hooks, turtles all the way down until you get to the central authentication primitive. Now, what if we have many of these examples, many of these components? Are your hooks being intelligently shared, the instance? Anyone know? Is it reusing the instances in the memory? No. Every component gets their own copy of their React hooks, and they're isolated. And that causes you to go to the Performance tab, and I challenge anyone here to be able to understand what these hieroglyphics mean, but it's bad. Like, took very long. I have an M1 Mac. This thing could put a man on the moon with ease, but it can't run my web app. Use memo. You forget one use memo somewhere down this hook train, it is punishing. and it will punish you. Hard to test React hooks. I run just coverage on many of your apps, and your coverage is not very good either. If you have so much state bound into the hook world, it is very difficult to test, and this is embarrassingly low code coverage on one of our apps. Very often we're console logging, right, in our components, in our hooks. Why are things re-rendering? We're trying to be a detective, very difficult with hooks, and essentially it boils down, what I'd say, to this. We are not properly thinking through the separation of concerns. There's too much stuff in our components. Our components are too smart when they should be dumb. All right, so what should we do about this? Well, if the chief issue is that our wallet state, our authentication primitive, is being injected and tied to the React render cycle, let's get it out. Let's inject it into our state manager. Let's put it in a state that is completely agnostic. It doesn't matter, it's vanilla JS. It could be used outside of the React context. This would be far more ideal. And now it's not so profound that I've come up here and basically said you should be using some state manager. But let me say that all of these patterns here represent vastly superior paradigms for managing your wallet state, composing with your wallet state, deriving data from your wallet state. You got the Redux global store, functional paradigm, you got the MobX, mutable classes, recoil, you got atoms and selectors, state machines. All of these are better to be handling your app state than being stuck in React hook world. What should your components look like? In my opinion, if you look at a component like this and 80% of it is basically the JSX with state being injected at the top, this is what your component should be like. Now if you go and look at your component and way before you get to the JSX, you have a ton of different stuff doing business logic in your component, I would say that is a code smell and you're doing something wrong. Yep. Why is this a problem though? Why can't we do this right now? Well, as we said before, the way that we're interacting with our web wallets are reliant upon hooks, and they cannot be injected into a non-React state. So if you're working on one of these libraries, if the chief outcome of this talk can be anything, is one, please, 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 do not be making your web wallet libraries natively in React. Please make them framework agnostic, vanilla JS, and then at the very last second, then you can expose your React hooks. And even better, please expose your stores. Expose your stores in such a way that we can subscribe to them. And even better, we can inject them into our own state manager. So that allows us to compose from that layer, not the deep view layer. A couple of us at Sushi are running into this issue, so much so and painfully so that it's not sustainable in our architecture, that we're working on actually creating adapters that allow you to take Web3 React and use it outside of the React context and actually any type of state manager that you're using. Here's an example of ZooStand. All I want is to be able to compose within ZooStand. Please, if you're working on one of these libraries, expose a ZooStand slice that I can just put in, and then later and separately, I have access to that. I can compose within the non-React world. Now, if you want to be doing this, transitioning yourselves to the composing within state managers, here's an example of what you could do. You can write a component whose only job is to run the hooks of your wallet and sync them to your state manager. It's a little bit of a hack, but it does work. And then you tell the rest of the developers, never use these hooks again, compose at the state manager level, please, please, please. Now we're going back to the central premise. How do we write more sustainable web apps? This might not be super popular among front-end apps that, you know, IPFS, it must be pure JavaScript, you can't have any backends. I would contest, right? There's certain things that backends allow you to do that front-ends really shouldn't be doing. Super heavy client-side work. Also, all the work that's being done in our huge bloated front-end clients are not being shared, whereas backends can do HTTP caching. And I would suggest to you that we can evolve our thinking a little bit on this, right? That I think we can use a backend, for example, Next.js serverless functions, I would qualify that as some degree of a backend, for the sake of that it's easily deployed across many different services. right? I would kind of qualify that as, yes, you should be using that. We should open our hearts a little bit and count that within the centralized, decentralized camp. I would even say that if you go as far as making a Docker image that represents your entire application, there's so many different platforms that can deploy Docker images. Please, let's consider a separation of concerns and consider using some of the backends. I was checking out this tweet from one of the engineers on Lyra Finance last month, and he also said something kind of interesting. And we're talking about the idea of us in this industry are not managing wallet state properly. And there's ways that we can evolve our thinking on this set. He's basically saying, why do we need the wallet at all, right? If the wallet only exists to issue write transactions, every other use of it, which is reads, let's not rely upon that context. Let's use our own node provider. Really, really thoughtful. Saw this tweet from last week. This flash of when it says connect, and then it turns off, right? It's kind of annoying for a user. It's even more annoying, especially when I go to an app and it makes me log in with my web wallet before I can even use it. Please stop doing this, right? The reason why we're doing that is that our philosophy and our coding patterns on the front end as it relates to managing state is not developed enough. We can do better. As far as Sushi is concerned, we're also thinking about this, right? How do we manage state better? What if we make the state of the application more stateless? Let's inject the chain ID into a subdomain. Let's inject a address into the URL. That's an idea. Another idea is considering going old school. Why don't we cookie the user once we understand the state of the application, and then perhaps even using local storage. That could be, an option as well. Regardless, all of us, and I'd love to talk to some of you after this about how do we make our web apps more sustainable, and a key answer to this question, and my assumption is we need to manage the wallet state better. Yeah, thank you.
All right. Thank you very much, Gabe. I would like to talk to you later because I'm working at MetaMask and developing a lot of applications for developers and giving them best practices on how to build dApps. And I have a lot of the same thoughts that you do, come from the React world. And yeah, so maybe we can chat later on when I'm not hosting a conference. Awesome. Please, one more round of applause for him. He has some really good ideas here, and I think that all of us should take those to heart and think about them. So our next speaker is not due up for a few minutes, so you guys have some time to go to the bathroom, grab some food. There's some more food out there, and we'll be back here at the top of the hour. Thank you very much.
Hey. Fuck you, right? Michael. No, it's this thing.
All right. So I hope you guys are ready for our next ETHDubai talk. So we have talking about writing yearn strategies. Faku, you can find him at Salty Faku with both Twitter and GitHub. He works with Yearn Finance. He's a Yearn guy at Iron Finance. Professional bow swapper, helping builders make a lasting impact on the crypto community with dataless angels. Help me in welcoming Faku.
Thank you, guys. Do I use that one or? Okay. Hello, everyone. Today I want to talk to you about how to become a strategist. It's actually pretty easy. We are here to debunk a myth that you need to be a hardcore developer, a Linux core developer to be able to be a strategist, because that's not true. Actually, the most important thing to become a strategist is to write a strategy. And to do that, you have to understand how things work. That's much more important than writing complicated code or fancy stuff. The important thing is to understand the financial aspects and how the protocols interact between them. Seems simple. It's not that simple, but learning Solidity is much more simple. So let's go. What are the vaults and what are the strategies? Okay, the vaults are like a piggy bank. They're super simple. You just deposit tokens, and the strategies are going to grab tokens from the strategies to invest them. In the strategies, we have something that we call the want token. The want token is the token that you want to accumulate more. So it's going to be compounding that token. That's what the strategies do. These are the definitions by Andre, which are quite interesting because you can think as vaults and strategy to be complicated, but they are pretty simple. Okay, let's get into some technical details about the vaults. Thank you. The vaults are written in Viper. The idea is not to complicate your life with Viper. The thing is that you're not going to be interacting with the vault code a lot. Most of the interactions between the strategies and the vaults are already coded in the base strategy. The benefits of having the vault as an ERC20 is that you will be able to transfer it because it's a share. It's just a share. You're going to be able to do leverage, which is cool, and any other thing that you do with an ERC20 are more boring, actually. The vault are going to keep track of your shares, the price per share, which is the value that is going to accrue when you get more money, when you get yield. And the good thing is immutable code. We're not using any proxy weird stuff because we want our users to be sure that they are going to be using exactly the same code every single time. That's important because you can audit the code and you can check what we're doing with your money, which is super important. With the V2 design, the big highlight, multiple strategies, up to 20 strategies. That's super important because it's super difficult to deploy big chunks of money into a single protocol. So with multiple strategy, what we achieve is to be able to deploy smaller portions into different protocols with different strategies. And we use the Keeper network. It's a decentralized bot network. So we keep everything decentralized and with automation. Well, we wanted to make it more complicated, so we wrote the strategy in Solidity. Actually, that makes it more like easier because it's more popular and you have inheritance. So what we did is we coded, as I told you before, everything to interact with the vault in another contract, the base strategy.sol. So you're able to import that contract, inherit it, and you don't have to code all that boring stuff that's always the same. You're going to have to code only the main part of your strategy, the investment part, which is the fun part actually. The strategy is going to manage the accounting, report the profits and the loss to the vault. It's going to invest, uninvest, collect the rewards, and recycle them. We're going to see how it works later in the presentation. And it's also going to do all the heavy lifting, like checking the slippage, harvesting the returns, which is collecting the rewards, and keeping the collateral ratio healthy, which is for strategies that are debt-based, like a MakerDAO CDP. You don't have to manually check your CDP every time so you don't get liquidated. The strategy is going to do it for you. So, well, this is really cool because it gives you an idea of how a vault is composed. This is the USDC vault. This is from a few days ago. So you're going to see that we have 1, 2, 3, 4, 5, 6, 8 strategies, if I'm counting right, that are attached to the vault. Every single strategy has a different percentage allocation because it doesn't matter that we have 9 or 8 or 9 strategies. We're not going to assign the same amount of capital to each of them. We assign the capital based on simulations to achieve the best APY, and also we cap the percentage we assign by the risk that the strategy has. So we want to keep the funds as safe as possible. And also, you're going to notice that the last 3 strategies, they have 0 capital allocation. That's really cool because we can have new strategies ready when the opportunity comes, and I'll assign capital when it's the best moment because we want to maximize yield all the time. Okay, here's another graph about how the vaults and the strategies interact. The vault is the smart contract front end, to call it somehow, for the user. The user is never going to interact with the strategy directly. We don't want that. For security reasons, we only let the user interact with the vault. All or most of the strategy public functions are permissioned. Nobody can touch them. And it's the strategy, the one that is going to interact with other protocols or the DEXs. So vault can have multiple strategies, but the strategy can only have one vault. That is because we only have 1 token per vault. We want to keep it simple for the users. So that's also, it's going to be easier when you build your first strategy because you're only going to have to manage 1 token. Okay, let's go to this complicated diagram. It's not that complicated, actually. These are all the parts that interact with a strategy usually. So you have the keeper network, which are bots basically, the vault, the strategy, a DeFi protocol. It can be, for example, Compound, that we're like depositing to Compound, borrowing money to get comp rewards, and then a DEX, Uniswap, SushiSwap, whatever you want to call it. Why we use a DEX always? Because we want to exchange the rewards, in the case of Compound, the comp token for more DAI, for example. That's the want token. The want token is DAI. We want to get more DAI. So how does it work? The numbers that you see there is the order in which the transactions, the actions are executed. So the first action is the keeper monitoring something that is called the harvest trigger. That's only a Boolean, but there's a logic behind telling the keeper, now it's a good moment to call harvest and to execute the next steps. Why? Because sometimes you want to accrue more tokens because of gas costs. Imagine having to recycle, I don't know, like every hour having to sell tokens on Ethereum. That's crazy. The gas cost would eat us alive. So when the harvest trigger is true, the keeper bot is going to run what we call harvest. The harvest function, it has simple tasks. The first one is that harvest is calling in the strategy. The strategy is going to claim the rewards from the DeFi protocol, is going to get the rewards, and then just swap them in a DEX for more tokens that we want, the tokens that the vault is managing. The last two, three things, it's reporting to the vault the accounting, because with the vault shares, what it's going to increment is the price per share. And just that. You're not going to, it's not rebasing. You're not getting more tokens into your wallet. The price per share is the thing changing. It's going to execute at just position. At just position, we're going to see it a bit more later, but what it does is adjust the percentage of that allocation. Because if we assign to a strategy, for example, 1%, and because of the rewards, it ends up having 5% or whatever, we don't want that to happen, because remember that the percentages that we allocate are risk-based also. So we want to keep always the same debt allocation. When all that is done, send success, and that's it. All these complex diagrams, it's pretty much abstracted from you anyways. Well, this has been the boring part. Theory. Let's talk about what you need to write a strategy first. This is what I got when I wrote my first strategy. The software is like Git, ETHBrownie, which is a development framework, Ganache, which is going to help you get a mainnet fork so you can test your strategy before deploying it. The Brownie Mix is our repo. It's actually a template that you can use, and it has already made the tests and all the code in place with nodes that where you have to complete with the logic of your strategy. Some programming experience. So I used to code in PHP, and that's pretty much it. And I learned Solidity using CryptoZombies, which is super fun. I did till level 4, and for me that was enough to be able to code a strategy. Then the two most important stuff, understanding how things work. Not only how the vault and the strategies interact, but also how the DeFi protocols interact between themselves, and how the slippage works and all that stuff. That's the important stuff. And a ton of willpower. You gotta sit down and start understanding how things work. So that requires hours sitting down in front of the computer and trying to figure things out. So you want to write a strategy, you have a great idea, but we have a process. This process is because we are focus on security. For us, security is super important. We never risk the principle. So that's why we have due diligence. That's the first step. Due diligence is a little investigation of the protocol. Then you code the strategy. Then two peers have to review it, because we all know how audits are these days. They are super expensive, and they take a lot of time. If we have to audit every strategy, we're dead. We're going to lose every yield opportunity. Then it's go to experimental. Core dev review, which is an internal auditors inside of Yearn. The safe farming committee is going to review it, and then it goes to production. Let's go more in depth into these steps. Well, what do we check in the due diligence part? Well, actually, it's something the strategy has to do. For each new protocol, we do an in-depth investigation, not only of the code, like auditing the code, but also how it works and who is owning that contract. And that's super important. For example, you're going to see a lot of aspects here, but I like to highlight the raggability part. That is, are the owners of the contracts or the protocol able to rug pull the users to take the user funds? For example, for multisigs, there seem to be super safe. It's like someone tell you, hey, yeah, we have a multisig. What's the threshold? 1 of 10. Now you have 10 people that are going to be able to execute transactions from that multisig. That's not good. That's not really good. So you have to also ask about the threshold and verify it on chain. So you need to have something like 3 of 5 or 6 of 9 people, so they cannot collude and steal your users' funds. And then we check the audit reports, how the protocol works, etc., etc. And we have a path to production, which is the process that the strategy is going to take to go to production. So well, now how to code. And this is only one slide because it's so simple. We did it in a workshop yesterday, and in 3 hours we had something simple working. So you clone the brownie mix strategy mix. And to code the strategy, you only need to code 3 basic functions. All the rest is going to be like dependencies from the code that you put in these 3 functions. The first one is adjust position. The only thing it does is invest the funds. It's going to, for example, deposit into a MasterChef contract, and that's it. The second one is the other way around. It's liquidate position. So what it's going to do is going to withdraw money from in this case, in our example, from a MasterChef contract. We want to assure to all our users that they can withdraw at any point in time. So there's no way for us to block the withdrawals in the vaults. And the final one is prepare return. This is the one that has a little bit more complexity because you have to build the logic behind your strategy pretty much there. This is the one that is going to claim the rewards, is going to sell the rewards using a DEX, and it's going to send a report to the vault saying, hey, this is how it went. This is how much we won or we didn't. So this is where the business logic goes. Well, and then write tests. That's also kind of boring. It's not nice. They take time to run, they're not fun, they're not glamorous, but it's the only way to assure that your strategy is not going to have problems in production. Let's see how, this is the brownie mix. These are the tests that you're going to have by default when you use the repo. Those are like 4 tests because the conf test, it's a configuration one. This is not the ideal scenario, but they say we test in prod. This is a production strategy. It has like, I don't know, 15 tests. This is the way to do it. You have to test everything possible, like every edge case. What happens if I airdrop some tokens to a strategy? Is it going to work well? Is it going to lock the rewards? All the weird stuff, we have to test it, because when we send it to production, it's too late. So let's say you go to your strategy, you have amazing tests, 2 peers reviewed your strategy, and you're able to publish it into ETHDubai. ETHDubai is not Yarn, it's a platform that the strategists maintain. We try to make it funny, but with the right disclaimer. That warning there says that if you deposit there, you're pretty much going to lose your money. This is the testing product we do. We choose 2 emojis, a funny name, and we try to promote it for users to deposit and to get like early yields for more risky things. But we're just testing it. This is testing. Next step. This is part of our process, the safe farming committee. So you have to convince a 12-people committee that your strategy is safe and it's worth going to production. So they're going to review the whole due diligence. They're going to ask a lot of questions, but it's pretty fast. If you're convinced that the strategy is good and it's performing well, it's going to be fast. Then a core team member is going to review it, because as I told you before, getting an audit here, it's impossible. So what we do is we get a review from a core team reviewer. We have 2 security auditors internally, and if the strategy is getting bigger and bigger, we get a committee, and then we get an audit. But after the strategy is already in production and reviewed by at least 3 or 4 people, and with some time in testing. So it's debunking also a bit the myth that we test in prod. There are stuff that you need to test in prod, but you need to make sure that all these steps are there. If not, maybe it's not going to work well. Well, this is the last step. This is like super verbose. I don't know why, because it's super simple. It's just sending it to governance. So when all this is done, governance is going to either endorse the vault, it's what we call it, it's the technical term if you want, the function we call in the registry we have, or add the strategy to a pre-existing vault. So if you are making a strategy for a new token, anyways, it's super easy. It's just pasting the address in one of the configuration parts of the deployment, and that's it. But it's going to deploy a new vault with a new strategy that you created and endorse it by governance. If not, it's going to attach it to a previously generated vault. Well, that's it. Your strategy is in production. You are great. Applause. You are making a lot of money. Yeah, but strategies are not something that you set and forget. At Yearn, we monitor everything, because I will get, again, the example of Compound. When the Compound rewards got stuck, got a problem, we were monitoring the time lock. So we knew ahead of time that those rewards were not going to be there, and the strategy might get locked. So we took preventive action, and nobody even noticed that we might have had an issue because we were monitoring. In DeFi, things change. So monitoring is essential. So you don't have to leave. It's not set it and forget it, and you get rich from one day to other. No, you got to keep monitoring, and you are the one who made the strategy. So stay around. You're the one who knows. So when something happens, you can help fix it. And that's it, guys. Help us build the future. You're welcome to join Yearn and start to build the strategy together.
All right. Do we have any questions? Anyone? If you want to stand up and raise your hand if you have any questions for Facu. All right. Thank you very much. Another round of applause. And we did finish a little bit early on this talk, so if you guys want to take a few minutes to go get some food or stretch your legs, we will be back here at the bottom of the hour with our next speaker. Thank you very much. Correction, we have a 30-minute break back here at 1700 with Boring Crypto.
have any links or anything to open, right?
Ah, the speaker notes here, great.
Yeah, everything's there.
Yeah, perfect, man.
So just forward and backwards.
Yeah. Next slide coming, wow. Nice.
Awesome.
First time I used it, Google.
Oh, yeah, I mean, we have everyone set up on that. They have
Great, you can pick it up and go last week.
yeah, the problem is that on HDMI cable that they have hooked up was crashed.
All right, so welcome back, everybody. We are getting ready for our next talk. Most of you know who he is. He's going to be talking about Boring Box, Bento Box V2, the revolutionary tech behind the success of Magic Internet Money and Kashi. His name is Boring Crypto. You can find him at boring_crypto on Twitter or just Boring Crypto on GitHub. He's a reader of Boring Smart Contracts. He's the inventor of Bento Box, spender of Magic Internet Money, instigator at Pixel Inc. Is this introduction boring enough for you? Hands together for the most boring of all fancy unicorns on the web, Mr. Boring Crypto.
All right, so Yieldbox. Yieldbox is a smart contract infrastructure layer. Sorry. Is it over? Yep. If you can't read the screen, but I think it's big enough, you can scan the QR code and get the presentation. So Yieldbox, unfortunately, where is it? Yep. It's not a protocol. Doesn't have a token. There's no DAO. There's nothing to ape into. So if you're here for that, then go somewhere else. So it's just a piece of infrastructure to make development better and get better yields. So let's go through it. We're going to have a look at what the user benefits are, what the benefits for developers are. We'll have a look at the contract stack, and we're going to end with some examples. So the user benefits. So one of the main things of Yieldbox is a way to get yield, so to get into strategies. So it makes it much easier to get into strategies. Currently, if you want to get into a strategy, let's say Yearn, you have to go to the Yearn website. If you want to go to some other strategy, you have to go to another website, and you have to figure out how these websites work, and they all have clunky UIs, and it's very unclear how to use it. And you also have to approve your tokens to each of these websites. So with Yieldbox, you just approve your tokens to the Yieldbox, and then you can assign it to any strategy you want, and you can move between strategies. So it's all about capital efficiency. So what does that mean? Let's say I have some ETH. And one thing I want to do with that ETH, maybe I want to put it in a lending platform, like here, and then borrow some USDC against it. But also, I kind of want to use that same ETH to put into a strategy and make some yield from it. So what I actually want to do is I want to take my ETH, put it in a strategy, and then I get some sort of strategy token. Then I want to put that into the lending platform and then borrow some USDC from it. Or even crazier, I might then want to take that USDC, swap it back to ETH, and loop it again, and then I get a lot more leverage that way. Unfortunately, these days, this is normally the situation you run into. Whatever token the strategy gives you is not really, cannot be used in the lending platform, because that just wants, straight ETH. So with Yieldbox, basically every Yieldbox asset is a token plus a strategy or no strategy. And that creates an asset, and while that's sort of like a token, an asset, it behaves mostly still like ETH. So you can then take that, and then if a lending platform is actually built on top of Yieldbox, you can then just borrow USDC against it. So now you kind of, you can have your cake and eat it, right? So you get the yield from the strategy, but also the benefit of the protocol. Another benefit for users is simpler approvals. I bet most of you spend a lot of time doing approvals. Every time you have a new protocol or a new token, you have to approve, approve, approve. So with Yieldbox, you approve your tokens once to the Yieldbox. And when you have a new protocol you want to use all your tokens in, you just approve that protocol once, and then it has access to all your tokens. So now we're going to look at the benefits for developers. So almost every protocol out there, it has to deal with tokens, it has to deal with ETH and Rapid, it has to deal with ERC20 tokens, and that's for most protocols where it stops. It doesn't support also NFTs, ERC 721, it doesn't normally support ERC 1155 tokens. So with Yieldbox, without having to do any work as a developer, you get support for all of these without having to do any work. And we'll look at some examples about that later. Another thing that most protocols can't deal with is rebasing tokens. You normally would have to wrap them, and then you'd have to use a wrapped version of it in your protocol. That whole problem goes away as well. As discussed, the capital efficiency. So if you build a protocol by itself, it has a certain yield, a certain benefit to users. If you build it on Yieldbox, it's the same protocol, but extra yield for any tokens that are sort of sitting still. They can be assigned to strategies by the user. It also has a built-in token factory. We'll look at that. And overall, and we'll see that in the examples, you just get smaller, simpler, and less exploitable contracts. So this is the these are all the sort of different tokens. So the way it works is, so you can take any token, whether that's a native token, an ERC20, some rebasing token, an NFT, an 1155. You can combine that with either no strategy or any strategy, and it's completely permissionless, so anyone can write strategies, and people can choose those. And that sort of gets wrapped up into a Yieldbox asset. And those are kind of uniform, so as a protocol you do not have to worry about like how that asset works or what that actually is. So this is the token factory I talked about. Often what you see is, let's say, Uniswap v2. Every time there's a new pair, you have to deploy an entire contract that is a complete ERC20 token that has all the swapping functionality, repeated. There's no need for that. With Yieldbox, you can simply have a single contract, and whenever there's a new pair, you just call create token, and you'll just get an asset ID that is just a simple ERC 1155 token. And then you can mint, you can transfer the ownership, and you can renounce the ownership. So this is just the basic functionality you will need in most contracts. And let's have a quick look at the contract stack. So the core of the yield box is a standard ERC 1155 implementation. So it's a little small, but that's just your basic functions that are in there. And then it gets wrapped into an asset register. So that's kind of where you register and say, hey, I have this NFT, this token number, I want to combine it with this strategy, give me an asset ID for that. And then from then on, you can just use it as an asset, or whether it's like an ERC20 token or whatever you want to put in there. And then that gets wrapped into the native token factory. So that's the part where you can issue new tokens that your protocol might need. It also includes the boring factory. That's a very simple clone creator, so you can get a master contract. You can create any number of clones from that. And it also keeps track of the clones. And one of the cool things about that is with the approvals, if you approve a certain master contract, you've automatically approved all the clones. So in certain contracts, this will be very helpful in that sense. And then around that is the yield box contract. That includes boring batchable. It's just a very simple function that you can now call any function in the yield box. You can batch it so you can call 10 of them at the same time in a single transaction. So just some gas optimization there. And here's some of the functions that are in Yieldbox. It's a way to deposit assets, to withdraw them. There's a whole bunch of different transfer functions depending on how you're transferring that are gas optimized. So whether you're transferring a whole bunch of assets from the same user to the same user, or from one user you transfer to like 20 users, there can be gas optimizations in that code. So that's what this does. Let's look at some examples. So this is a very simple escrow contract. So basically, I can make an offer and say, I have this asset, this quantity. If you give me this other asset of this other quantity, let's swap it. I'll just figured it would be a bit small. So this is just the core part of that. So the make just pushes the offer into an array. It doesn't actually swap anything. It just kind of puts it out there. And then, providing you still have the assets in Bento Box, if someone else wants to take that offer, they call the take with the offer ID. Then you just ask the yield box, okay, give me what I wanted, and then I will return the thing that was on offer, and then it closes it. And you can obviously cancel as well. So if you are the owner of that offer, you can say, actually, I don't want that offer out there anymore. So one thing to note here is that the contract escrow, it's not like is ERC20 or is something. This is the entire contract. If you deploy this on an Etherscan, this will literally be all code you will see, plus the interface for Yieldbox, which is a couple of lines. So to deploy this whole thing, maybe a couple of $100K in gas, it'll be very cheap. This contract here is not just like an escrow service for just ERC20 tokens. This is also basically a limit order system for native tokens, for ERC20 tokens, for ERC 1155 tokens. It's also a marketplace for NFTs, because you can put up an NFT for offer, and then someone can buy that. This is also a way to swap NFTs. So this little contract here can do a whole lot of things. And as you can see, you don't have to deal with native tokens, wrapping ETH. So this takes a whole lot of complexity out of it. And less complexity means less bugs, means getting wrecked less. I had another little example here. which is a tokenizer. So let's say you have an NFT and you want to tokenize it. So this is the entire contract again. I'll just get to the core of it. So you deposit your NFT. You say the source asset, it can be something else, but NFT makes most sense. You put one in, then here you can see how the create token works. So then it creates a tokenized version of that NFT. It gives it a name and a symbol, 18 decimals. Then the transfer brings in the NFT, because that's what you've got to give. And in return, it mints you the tokenized version, the tokenized tokens. And then you can turn around and say, okay, now I've got all these tokens, I want to withdraw the NFT. And you can simply burn those tokens, and it will automatically transfer this, this NFT back to you. When Yieldbox, I'm still in development. Basically, most of the code's written, and this is the GitHub for it, so you can check it out. I'm now in the process of doing a lot of examples to see, if I'm missing certain helper functions of things, to make sure it really provides for all the different ways people want to use it. Also, very keen on any feedback anyone has. If you look at it, that'd be great. I'll leave this up for. Oh, actually, it's on here too. Yeah, so if you want to reach out, that's my Twitter, my Discord. The GitHub is on there. I'm always keen on feedback, so I have some time left, so any questions?
Okay. Let's start over here.
Yeah, I just have a quick one. Is the library also optimized for 721As, the Azuki 721As?
Sorry,
721A.
A?
Yeah. So recently this group of developers called Azuki, they also represent this NFT collection. And they came out with these gas optimizations for 721s. And they're pretty hefty. They're like 1/3 gas than 721s.
Cool. I'll definitely look at that.
Perfect. Thank you.
Next was over here.
There's something I didn't understand. You mentioned the yield-bearing tokens cannot be deposited to get to borrow money, but we do have. Maybe you mean, like, just to clarify, maybe it's within the whole system. Yeah, this part. Yeah, so we can take YARN tokens and deposit it into a Spell platform and get MEM.
Sure. It's not like it's never possible, but you can't put them into AF. It's like it has to be specific. It's a little bit harder because each platform that will want to support it, they would have to then understand exactly what a YARN ETH token is, and also how to get the price of that. Right, whereas in Yieldbox, if you know the price of ETH, then you can just accept YARN ETH and AV ETH and compound ETH, and then so it's much easier. If you build a lending platform on top of Yieldbox, it will be much easier to just accept a whole long list of different collaterals with strategies.
So standardizing the whole process across.
It's a lot more standardized, and it behaves a lot more like the original ETH in a sense than when it's really locked into a strategy. And it's also a lot like the way the sample strategies work. It's a lot cheaper to, unless you pull in big amounts or push in big amounts. If you do small amounts, there's like a buffer, so there's almost no cost to getting into a strategy. Okay. But that's really up to the person who writes the strategy. But like the samples that I'm making work like that. Yeah.
Thank you so much.
No worries.
All right. If anyone else has a question, okay.
Thank you. Hey, Boring. That's a bit. Very cool stuff. So my question is, what about licensing? Are you thinking about releasing this through a different license from Bento-Box? And second, how do you think about the trade-off of keeping all these assets within one single smart contract, which is basically this gigantic, vault holding everything from a security perspective instead of isolated, pools or tokens?
Okay, the first one is simple. Almost every part of it will be MIT licensed. Just the core yield box is unlicensed simply because there should be only one on each chain, and I will deploy them. Because there's no point having more than one. It's, as I said, there's no token or anything. There's nothing to gain from having more than one of them. And if someone wants to work on it or make it even much cooler or whatever, like just reach out. It's just to, I just didn't license it because I don't want like 10 different yield boxes out there. That would just be silly. Yeah. The second part.
Yeah, my question was about. It looks like there is a significant trade-offs in holding all these assets into a single place compared to have isolated pools. And I know this is kind of becoming a little bit more accepted within the community after Maker, after Balancer, after Bento-Box. But do you think there is something to be concerned in having this single smart contract holding all these different assets compared to many different isolated pools?
I think for this one, not so much. And also, a lot of tokens will actually not be held inside the Bento-Box because if you assign it to a strategy, it's actually the strategy that gets the tokens because they are going to be dealing with it. Right. So it will be, Bento-Box is true, it's like most of it is sitting in there. With Yieldbox, it will be more spread out. So only if you don't assign a strategy, it will actually end up in the Bento-Box.
Gotcha, thank you very much.
All right, just stand up and raise your hand if you have a question. Anyone? Yeah, I thought he explained it pretty clearly too.
Cool, thanks.
All right, give a hand for Boring Crypto. All right, so we have a few minutes before the next talk. If you guys want to take a break, we'll be back here at the bottom of the hour. Thank you very much.
Yeah, I got it here.
Yeah. You want to go ahead and do this?
All right, we're going to start this next talk a little bit early. So today we have coming up Roman Semenov. He's going to talk about building shielded transactions using zero knowledge proofs. He's working on ZK snarks and plasma implementations for Ethereum and Tornado Cash and other privacy and security related ETH stuff. He's from Moscow, and give him a big round of applause. Roman Semenov.
So the next slide is black, or oh, I see. Yeah. So let's talk a bit about privacy. So the blockchain is like a Twitter for a bank account. So all transactions are public by default. So when you pay to someone, this person is able to look for entire transaction history or check all your holdings. And it's not very convenient, so for most users it's unacceptable. In traditional finance, all transactions are private by default. And especially for businesses, they are not very comfortable sharing their cash flows and clients and all this stuff. So for good adoption, the blockchain needs to have good privacy options. And with growing popularity of chain analysis tools, it becomes easier and easier to track other people's funds and financial history. So privacy should be like a feature and not a product. So there are many separate privacy chains that have only a single feature, privacy, but we want to have this as a feature in Ethereum. On Ethereum blockchain, just one of many features that Ethereum has. And it's possible to implement all the privacy features on Ethereum. Current Tornado Cash version that is on production is just the first step. It's possible to do much better than that. So I give a brief overview of privacy on other blockchains in crypto. So I will not mention like privacy based on like custodial mixers or SGX technology because it's not secure at all. So the good privacy options are on Bitcoin. The best we have is CoinJoin. Those are transactions that have like hundreds of inputs of the same amount and hundreds of outputs, and they are mixed between each other, so anonymity sets for each transaction is separate. So each output can originate from one of possible like 100 inputs. There is Mimble-Wimble technology. For example, Beam and Green chains are based on this technology, but it provides only confidentiality. So Mimble-Wimble hides the amount that is transferred, but doesn't hide the transaction graph, who transfers to whom. So next, there is Monero. In Monero, for each transaction, there are 10 fake inputs and 2 like real inputs. So this is decoy-based system, and it's pretty hard to analyze it, but it's still possible. So some data still leaks, and by exploring like taint trees, in some cases it's possible to de-anonymize Monero transactions. So Zcash is one of the best privacy technologies, and it perfectly hides transaction graph, but it probably needs more usage to be good. And then there are 2 options on Ethereum, Aztec and Tornado Cash. Tornado Cash has more usage, but Aztec in the long term has pretty good technology. So it can take some time to implement it, but it's pretty good. So the current Tornado Cash stats, it has 500 million of TVL, and 2% of all existing Ether has already passed through Tornado Cash smart contracts. It has volume around like $5 billion a year, and plenty of transactions. So pretty good anonymity set. It also has some drawbacks. So in Tornado Cash, we have pools of fixed amounts, like 1 Ether, 10 Ether, and 100. They are like separate, and they have separate anonymity sets. And it's also not very convenient to use those fixed amounts because you often need some custom amount to pay someone. And it's also pretty expensive. So 1 million gas for deposit and 400K for withdrawal. And recently, Tornado Cash released a new version that fixes some of those problems. So it allows to transfer arbitrary amounts. And it works like a shielded pool with UTXO model inside. So it's possible to do joins, splits, private shielded transfer inside the pool. And it also uses Gnosis chain under the hood. So it looks like you're still on Ethereum, but you never need to switch the network, but the transactions are much cheaper thanks to usage of SI chain. So here is a quick demo. Just a sec. So in Nova, we connect MetaMask with mainnet, and we can deposit some arbitrary amount to our account. So the transaction will forward the funds to Gnosis chain and then deposit them into shielded pool on Tornado Cash, all in a single action. The video is sped up, so it takes around like 2 minutes to do this action. So after transaction is confirmed, you will have some funds in your shielded account, and you can do a shielded transfer to other users that are already registered in the same shielded pool in the Nova. You can transfer any amount, and for shielded transfers, the fee is less than 1 cent, and the transfer is pretty fast. It all happens inside this shielded pool. And then it's possible to withdraw your funds back to mainnet. And there are fixed amounts that we recommend to withdraw, but it's possible to set any custom amount. So you just hit withdraw, generate snark proof, and the funds will be on the target address on the mainnet. And you never need to switch the network in the MetaMask. It always stays on mainnet. So here's a simple explanation how it works. So when you deposit, you send the transaction to MetaMask with MetaMask to ETHDubai bridge. It will transfer funds to Gnosis chain and then puts them in Tornado pool. When you do shielded transfer, it is done using a relayer. So you generate snark proof, send it to relayer, and relayer will send the transaction to Gnosis chain for you to preserve the privacy. And when you withdraw, you also send the transaction through a relayer. Then Tornado pool will send the funds to ETHDubai bridge, and ETHDubai bridge will send it to your target mainnet address. So the Tornado Cash Nova was rolled out to mainnet a few months ago. It still has limit of 1 Ether per deposit. So we want to avoid, like in case the bug is found, we want to avoid people losing funds. So it's still in beta mode, but so far no bugs were found. And it has over 3,000 Ether deposited, considering there is a limit. That is pretty good usage stats, 1 million TVL and plenty of transactions. So let me explain a little bit how it works under the hood. I'll try to make some simple explanation, but I hope it will be clear. So how the Tornado Cash Classic works first. It maintains internal Merkle tree of so-called commitments. When you send a deposit, you send some Ether along with some hash and the smart contract will put your commitment in its Merkle tree. So how the zero knowledge actually works here. So when you deposit, you generate two random numbers called secret and nullifier. If you hash two of those numbers, nullifier and secret, you get what we call commitment hash, or simply commitment. This is the string that gets inserted in the Merkle tree. And there is also another entity, nullifier hash. If you hash only one of those random numbers, you get nullifier hash that is linked to your commitment hash, but for external observer, they look like two entirely different numbers. So only you know this connection. So when you do a deposit, you send this commitment along with Ether, and it gets inserted into the tree. And when you do a withdrawal, you generate a zero knowledge proof, proving two things. First, that your commitment is in the Merkle tree, so you generate Merkle proof for that. And also, the smart contract will check that your nullifier hash hasn't been published yet. This is protection from double spends. So when someone sends a proof that has already known nullifier hash, that means this Tornado Cash node was already withdrawn. So for snarks, public inputs are Merkle root, so the smart contract will check that its Merkle root corresponds to the one used to generate the snark proof. And a nullifier hash will be also public. And privately, when you're generating a snark proof, you will provide a nullifier, secret, and Merkle proof. This is visible only to you, and the snark proof is generated in the browser. So those private inputs never leave your client side, like your browser. Then Tornado Cash Nova is a little bit more complex system, but it's based on the same concept. So it makes the node a little bit more complex. So now your node contains the amount that you're sending, public key that owns this node, and also some secret number. So if you hash all those three numbers, you get the commitment that is inserted in the tree when the node is generated. And there is also nullifier hash that is computed a little bit differently, but the same concept is important, that is somehow linked to your node. So its commitment hash and nullifier hash are linked. So when we do a transaction, it is simple join split transaction that takes two inputs and produces two outputs. So it basically spends two nodes and generates two new nodes. And the snark checks that input amount, so sum of input nodes is equal to output amount, and also checks that spender knows the private keys. And also for each node, it checks all the rules that is checked in Tornado Cash classic version. So here the public inputs would be Merkle root, two nullifiers for two input nodes, two new commitments that get inserted in the Merkle tree as a result of this transaction. And then there are private inputs, basically your node, private key to spend those nodes, and Merkle proof for each one. So essentially, this is, you take some model similar to Bitcoin, but private. This is the same technology that is used in Zcash shielded pools. So pretty similar pool, but on Ethereum. What also can be implemented in the next version of the protocol would be token support, and it's pretty easy to add. So in addition to amount, we can just add additional field, asset ID, and that's pretty much all that is needed to add the token support. Also, shielded atomic swaps are possible, so swaps inside the privacy pool. And there are some other features that we want to implement, like diversified addresses. So it's pretty convenient if you have a single private key and can generate any amount of addresses corresponding to the same private key. So each time you give someone the address to send you shielded Ether, you can give out different address, but all of them will point to your same wallet. Also viewing keys for compliance. So Tornado Cash Classic has a compliance tool that allows you to prove your origin of funds. For example, if you withdraw from Tornado Cash and send to a centralized exchange, you can also provide this compliance report to show where the funds come from. So this new version will also support that. And then it probably will use some layer 2 technology like rollup. Like we're looking for different rollups. And we hope that they will have better bridges, because now we implemented like the Tornado Cash Nova is deployed on Gnosis chain, because it's the only one chain that provides fast withdrawals to Ethereum mainnet. Optimistic rollups has 7 days delays, and Polygon has 3-hour delay. So we hope that other chains will have better bridges soon. And the transactions fee on the new version will probably be paid with a single unified asset like Torn, because when you transfer different ERC20s, you need to pay a fee to Relayer, but you don't want to expose which asset you are transferring. So it's a pretty good idea to have all the transaction fees paid with a single asset for any transaction. So this is pretty much it. If anyone has questions.
All right, we'll start here. Hi, you mentioned ERC 721 support. How would that work realistically, right? Because they're, well, non-fungible.
Yeah, so ERC 721 NFTs will remain private as long as they're in the shielded pool. So you put NFT in the shielded pool and will be able to transfer it to someone in a shielded transaction, and it will be not visible that you transferred this NFT. It will remain on the balance of Tornado Cash Nova. And you can also sell it using Atomic Swap to someone else. But when someone withdraws this NFT from the shielded pool, it's of course visible where they withdraw it to.
All right.
So does Tornado use blockchain forensic tools like, say, a chain analysis or Elliptic or Cypherblade at the start, where they verify what sort of funds are coming into? If they're sort of suspect funds or, say, hack funds, is that sort of verified?
Sorry, can you repeat it?
Yeah, so the question is, when someone deposits into Tornado, do you verify what sort of funds are those? So in the sense, like, do you use blockchain forensic tools like Cypherblade, Chainalysis, or some of these to verify whether they are from,
So we as a developers don't have any access to smart contracts like Tornado Cash smart contracts, because the contracts are immutable. There is no admin access. So all the contributors have the same access to it as any other regular user. So there is no one that can change or censor transactions.
Sure. I'm just saying, but the deposit would happen from a particular address. Imagine that address is tagged that this has been used for example, an illegitimate activity. That can be served through the smart contract through an oracle, which oracle would probably track, these are the set of addresses that have been marked with a certain label. So.
Yeah, so in the same way that you cannot censor a regular Ethereum transaction, for example, there are tainted funds in some Ethereum addresses, you cannot tell miners to not accept transactions from this address. So you cannot prevent anyone from doing a regular transfer in Ethereum. In the same way it works with Tornado Cash. You cannot prevent anyone from interacting with a smart contract. It's trustless.
Okay. And do you see, like, have you kind of dealt with law enforcement agencies coming to Tornado Cash and sort of requesting for any modulations or modifications around what's being done right now?
So there is not possible to do, this is not possible to do any modifications even if you want to. The contracts are already deployed. But usually law enforcement guys, they go and ask for logs from Infura, Etherscan, and all those other Web2 services. And often this is enough to solve the cases.
Understood. You also mentioned one thing around compliance auditability. I didn't understand that, but where you said if you're moving funds to a centralized exchange, you would be able to showcase those logs. I didn't clearly understand what exactly was that.
So the user that has the node that allows him to withdraw the funds, the same node can be used to generate the cryptographic proofs that links deposit with withdrawal. So the user can selectively disclose his private data to someone. So the choice is in the hands of the user.
Understood. And how long before NOAA would sort of go live for all sort of users? Right now, I think it has 1 million TVL that is out there.
Yeah, so Tornado Cash Classic also has the compliance tool that is widely used.
Okay.
All right. Anyone else have a question? Stand up, raise your hand if you do. Oh, right here.
Hello. So you have proposed one solution. You have proposed one solution where you will try to generate multiple public keys from a single private key. How you intend to do that?
Sorry, can you repeat it?
Multiple public addresses from a single private key, right? Could you, how you intend to do that?
This is, involves a little bit of math, but essentially you mix some random number to your private key to generate new addresses. So each time you will get a new one. But yeah, it's very complicated to explain in 1 minute.
Any reading material on that?
Zcash has similar features that is widely documented. So if you're interested, you can just look up diversified addresses in Zcash. Our implementation will be pretty similar.
Okay, thank you.
Yeah, so that's diversified Zcash. All right, anyone else? Is that a hand back there in the back? No? Am I missing anyone? Right here?
Hi, thank you so much. My question is fairly simple. How would you describe zero-knowledge proofs to people who don't yet understand, or better said, to maybe an 8-year-old? Thank you.
Oh.
How do you explain to a 5-year-old?
Yeah, it's a thing that allows you to prove something without disclosing what exactly you're proving. Like, for example, that I know code to padlock, but I don't want to tell you exactly what code it is, just the fact that I know it.
Any follow-up to that one? How might you explain it to someone more corporate? I think it would be the same thing. Okay. Any more hands? In the back? You want to meet me halfway?
Yeah. Actually, it's not a question. It's more of the zero-knowledge proof analogy. I don't know if you know that to a corporate, you'd use the Sudoku example. So let's say I played Sudoku and I beat you, but I want to prove to you that I beat you without showing you the answer. You'd be able to verify the lines and the boxes without actually showing the Sudoku solution. So that's how you prove zero-knowledge proof.
That's actually pretty good. I like it. All right. Any other hands? Okay. All right. If we have no other questions, we will get ready for Mudit Gupta's talk next. By the way, if he's in the room, please come up here. So let's have a round of applause. And I know we're finishing a little bit early on some of these talks, so we're going to try to move into the next one as quickly as possible, but we do have to locate the next speaker first. Thank you very much.
Thank you, everyone.
Just one moment, I'll be ready.
All right, so we are running about 10 minutes ahead, which is actually good because I know everyone's getting a little bit tired, but we got to keep the energy going for Mudit. He is going to be speaking about security with smart contracts. You can find him on Twitter at Mudit_Gupta, also on GitHub at MaxSam4. He's a blockchain engineer, Ethereum dev, security researcher who loves all things coding and gaming. Give me a warm welcome for Mudit to the stage from New Delhi.
Okay, sure. Thanks for the intro. Happy to be here, folks. So the topic, the main topic is the security trilemma today. We'll be talking about for a bit. And then there are a bunch of other things I'll be talking about. I'll be talking about just a checklist for your smart contract security. Like when you are building smart contracts, like what you should do to make sure your contracts are secure. And then a bunch of similar things like this. So let me first start by who I am actually. That's a Linux command. Who am I? I'm currently the Chief Information Security Officer at Polygon, and I am also a technical partner at Delta Blockchain Fund, doing due diligence there. On the side, I am advisor to projects like SushiSwap, so help them with anything technical, anything security related, and yeah, helping the community as much as I can. Now back to the topic, the security trilemma. So I've defined this as a triangular relationship between the usefulness, the cost, the usefulness of the product actually, cost of the security measures, the budget basically spent on security, and the risk that the person or the product guy is willing to take with their product. These three things go hand in hand, and if you move one pillar, the others automatically just move. So understanding the problem. Usefulness, firstly, let me just define what usefulness is. So it's basically just a combination of features that a product has and how easy it is to use. So from usefulness, I basically means like what you can do with that software, what you can do with that product. A basic calculator might just give you like 1 + 2. A scientific calculator will give you more functions like sine, cos, and stuff. So that's your usefulness. And then there is ease of use. So oftentimes you will see better products won't succeed just because they're very hard to use. If someone can't use your feature, doesn't matter that the feature exists. So user experience is actually quite important. Security can hamper user experience in many ways. A typical good example would be the captchas. I'm sure everyone hates captchas, but they are a necessity, almost a necessity for most things. Now, that is just like a trade-off most products have accepted to take. They'll add captchas in exchange of the little less usefulness of the product. Then, like, how do you increase your usefulness? Basically, the best way is to add features. the more features your product has, the more useful it is. But there is another thing you can do is just make your product easier to use. Especially in DeFi, you might have seen like a lot of projects or products launched which were too complex, but then easier versions of those projects launched and they just took off. A good example can be Bancor and Uniswap. So sure, Uniswap is or was different from Bancor even in V1, but the base concept was the same. But Bancor never really got much attention, especially in the V1 version, just because like it was relatively complex to use. They tied everything to the Bancor token and stuff, while Uniswap just made it all open, and rest is history. So that's one example. Then in terms of the trade-offs, when you add any feature to any product, you are basically increasing the attack surface. If you increase the attack surface, you're increasing your risk, you're taking on more risk, and you're also increasing your security budget if you love security. Like if you want to get one feature audited, it might take you, I don't know, 6 months wait time. And if you want to get 2 features audited, it would take you a year. So definitely hampers all of your things, hampers your budget, hampers your timelines and everything. Usefulness is obviously important. If your application is not useful, there's no point going forward. I mean, that's the base requirement for any product. It needs to be useful. So that one pillar is super important, usefulness. Cost is obviously another super important parameter, especially the product guys will agree. If you end up spending all of your budget on one thing, the product would just suck. You have to manage your budget very carefully, and you have to like make sure you are not just spending everything on security while not having an actually usable product. Risk is another thing you need to manage very carefully. Like if you don't manage risk properly and have 9 nodes, you might end up losing $650 million and not realize for a week that happened. So you have to be very careful about what risks do you accept. And that's basically the trilemma. You have to adjust these 3 parameters and find the right balance for you. One thing I'll tell about all the trilemmas is you can't solve a trilemma by their definition. You can only optimize for it. So the next time you see any marketing materials stating they have solved the trilemma, you can assume it's full of shit in most cases. Why you can't solve it? So I'll mathematically prove this. The reason is the things that are present in trilemma, they are measured on a scale. They are not a check mark that you just check off. So security is not just a check mark you check off this is secure or not. It's always a scale of like how secure it is, how safe it is. Cost is not a check mark. Like you don't just check mark of $1, it's costly. It's always relative. It's always a scale. And same as usefulness. Like something very basic is also useful, and something super complex is also useful. So it's just a scale. So you can't just like solve a scale. You can't just tick mark that off. You have to find the right balance for everything. And that, by definition, you basically optimize the trilemma. So how do you actually optimize the trilemma? So now this depends a lot on the product itself. I can give you some pointers. So one thing is usually extremes are bad. So you want to be somewhere in the middle. You don't want to spend all of your budget on security. You don't want the product to be not useful at all. And you also don't want to take on all of the risk in the world in most scenarios. But obviously there are certain things where like being extreme is fine. So for example, if you are Bitcoin, then having a product that is not very useful, that spends like energy of multiple countries on security, and that like takes no risk is probably a good like trilemma situation. Then if you're building an MVP product, then you can obviously go super high on risk. If there is like no monetary value to it, you are just building something for fun. People call it testing in production. So in those sort of things, yeah, you can take on super high risk. For cost, people don't really spend much money on like these MVP type of things. All of the focus goes into the usefulness of the product in that case. So for those sort of products, yeah, it's good to like focus everything towards usefulness. But for most products that go live in production, yeah, you have to just find the right balance. It depends on product to product, but there is always a good balance. The third thing I'll add is you need to adapt over time. A lot of times I've seen a lot of projects that just mold themselves in a shape at the start of the project, and then they never change. So I'll tell you, like, even I've seen projects that just allocate a fixed budget to security, and 5 years later, when the project is 10 years, when the project is 10 times more complex, the security budget is still the same. People, I don't know why, but don't adapt over time. Change is super important. Evolution is super important. So doesn't matter if you have struck the perfect balance. You need to keep tweaking it over time. And like you might have to tweak it depending on external parameters, not just your own product, but external parameters can also affect the right balance that you should be having. This is basically like what I had for the trilemma. Now I have a bunch of other things. But before that, I'll get into shilling. Today's video is sponsored by Raid Shadow Legends. Well, not really, but the two things I'll mention here is one, Delta Blockchain Fund. Keep an eye on it. I'll be dropping a few useful small DeFi tools for it. The MVP sort of projects which are good on usefulness. But yeah, I'll make sure they are relatively secure. And then the second, Polygon. I'm currently building the best security team. So like, if you are interested in security, just reach out to me. I'm hiring aggressively. Now, this one, pointers for writing secure smart contracts. This is basically something I was working for an internal list in Polygon, just like creating some guidelines and security stuff. I'll probably make the whole thing open source eventually once it's ready, but just to give you some highlights. The first thing I'll say is you should first understand how to, like, what DeFi actually has. To actually write smart contracts, you need to understand the best practices. The best practices are called best practices for a reason. You should understand the common pitfalls. Like if you see someone falling in a ditch, you should not be walking to the same ditch. Just avoid repeating the same mistakes and you'll be golden in most scenarios. Another thing I like a lot is doing capture the flag events. So if you are even remotely interested in smart contract security and you are a developer, would definitely highly recommend to do CTFs. That would allow you to learn a lot about different attack vectors. That would allow you to think in a manner that the like bad guys think, in a manner that the exploiters think, and that way you would be able to like sort of front run their thoughts and keep your product safe. The third one, which honestly I feel like is the super important, it's the most important bit in smart contract security. Keep it simple. You don't want to go crazy with optimizations on all, unless you are maybe transmission. In most scenarios, you would just want to, in most scenarios, the trade-off for like saving a few bits of gas for making your code non-readable, it's just not worth it. Start with a as easy to read code, as simple as possible. Doesn't matter if it's not super optimized. Optimizations can be added later. Just make sure you have something very simple that is safe and sound. Another thing is have proper documentation and specification. I'll tell you, like even the tier 1 DeFi projects, they are super lacking in documentation, and almost no one has proper specifications. Someone who comes from like a traditional development environment, when you spend like a good chunk of your development time just writing a documentation and specifications even before the development starts, it's just a weird thing. It's good to be building fast, but you have to be, like, especially when you're dealing with such large amounts of money, you have to be building proper. I don't think rushing projects to be the first one to do this or do that makes sense, especially in DeFi. The first mover's advantage, I feel like, is overrated. I don't think, like, probably none of the projects that just launched first has actually maintained lead in this space. It's almost always the second project which is more polished that takes over. Like even in like lending borrowing platform, Aave is taking over Compound. In like AMMs, Uniswap took over Bancor. Sushi would be taking over Uniswap very soon, and so on. So people who launch later sort of usually get to do the better job. Reuse safe code. So no need to reinvent your wheels. There are already enough ERC20 tokens out there. I don't want any of you to be writing your own one to save 2 gas. So just reuse code. And then these are some checklists that I tell people. One is aim for 100% test coverage. If there is any reason you can't get 100%, if there is a branch that is impossible to reach, try to reason with it, why it's why you are not able to cover it, add a code comment to it for the future devs, for auditors and all that, hey, this is the scenario that we cannot test, then you add a comment like, this is fine, this is perfectly safe, this can never happen in production, or you add a comment like, this is very complex to do, or this should never happen in production, but there is a chance it might happen, so focus more on this bit maybe. So even those comments can be very helpful for any reviewer, any auditor. Use a static analyzer. Like I like trail of bits tools a lot, so Slither is my favorite one. There is Methods as well. You can use both, but in practice, like even if you have one of them, you are good. Most of the rules they share are the same. Then use a property testing thing. You can either go for formal verification, go for a tool like Satora, or you can go for a fuzzer like Echidna from Trail of Bits. The difference is basically with formal verifier, you'll have guarantees that the property you are testing, maybe you are saying that X should always be less than 5. A formal verifier would give you a mathematical proof that there is no code path possible where X can be greater than 5. So you'd be like 100% certain in that case. On the other hand, a fuzzer would just keep trying random inputs to sort of, you can customize the inputs, but let's just say it would keep trying random inputs and see like in any scenario, in any path of the input, does the value like breach your condition? Does it become greater than X? So you will never get absolute security with a fuzzer. You would get probabilistic security. Like the longer you run the fuzzer, the higher chance that there is no bug. So yeah, in theory, formal verifiers obviously look good. The big gotcha with them is it's very hard to formal verify complex things when there are too many code paths. It's just not possible to do it with a formal verifier, so you have to fall back to a fuzzer. And fuzzers are also usually easier to use. So my recommendation would be for simpler things or things that are super important, super critical, go with a formal verifier like Satora. For things that are like maybe too complex, that are like integration of yarn curve and I don't know what not, some V tokenomics and all in one function. That thing you just can't do with a formal verifier. So go with a fuzzer, just try random inputs, let it run for multiple months or something, and hopefully it won't find anything. But fuzzers have actually found issues. I remember, I think it was consensus diligence solidity fuzzer or something that found an issue after 3 months of just continuous fuzzing. So it can take a while, but like even that single bug can be quite useful. The last bit, obviously, get peer reviews and audits. I know it's hard to find audit slots right now for any of the good firms, so you just have to ask your friends to do semi-audits for you, but that also works. Oh yeah, so I was collecting topics about this talk at 4 a.m. today. So what should I talk about? This was the tweet. Don't tell the organizers my slides weren't ready till now. So I'll just rapid fire answer some questions I got from my Twitter tweet or whatever. Oh yeah, so this is something I just talked about. There are certain things that harm the UX in terms of security. CAPTCHA is the most, I think, relatable experience. Everyone hates CAPTCHA, but they are super important. Other things like slippage protection can be one thing in AMMs. Like most of the people don't realize what slippage protection is doing, but it helps you from being sandwiched in most scenarios and all. But it also can lead to some failure of transactions or trades when the prices are moving very fast. The asset is very volatile. It's dumping faster than Titan or something. So yeah. Can users trust DeFi if they can only review the smart contract? It really depends on the smart contract. If the smart contract does not depend on an external factor, it's a self-contained smart contract, then yes, you can just trust the smart contract. A good example would actually be Uni's V2 code base, assuming it is decentralized. There is not much Uni can do to rug your stuff. While there are certain code bases where the owners or the DAOs can actually upgrade the contracts or whatever and steal all of those things. So in those things, you can't just depend on the smart contract. You also have to depend on the DAO itself or the people controlling that power. So will you post a recording or will there be a live stream? Probably should have answered this first, but yeah, I think there is a live stream going on. Is deflationary based assets. So yeah, like a lot of ETH folks would disagree with me, but I would say like deflationary assets for a platform that wants to get used is a bad thing. I don't think you should be like deflation basically promotes users just to hold tokens. We want users to actually spend their tokens, build cool shit. So I don't think deflationary model is a good bit. The only gotcha there is Ethereum is not deflationary, not even in ETH2. It might become deflationary if it gets a lot of usage. If it gets usage more than it can possibly sustain, then it becomes deflationary. So it becomes a self-balancing model where like the system actually wants to slow down growth so that the nodes and all can keep up, or the gas prices don't like go crazy and all. So if it's being used a lot, then it becomes deflationary. But if it's not being used a lot, then it would remain inflationary and it would be promoting use of the token. So that model fits. But if there is a lot of DeFi tokens just launch and say like we are deflationary from day zero, even if you don't use it, most of them are Ponzi's. So what audit really accomplishes? So everyone has to understand audit does not guarantee anything, especially code audits. Financial audits are a completely different beast. You can verify things mathematically, but when you are doing code audits, you just can't verify things. You can only sort of do peer review in some sense. You can, again, it's not a check mark, it's a scale. You can move towards a good quality scale, but you can never just say this is audited, this is safe. That can never happen. So now about the bridges and all. Yeah, so in DeFi, this is something I was just talking about someone. A lot of hacks sort of just happen in clusters. So people just figure out a new attack vector or a new attack surface, and most of the protocols that are using that attack vector or surface just get exploited. So when the flash loans came in power, I think BZX was the first one that got wrecked. All of the attacks just immediately become flash loan based. That was all of the hype because that was the latest attack vector. People hadn't realized that ditch yet and were just falling in it again and again. These days, bridges are the new hype, wormhole, the Ronin thing and everything. So bridges are the new attack vectors. That is what the attackers are targeting right now. So bridges should remain careful, but they should make sure their code is safe. But that's the latest thing in this space right now. So yeah, everyone's going after bridges. So principles that developers should consider. Again, the checklist I give, that is good. The balance you need to find out in the space, that is good. It really depends on product to product. I don't think there's any general advice apart from what I've already talked. But just think about your product, think about how much, what balance you want to find there, and go with it. So Vitalik's multi-chain and cross-chain thing, I agree with him on some bits. So one is, the future is multi-chain. I agree with him. If you find ETH maxi or even BTC maxis, they are just either lying to themselves or I don't know what they are doing, but I can guarantee you the future is multi-chain. Just imagine if cars were created in the 19th century and we only had one brand creating cars. That won't happen. You'd have specializations in different spaces. So it might be that ETH might be the best one for DeFi, Solana might be the best one for I don't know, shitcoins, and other chains for other things. So there might be different use cases, but there will be multiple chains. No offense, Solana is great. Solana is doing great stuff, but this was just a joke. So yeah, next thing. Well, that's a comment, so I'll pass that. I didn't get time to edit it properly, so apologies for that. How protocols valued at 10 billion should have bug bounties? Yeah, I mean, with that, I'll say in this space, I think we really need a company like Zerodium. So if someone is from traditional security field, Zerodium is basically a company that buys zero-day exploits. So if someone finds a bug in like Facebook and they can access Facebook, just log in into anyone's account, and they go to Facebook directly, they might offer them like 100K bounty. What this dev group or this security researcher can do is reach out to Zerodium instead and sell the zero to Zerodium. All of this is legal. I don't know how, but it is. Zerodium would likely pay them in millions, and then Zerodium would, with their lawyers and all, negotiate with Facebook and I don't know what, get probably even more for that bug. Or just maybe sell in the black market. So in any case, companies like Zerodium that can guarantee you fair market value for any bugs would be great in this space. I personally, I have reported a lot of bugs. In fact, like once I reported a critical bug in a layer 1 chain. I got a bug bounty of $250, even though the stake was like tens of billions of dollars. I wasn't even angry about it because for me, like I wasn't doing it for the money. I was just doing it for fun, for education and all. So it really depends on the motivation of the person. I think from that incident, I learned a lot more than what money could have like made me or like earned me or whatever. So I don't want to put exact numbers for different types of bounties, but yeah, I do think there should be some intermediary who like guarantees fair market value for bounties. Deflationary base asset, I think we have already talked about this, and the security culture. Yeah, like 90% of the projects launching that are present right now, honestly, I think won't exist 5 years later. People are very bad at optimizing that trilemma. Everyone is just going for that usefulness. People don't care about risk. People don't care about security. There is no budget for security. Projects are launching without peer reviews, without any audits. I know like projects that have like billions in TVLs and have no audits. So it's scary. Like those projects, I feel like won't survive long term. I might be wrong. Hopefully, I'm wrong. But yeah, that's how it looks like. And that's all I had on the agenda. But I'll open it up to any questions if anyone has.
Yeah, let's get to questions. I was taking some notes. So follow best practices, reuse safe code, keep it stupid simple, right? Mind the ditches previously visited by others, Ronan. Monitor your bridges. All right, so do we have any other questions that, oh, you're right here.
Hi, thank you for that talk. So the blockchain is moving very fast in terms of innovation. Do you think security is also moving as fast as blockchain, or are we barely scratching the surface as an industry? Thank you.
So with security, unfortunately, it always lags behind development because it rarely happens that someone develops a security product for something that doesn't exist yet. It always happens that a product launches and people realize it's not safe, so people start working on like how to make that secure and stuff. So even in blockchain space, since we are growing so fast, security is lagging. It's lagging more than the traditional world with the development and the you won't get completely new primitives every day in the traditional world. So you don't need new security tools every day in the traditional world. So even though security lags behind the latest stuff there, it's still fine. A good example would be antiviruses. You will see they keep updating every day. They have now added behavioral analysis, but you know they only update the database when they actually like see the bug. The viruses are the latest ones at least are always one step ahead. So yeah, in the blockchain space, it's even more like focused in the sense that we keep dropping new protocols, new primitives and whatnot every day. The security space just can't keep up. So it's a tough situation, but yeah, over time, I think it is getting better.
Yeah, hi, here, this. Yeah. So you mentioned about the budget problem, and then obviously in the Web 2 world, we've been seeing that also. Like, you know, security is considered to be a cost center. You know, we don't get the kind of reward, and then. So what kind of typical budget would you recommend for companies? And if we categorize, let's say, bootstrapped early stage versus growth stage versus matured, Do you have any ballpark number or percentage or any suggestions?
Sure. So putting a number again is very hard. Depends on the product. Depends on the range you optimize for. Like in general, I say like 10% of your engineering budget, at least 10% of your engineering budget should go towards security. So that would include like audits and all. This is the like the number we use in the traditional world, especially like if you're building any project, at least in the traditional world, 10% is the standard accepted amount. In the DeFi world, if you are just starting up, you don't have a lot of money to burn on security and all, 10% is fine. But as the project matures, I feel like more of the engineering budget should move to security, because like smart contracts are not upgradable. What are you going to do with all of that engineering budget when your project is already live? There should definitely be a research budget, super high research budget, so you get to know about your next, like what you will be building next. But you should be spending a lot on maintenance and security as well while the project is live.
All right. Any more questions? We maybe have time for one or two more. Just raise your hand. Okay. If not, let's get Moody a big round of applause.
Thank you, guys.
So we are still about 10 minutes ahead of schedule. So if we can get all the panelists up here a little bit early, that would be great. Otherwise, we will see you here at the bottom of the hour, but we'll try to start a little bit early if we can. Yeah. Yeah, we're gonna, it was supposed to start at the bottom of the hour, but if we can get everyone in here, we'll start early. So you can either go ahead and sit down, or yeah, it should be at 6:30. If everyone gets here early, we will start early, but if not, yeah, we'll start at 6:30.
Gracias. Hello, everyone. Can you hear me? Okay. So today we will talk about interesting topic. And the title of the topic is Why Building DeFi Sucks. So we'll have three parts. First of all, we'll introduce the speakers here. Second, I'll ask some questions. And the last one, anyone can ask the questions from the speakers about this topic. And you can complain about anything, you can raise the gossips, you can ask whatever you want, to be honest. And the more interesting questions you have, or most interesting question, will receive a nice t-shirt, the Lobster DAO t-shirt. I lost my friend Olga. She's wearing this t-shirt. But yeah, this is a t-shirt designed by Klibansky, and this is a lost NFT from the Lobster NFT collection. So just a bit later we'll show you. So I'm going to start with the questions. The first question is, please introduce yourself, and who are degens?
Hello, testing. Can you guys hear me? Perfect. Yeah, my name is Akil. Work with the EF. Have led UX in this space for quite a few different projects, helping with status nodes, leading some of the design work for the different client teams. So I actually don't have too much context from the DeFi side of things, but bringing context from being in the space for leading UX projects. I think degens are individuals that are quite enamored by the DeFi space. Okay. So people that actually have a good understanding of what's happening in the ecosystem, not myself, but people that go ape with anything that they understand. So would love to kind of hear more interpretations from individuals who are actually involved in the DeFi space as well.
Thank you so much.
And I'm Peter Jubb, Executive Creative Director at Blockchain Foundry, also co-founder of Last Known, which is an NFT marketplace. So at heart, I'm a UX designer and UI designer and content strategist. So I guess my opinion of degens is like cross between like Wall Street Bets, jokes about your wife's boyfriend, etc. Okay. But someone who's into crypto as well.
So hi everyone, my name is Sergey. I'm co-founder of 1inch Network. 1inch Network is it's difficult. It's a set of it's a distributed network of decentralized protocols. It includes aggregation among decentralized exchanges and DeFi itself. We actually invented aggregation in DeFi space before DeFi starts to be DeFi. Back in 2019. Degen is for me someone who knows DeFi, decentralized finance very well, and is looking for profit and likes memes.
Thank you so much. The question, Sergey, to you. How many of them are real degenerates?
How many of them are?
How many? The ratio. Yeah.
Once again?
How many of the degens are really degenerates?
I didn't get it, I guess. How many degens?
How many of them, yeah,
are real degens? I guess every degen out there is unique, really unique. Based on what I see in the shitstorms, I get almost every month.
Okay, thank you. Next speaker.
Hello. Hey, so I'm Mudit. I'm leading security at Polygon. I'm a technical partner at Delta Blockchain Fund. I've been doing security, traditional security for 10 years. I got into blockchain like 8 years ago. I've done research, a lot of development, and now just doing security again. That's brief intro about me. And as for degens, like I'll define degen as anyone who sort of is willing to become a friend with me. That's like my definition. Anyone who wants to call themselves a degen is open to call themselves a degen. I don't add any filters or anything like that to it. If you want to be a degen, you are a degen.
Thank you. Next speaker.
Howdy. Boring Crypto. I've Solidity Dev. I've created the code behind Bento Box, Kashi, Magic Internet Money from Abracadabra. Degens, I think, are just like kind of like an extreme version of early adopters. So I think it's great to have them in this space.
Good opinion. Next speaker.
Yeah, hi, I'm Ansgar. I'm a member of the Quill team. We do core development, so actually a little bit removed from the DeFi space naturally, and like the way I like to think about it, also about degens, is basically people who just are the very first adopters, the people who like jump on the ship to, I don't know, settle in a new place, to maybe jump on the rocket ship to settle a new planet, right? Maybe the very first people where it's still a little bit crazy, still kind of reckless to take that risk, but also very exciting. And we are actually the people building the ship, and to the extent that maybe some aspects are not great yet, and I think that's what the panel is about, we want to figure out what of that is our fault and how can we build better ships for all the degens to go settle Mars. So that's why I'm here.
Nice metaphor.
Hey guys. I'll just take that. You can have that. Hey guys, I'm Christoph. I'm a product manager and a researcher at Nethermind. And I'm also an Ethereum core developer like Ansgar here. If I had to define a degen, I'll just say that there are people who are like chasing high APY, like the early adoption, don't read smart contracts that they invest in, and just in general have a very, very high risk tolerance. Sorry.
Yeah, when the APY is too good, you are the APY. Hi everyone, my name is Igneous Tyrannus. I'm the head of communications at Bybit, the third largest crypto exchange in the world. Maybe the odd one out. I'm not a developer. We are from a centralized exchange, but we are always very interested in the DeFi space. We truly believe this is the future, and we are actively supporting it through investment, through running hackathons and supporting developers through kind of looking at their projects and so on and so forth. We also have we are the first proponent and ongoing supporter of the world's largest DAO by treasury size, BitDAO. It has more than $2 billion worth of tokens in its treasury. It has already allocated $633 million worth of tokens to various pursuits, including $200 million to develop a zero-knowledge ecosystem. So DeFi space is a passion and a focus of ours. What is a degen? Well, the way we see it is it's a segment of the customers we want to serve. Essentially, people who are looking for high risk and high returns, and they are really, really keen and vociferous about expressing their opinions, because we really see like taking risky positions is also just a way of expressing their opinion.
Hi, my name is Talal. I'm the founder of CoinMina and founder of Tranche, a DeFi protocol. First, I want to acknowledge that the panelist to audience ratio is insane. When they're saying, like, please, all panelists come on stage, I did not expect that. As for degens, I think there's something called degen score, where you can just put your address and it'll do a bit of calculation for you to see how much of a degenerate you are. But I guess it really boils down to degenerates are people that want to make financial returns, try out new products, and ultimately don't give a shit that whether they make or lose money, as long as the thrill is there. So there's, I guess, crypto adrenaline junkie, if that's even a word.
Thank you so much. So in the end, we know that degens means decentralized generation. Right? This is where it comes from. And some of them are degenerates. So nothing to do. And right now we have blitz question, just one or two, option one or option two. I will ask each of you, and after that we will discuss a little about this. What is better or has more perspective for EVM mass adoption? Optimistic Labs or ZK Labs? What do you think?
Optimistic.
Thank you. Next. ZK.
ZK.
Thank you.
ZK.
Thank you.
ZK.
Awesome.
I don't know enough about it.
Both.
Both? Okay.
Initially optimistic, then ZK.
I like this answer.
Yeah, actually, I like that. I was going to say that.
Okay, okay.
ZK for me.
ZK. Okay, why I'm asking this question? I'm asking this because we have to understand the context of the speakers, and we are on the Ethereum conference, and my opinion about this, about optimistic rollups or ZK rollups, is same as guys mentioned. Now we have optimistic, which is onboarding, and then we have ZK rollups. But users or degens, they don't care about how it works, to be honest, as far as I know. So for them it doesn't matter, but for us it is. And another question is open question, so any of you can answer this. What is the use case or the protocol in crypto or DeFi failed its product market fit recently?
Almost all.
What use case or protocol in crypto DeFi failed its product market fit? So I can answer this question, and probably you will find. So for me, the prediction markets, one of the most hyped use case of the crypto, cannot find its product market fit. What do you think about other cases? Yeah.
Hello. Yeah. So one thing, one product / use case I feel failed to find its market fit is fixed interest rate lending borrowing. So Notion, Yield, and protocols like these. These like fixed yield stuff is like top of the, like it's used a lot in TradFi. But not a lot in DeFi, because like the main usage for this is in regards to hedging, and there just aren't very like on-chain hedging strategies. Most people just hedge them off-chain. So yeah, that's one space which just never took off.
Okay, interesting. Any other case you think failed its product market fit?
Maybe those protocols which were hacked.
Of course, but it's not about product market fit, it's about competency. Okay.
Insurance probably as well.
Insurance, you think?
Like
it's a good point.
We can barely quantify risk in the real world, let alone quantify risk and try to manage that in DeFi. So insurance is definitely a big one.
But why why it's failed its product market fit? What do you think? Why it's overall sold?
Because it's overly complex, and it, like insurance companies fuck it up in the real world. So
of course.
Let alone what's going to happen on chain. So
you think that people, they don't trust the insurance protocols, that the funds are really insured?
No, it's not that. I think that the way that it's built now isn't sustainable. Like if the insurance protocols are basically bailing you out in the same token of their protocol. So if it failed, then they won't be able to repay that premium. In the traditional world, if that happens to an insurance company, there's Munich Re, Swiss Re, so reinsurance companies, and that in DeFi hasn't reached that stage of maturity.
Also, just kind of like insurance is done very differently in the traditional finance world, where you have actuarial tables to kind of like investigate the likelihood, probability of something happening. Whereas in DeFi, it's really just kind of like, as my fellow panelist said, it's bailing someone out, and then you're basically just playing a numbers game instead of really kind of like make it very scientific and really just like based on a mathematical model that is statistics and data driven.
I have one, derivatives, and I think because degens, they don't get it.
Okay. So if degens, they don't get the idea of the protocol, they are not using it, right? And they don't know what to do. Interesting.
I wouldn't say that it failed, but smart contract wallets, I think, still haven't hit product market fit, right? If you define it as having incredibly high adoption among users. So these days on Ethereum, the vast majority of users still use EOA accounts, and that's quite risky for them. A single private key controls all their funds, and if anything happens to that, if it gets lost, irrecoverable, and if they get stolen, all their assets are gone, right?
Okay, I agree.
I've maybe, sorry to drag this out too much, but I have one more DeFi-related thing that I would want to see is that experimentation with stable coins that are not pegged to the US dollar. I think it's somewhat ironic that that crypto was originally like a way to get rid of the US dollar, and now it's kind of enshrining the dominance of the US dollar in global finance. And that doesn't have to be a bad thing, but I still would at least like to see some experimentation, well, some more at least than there is with non-US dollar-based stable assets.
This is a very good point. I also surprised why we have only, liquid dollars, not euros or whatever. Good, interesting. So, and right now we will start from the topic of the discussion: why building DeFi sucks. Of course, one of the reasons why building in DeFi sucks is you can spend a lot of time, efforts to build the protocols, and after a couple of years, it will not find the product market fit. So you basically, lost your funds, you lost your energy, but somehow it doesn't work. And but we will right now we'll go to the theses which written by Andrew Cronier, one of the DeFi influencer and builder. And it was interesting story because 2 years ago he published part 1, why building DeFi sucks, in the end of February. The part 2 was published at the same time a year ago. And I was expecting part 3, like right now, but we know what happened. And right now, I'm going to raise some theses from his articles. And the first thesis is, no matter what you do, they will be unhappy, and they will make a point of telling you so. So the question to you guys, is that true? Are you facing that within the development or not?
I can speak from my personal experience. So we got like already 100 times shitstorm on Twitter, and it's partially true, yeah. But everyone who get this shitstorm, those degens or people who are using your service or your products, your protocols, are unhappy about anything. You shouldn't take it personally. What is the case from our point of view in Andrei Cronier? They call sometimes people to join a fight in a cage or a box fight. Actually, I did it also once. It was just a joke, but this guy took it seriously. Yeah, I try to not to taking care about that. Just keep building and yeah, continue innovating.
So let me summarize. We shouldn't, as a builders, we shouldn't take it personal, right? And this is how we can protect ourselves from that.
Yeah, I was just going to add on to that's true for any product development roadmap, that people are going to have complaints, etc. But I think one key thing to kind of look at is, we talked a lot about UX problems with MetaMask and other things in the ecosystem, but when NFTs found that product market fit, no one cared about those things. Yes. Users came in that would have had difficulties using MetaMask 2 years ago, but they're complete experts in using all those technologies. There's obviously been a lot of work done by people like Foundation, Rarible, et cetera, to onboard those individuals. But once there's a good product, there's a good value proposition for those individuals, they take the time to learn those technologies. So like 2 years ago, we were talking about all these complicated workflows to make MetaMask a bit more usable for these newcomers to come into place. But all of a sudden, all these millions of individuals came into Web3 and had no issues. They might complain, but at the end of the day, they found value in the ecosystem, and they captured it more than most of the individuals that were already there.
In my world, it's like, why does anything suck? Why does any design or any technology suck? And really, it's fundamentally 3 concentric circles that makes for a good product, and that is technology, it's business, and it's user experience. And this industry is so new that it's driven by the technology, it's driven by the engineers. They're designing things, and it's driven by business. So you only have to go to Binance or KuCoin or Gate.io to see it's a spray and pray mentality of like, try to get them to use this product. And they haven't done any investment in user experience or testing. And that's really where the gap is. And the user experience is where the gap is. And so I think that's just going to happen over time, that it'll just get better.
So do you think that the best user experience will prevent us from, bad users? I mean, not bad, but somehow offended users. What do you think? It's a question to you.
Yeah, I think like over time the experience will just get better and they'll stop complaining. There's plenty of industries that have just shown that over time, like whether it's a fitness tracking app or a Facebook, from MySpace to Facebook, it's the social network's always been there. They just advancing it and making it more confined and more typical. And yeah.
Thank you.
I would like to add to this. It's actually cool to get feedback from the community. It's also if it's also really bad, it sounds really bad, and but it's still a feedback, so you can improve your product. So I don't like also to use MetaMask because it's terrible. But I share my feedback, but yeah, they don't care. I personally care about any feedback. So also if it's bad, it's cool to improve the product.
So coming from the startup space, like just like the worst thing that can happen to your project is that you have no users. So
Yes.
if you have complaining users, you're already in a really good spot. That's just what I want to ask.
I think the worst thing in DeFi is if you have a lot of holders and 0 users. And this is like, pretty strange situation because holders, they are always complaining when price go down, right? They don't care about user experience. They don't care about what you're really building. So this is why I'm emphasizing this topic because, yeah, in DeFi we have users if you have protocol without token. But if you have token, you have a mess situation here. So. Cool. Let's go to another question about conspiracy theories. Because another point he mentioned was why DeFi degens or users, they are so actively looking for conspiracy theories. Why? What do you think? So who can answer?
I can maybe go. So that comes down to, I guess, the point you mentioned that token holders are usually more aggressive. That it goes hand in hand for all retail investors. They don't like to lose money. In DeFi, the problem is most of the users are actually token holders for most of the products. Obviously, there are products like, for example, MetaMask, where nobody is a token holder, or everyone is. But in most DeFi protocols, most of the users just do liquidity mining and all, and have some of the token exposure, so they have the investments going in. So it's like, if token up, project good, token down, project bad, doesn't matter what the tech is. If you just look at the volatile movements, some tokens have, like even Spell token from Abracadabra, like it has gone, I don't know, 10x and like 90% down without a single change in the protocol itself. So that's all like the token holders playing it. And that's where all of this toxicity comes in when people are losing money. And this is why people feel like most of the users are complaining. At the end of the day, it's not the users that are complaining. I think the complaints from users, the feedback is actually good. The complaints that hurt are from the token holders who just ape in without understanding and then are mad for no reason. Like devs can't do anything about it. Everyone keeps asking devs to do something, but we can't.
Devs do something.
Just nice.
Yeah, so
do something.
Yeah, exactly. And coming to the final bit, what was the question?
It's okay. You already answered this. About conspiracy theories, of course.
Oh, yeah.
They have
So,
it.
yeah,
I want to build on that actually. I think there's a problem with DeFi inherently, the customer acquisition method they're using. Like when you use kind of APY to entice people to join you, and like lots of times you have those kind of like alternative smart contract platforms, how they kind of initially get those developers to move from Ethereum to build on theirs is because they got those infusion funds from VCs, and they use that to attract developers. But when you have the wrong incentive to attract people in the first place, of course you will have the number, and in time, maybe there will be something that kind of like slowly congeal, slowly kind of like start to shape up into something that is more mature. But initially you will always find just like when you use mercenary capital to attract people, then the liquidity you attract is going to be mercenary as well.
I'm not rage quitting, I have to be on the other stage, so thank you, appreciate it.
Thank you. So in the part 2, he said that the real users in DeFi are scarce. So can we count token holders as users or not? Or it depends?
I'll just add to it. That's the point like I was making, that in DeFi, most of the users are actually just token holders. So I think those are two different classes. Token holders can definitely be users. Users can be token holders, but the properties they show are different. Users are usually the people you really want to get feedback from. Token holders in a lot of scenarios are people you don't really want to get feedback from unless they actually use the product and understand it. So yeah, like although they can be the same people, their like mentality is often quite different.
Okay, and other opinions?
Yeah, I mean, projects such as Compound, like am I a Compound user? I farmed Comp when it started, and now I hold Comp, but I haven't used it in over a year. I don't know who has. But basically, Ethereum, I'm definitely an Ethereum user because I pay freaking gas all the time. So I think if you like superimpose two diagrams on top of one another, the projects that are successful are ones that have a very high user as part of their token holder base. But you can't consider them the same because I don't consider myself as a Compound holder. Don't mean to pick on Compound specifically, but it's because I'm sure many people farmed it in the beginning of DeFi summer, but no one really uses it now. But yeah.
I would like to add, I would say make token hodler to be a user. Yeah. So like a good example with Ethereum. To send a transaction, you need Ethereum. So also, in all the economics out there, every protocol should make the token hodler to be a user. Yeah, you need a kind of logic behind that. So your token is for using utility, not a security for holding.
By the way, one way to think about it is imagine every time you bought an iPhone, you get like an Apple share. That's basically the way that it's being done, right? Every time you use the protocol, they give you this token to kind of align incentives. But it has gone overboard for sure because humans love gambling, and this is a very easy way to have gamification of gambling, I guess.
Yeah, good point, actually. If your token can be used, you have users, right? If your token cannot be used, you don't have users, whatever you are doing. Okay, the question here is, in your experience, the weirdest user feedback in your career you ever seen?
I like this example with a dev do something, the price is dumping.
But this is basic one. It's 90% of requests, right? What else? Like the weirdest user request or feedback or question?
As a centralized exchange, we've received shitloads of weird requests, but one that particularly stands out is Bitcoin withdrawals to like a physical address. So I guess that's something you wouldn't find in DeFi. You'd only find in centralized exchanges.
Let me repeat. You met the situation where the user tried to withdraw Bitcoin onto the physical address.
Like apartment number X, and like, upset that we didn't process the withdrawal.
Like he was thinking it's kind of like a metal coin, or
yeah, I mean we're pretty retail focused, so it's not hating on anyone. I didn't know shit when I started, so but yeah, it's a funny request. You know, why haven't I received my withdrawal? And then we checked LogRocket to see. Because there's like address validation. If you try to send it to a non-Bitcoin address, it doesn't go through.
He literally inserted his address.
Apartment number, street, address, yeah.
Okay, this is weirdest one. You know better, Case?
I have one, maybe one more. Please see your refund. Because I did small mistake and swapped with high price slippage.
Okay, yeah, this is pretty often thing in DeFi. There people are sending money directly to the contract without interacting with it, right? And then they are trying to, send funds back, but you can say that we can't. You didn't interact with the contract. You sent money to that, and but it is very hard to explain to user that it is his fault to do so.
But this is, again, user experience. You as dev, you should have rescue funds functionality theoretically.
So in my experience, I met one guy who did it, but it was impossible in UI. So even no address, it is very hard to understand the address of the contract if you don't have it on UI. But somehow user did it. because he was thinking that he was the smartest guy in the universe, and you know what's happening. So, okay, the last question from this side, and then I will start asking you guys to ask any question regarding this topic, any pain points you have. And the last one second, and the last one is. So, the thesis is your success belongs to your community. We all know them, right? But your failure is 100% your own. This is thesis from Andrew Cronier. Do you agree?
I fully agree. So if you write a code and you have a bug in it, so from my point of view, you're responsible in it, not the user who is using and trusts you potentially because you have already a good reputation. That's why we have seen a lot of hacks in Andrei Cronier projects, and because he didn't care about the security audits, and he said, I built it for myself, but promoted it for everyone, and everyone trusted this person. So it's yours if you have built it.
That is somewhere I'll disagree. So I'll say, obviously, success is not only yours; it's the community's and everyone's. In case of failures, it depends, I'll say. For some protocols, some products, it definitely is like the developer's fault, 100% of it. But for some other things, it's not. Like everyone is a human. All the devs, everyone is humans. We make mistakes, and you can't just blame like anyone for a simple mistake someone might have made. If it's a repetitive thing they're doing, then definitely it's a problem. But otherwise, it's just a mistake. Everyone makes them.
Even if you are testing in prod?
If you do it very too often, then yes, that's a mistake.
Okay.
That's a bad.
Thank you. Any other opinions?
Maybe to also answer that from the perspective of the base chain, I would definitely also say that for Ethereum itself, like all the success that Ethereum has been having over the last few years, that was all the users, like the amazing experimentation, all the use cases that no one could have thought of, that all these people building things just came up with, developed, made happen. And that's all right, their success. And then possible failure cases, I really think it's just about if the core developers of the chain are not able to keep up with innovating fast enough to keep enabling all these features, right? So that would be our failure. So I think it's a situation where this very much holds true for the base chain as well, and we're trying our best to not make it our failure, but enable all of your success.
Okay, next.
Luckily, at the base chain, it's very, 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 very difficult to actually fail. Like EIPs take many, many years to go through the whole process. They get audited by tens, 20, maybe even 100 people, right? Well, how's it a failure if it's audited? It's too slow, yes, that is a problem, but you're not going to introduce a bug into Ethereum consensus then, right?
Any other opinions about the thesis that your success belongs to your community, but the failure is 100% yours?
So I actually find that the communities tend to be incredibly forgiving. Like I'm completely amazed how some projects just, it's truly their fault. Like they lose hundreds of millions of dollars for their users. 3 weeks later, they launch V2 and everyone apes back in, right? So. Yeah, I think actually, in general, there might be a quick blowback, but then it turns around and you get the other side as well. So,
I like to say, like, it's all about the testing, right? And what I like to say is you can always outsmart your users, but you can't outstupid them. And in many respects, they will do things that you had never thought possible. One time when we were testing a lottery app to scan a lottery ticket, we gave the user the app, and we gave the user the ticket. And 4 out of 14 users took the ticket and rubbed it on the face of the phone. And we were just like, well, how is that possible? And that would have equated to like 400,000 people who would have made that mistake. And it was all because we didn't use the right icon. It should have been a camera icon and not a barcode icon. And that would have been our call. Like, so many people would have screwed up, and that would have been our fault. And so that goes for just about anything. So test with real users?
Test with real users? Are we talking about social experiments?
I have also to add, it's not only about tests, it's very important, but also security audits is very important.
Yeah.
So from my point of view, right now in DeFi, when you publish something, you should audit your code from everyone who is offering this service. I know this is expensive, but it helps, so based on our experience.
Thank you so much. So right now we have a time for community questions, for audience questions. Please put your hands up and ask any questions regarding this topic. Yeah, we have one. Please help.
Okay. Where are you at? Raise your hand. And stand up. Where are you at? Over here.
Hey, what game changer are you expecting to come, or what game changer are you waiting for in DeFi, and when do you think it might come?
Please repeat again.
What game changer in DeFi are you waiting for, and when do you think it will come?
Good question. One.
Maybe I can go first. So, to be honest, I feel like most of the primitives that had to be created have already been created. There might be a few that come up over time, but if you think about it, there has not been a really new, big, innovative primitive in a while in DeFi. I think these will just keep getting better and more mature over time, and it would be like a slow, constant growth from now on, rather than this sudden jump that happened in DeFi summer.
So, guys, any game changer you see in the industry?
I think just the user experience need to be so much better. At the moment, most of the people who are using it are, developers themselves or people who kind of like have been farming since even before DeFi summer. Like, you still don't have a very solid, compelling case for mass adoption, and like institutions are looking at it as well, but it's still very difficult for them to even tap into like those that is currently being offered. It's just a very, like, when you look at Web3 design, like we talk about kind of it gives power to the individual and it's decentralized and all that, but like the design, the user experience is just not there for true mass adoption to happen.
I have one, fully permissionless money market by 1H.
Okay, nice shoe. Any question? May I ask you, may I answer the question about the next game changer? Right now I see some convergence between classical finance and the DeFi. So probably we'll see something on the horizon of synthetic assets, indexes, and the games around the tokenization of like real assets. I just feel this vibe is going on. So this is my answer. Any other questions, guys? Okay, we have one.
By the way, on the game changer side, even though I don't really like it, but I think permissioned pools, what Aave is doing, will bring in institutions, and institutions have significantly bigger pockets than we do. So I think that will be a game changer in terms of how important DeFi is on a global scale.
Yeah, hello. So what are your opinions on like regulations in DeFi? Like, should it be completely unregulated? Should it be like partially regulated? And what sort of regulation should be there?
Regulations in DeFi.
That's a tough question, but I'll say like it is and should be regulated. All of finance, like if you think DeFi is, there are no laws around it right now. But it's not like if you earn money on DeFi, you don't have to pay income tax on it. It's all, any financial activity is regulated. That's specifically why institutions haven't adopted DeFi yet, because although it's regulated, the regulations themselves are not clear. So it's a gray area. Over time, as he mentioned, like permission pools are ways making them that would come up. Sushi is actually working on them, some alpha for you. So there would be permissioned AMMs as well and pools as well in the future. And probably all of the DeFi would have some bit of permissioning. It's not like everything would get permission, so Aave wouldn't convert all of their product into a permission product. It would just be an option for that subset of users to use. And that would definitely bring in more volume. And yeah, I think that's what will happen.
From our point of view, we have to introduce KYC for DeFi, for those who are ready for this.
By the way, I don't think KYC has anything to do with proper regulations. I think it's very important to note that, like, it's a ticking time bomb if an institution have that much personal identifiable information. But I do think that regulations from an investor protection standpoint will come around because governments are gonna want to do that after, like, their citizens get scammed once, twice, 3 times. They're gonna have to do it. Are they gonna do it the right way? I'm not too optimistic, but yeah, I guess we'll see.
Following on, with this question, do you not see do you not consider this thing as if DeFi is actually sitting on the crossroad right now? Because if you go along the way of your mass market, then you are hitting the wall of regulation with KYC, with protecting all these small ticket clients and so on and so forth, which in essence kills the whole scaling sort of opportunities. On the other hand, if you go to the regulation with institutional investors and whatnot, then in essence you're not you're stopping with DeFi there as an idea, because they would need escrow accounts, they would need all these centralized and verified service providers that are not really truly DeFi. So is there an issue of how this DeFi actually need to walk? Which road it should be taken?
But here, institutionals, they have deeper pockets. DeFi, right? Yeah, the good question about institutionals, is it real DeFi or is something else?
It's gonna be a DeFi if we will have still the same composability. A good example with our ARCs, our ARC deployed under Fireblocks. So if under Fireblocks also Balancer would deploy and also 1inch would deploy, then 1inch can aggregate Balancer and also Aave, and we can make happen. For example, you can migrate from ADAI to AETH with just single click, and this is DeFi. Then maybe Uniswap will join it, and others. Maybe in the future we will not have only Fireblocks doing that. Maybe we need something more global, and maybe a standard for permission DeFi with standard for KYC certificates and standard to verify them on a smart contract level.
Sorry. At the same time, I think like lots of times, like everyone says they love decentralization, but we sometimes just forget. Kind of like something just says it's decentralized, and then we kind of like just think that's a virtue in itself. But decentralization should be a means to an end. It shouldn't just be a terminal virtue, and then so long as you are decentralized, you are good. Lots of times I feel like lots of protocols, they are over-indexing on the decentralized part, but not enough on what purpose or what use case it's actually serving.
Yeah, and what I just wanted to point out is that I think it's going to be really interesting to see how basically the relationship between the community and the development teams of the blockchains develops in the future, because as you were saying, basically as the community goes more mainstream, of course also so do the views in the community. And I think, so for example, there was a really interesting article, I think already 2019 or something, that basically Ethereum is effectively unforkable now. That just looked at the role of USDC and basically said that whenever there would be a contentious fork, whichever side of the fork USDC would choose to honor, that would be the only fork that survives, right? Because the other fork would completely cascade, all the DeFi would basically completely collapse and go away. So effectively, we are already like hard forking is a very important governance tool and also the decentralization resistance tool, and that's effectively taken away with this, like just by the effects that DeFi is already having on the chain. And I think in the future it's going to be really interesting. Do governments do the nice thing with regulation and it remains opt-in and maybe they force their citizens to follow along, or do they actually try and force the entire chain to play by their rules, right? And if there ever is a hard fork where on one side of the fork they enforce miners to follow specific rules or stakers or whatnot, and that is also the side that they force all the stable coins to live on, what options do we have, right? Do we have to start to compromise all our core values, or can we resist this? And I think this will be like a really important potential point of conflict going forward.
I think on the decentralization side, or like DeFi, decentralization is a spectrum. You can't say like it's black or white. The most centralized is sending a wire from Dubai to New York, where you go through your bank, who goes through a correspondent bank and SWIFT and all that, all these centralized entities. And then on the other side of it, if you're running your own node, managing your own private keys, that's more on the more decentralized side. But there's definitely going to be protocols that take all sides of that spectrum.
I would like to add, if you are talking about decentralization, how decentralized are we right now in Ethereum? If you look on the mining pools, there are like 4 big mining pools, and if 3 of them like put something together, they can scam everyone. And how many billions do we have in DeFi right now? So, you know, like we are not decentralized from our point of view yet, but we can be soon with like this. Upgrades of Ethereum.
So speaking about DeFi, we started as decentralized finance, but right now it seems like the main feature of the DeFi is actually composability, right? Because we cannot say that it is real DeFi, because smart contracts are working with the multi-sigs, and we have, I don't know, 3 people who can control the treasuries, and sometimes we don't have to blame them for their past, right? Some of you knows this funny meme recently, and so the composability, right? And composability is about the standards, right? It's not about users at all. It's about building blocks and then another blocks and then another blocks, and sometime builders, product builders, they will reuse them and build the products which are working with the many protocols, sub protocols, right? So the DeFi is about composability, not about use cases. And so guys, you have any other questions here? You have one? Cool.
Raise your hand. Stand up and raise your hand. Here? Oh, right here.
Hey, what's up, guys? Thanks for the talk. You guys were speaking about usability and developer user experience, and you mentioned MetaMask. What are the features that you guys would like to improve and to see for the next 6-12 months?
I would like to see all my tokens in the wallet. I don't like to add the token by myself, and I need a search field to find the right token and a sort functionality. Please prioritize that to the highest level. Otherwise, I have to write my own extension.
Which you can totally do very soon. Do we have any more questions? Stand up, raise your hand if you have a question. All right, I'm going to give it up to him so he can wrap it up here.
Okay, let's sum up. The good question is then token, then moon. What else? Can do devs something, right? And amazing question with the MetaMask. I have something to add here. Of course, all the tokens you have must be there, but sometimes you have a lot of spam tokens, especially on the cheap chains. You have like thousands of spam tokens, so there should be some kind of consensus approach for how to whitelist some assets and somehow sort them based on the balance, right? And another pain point is cross-chain. We have like many different chains, and you have to somehow switch between them.
We have seen a great hack in the last days, right? Like 600 million was stolen from the bridge. And yeah, great is maybe not the right word, but like, yeah, it can be terrible cross-chain implementations.
The question, the Anton from 1inch recently wrote the Twitter thread, and he agreed with Vitalik about there is no cross-chain, there should be multi-chain. What do you think? What's the difference?
I'm not sure. So, what I know, how we see it on 1inch is that this cross, like this, a lot of networks around Ethereum, it's just only for a short time. Layer 2 solve huge problems, scalability problems, and it's more safer than to move all the funds to a fork of Ethereum with no innovation technology behind that.
Thank you. Any other opinions?
I mean, I think it's kind of almost common wisdom in Ethereum to just go along with the multi-chain thesis, and I think in some extent that comes from not wanting to replicate the toxicity of Bitcoin maximalism, but I do want to point out that Ethereum itself very much bets on this layer 2 thesis, the modular blockchain, and I don't think in this world necessarily we will end up in a multi-base chain world. And so while that always makes one sound a little bit like a maximalist, I just want to put it out there that like I think it's very unclear whether in the long run we really have to live with all these terrible unsafe bridges, or whether we might get something better. So let's see.
I can add, like, I agree with the points Vitalik raised in his post. I have not read Anton's tweet, but agree with his points. But his conclusion that future is not cross-chain, I disagree with. I agree, like the point he raised, if you are bridging tokens from one chain to another, your security is basically reduced to the least secure chain. But the thing is, if you're bridging from, let's say, Ethereum to maybe Polygon, both of those chains have acceptable security for you, unless you wouldn't be bridging. So that is one case. And then I think like it's something like cross-chain will happen if there are, like, if there is a multi-chain world. I like to think of these chains as different countries, let's say. If there are different countries, people want to travel between different countries. You just can't like stop travel between different countries. If there are better opportunities in a different country, people will migrate to that different country. So cross-chain will happen. Doesn't matter if you like it or not.
So guys, we have only 1 minute left. We have to decide the best question from today's panel. And my suggestion is the MetaMask question, because it was, you know, the pain point. For everyone, basically, yes. And congratulations, you won the Lobster NFT t-shirt. Thank you so much.
All right, so we are 10 minutes away from the end of ETHDubai 2022. So we just have one more lightning talk left, so if you could just hang around for a few minutes, it's really quick, and then we will wrap this conference up. This has been a great crowd. I'm going to go ahead and hand it over to Mirko Garasso. He is one of my colleagues over at MetaMask, and he's going to talk about how you can build plugins with MetaMask using MetaMask Flask.
Hello. Yeah, pretty good timing of the panelists saying nice things about MetaMask. But yeah, I'm Mirko Garozzo. I'm a Web3 engineer at MetaMask. I've been working Web3 for a number of years. Thank you. What I really like about Web3 and what really kind of makes me stick around this field is that I love how decentralization allows developer creativity to build amazing things. That's why today I'm super excited to talk to you about MetaMask. And especially a project called Snaps. So Snaps is what we at MetaMask consider the most important feature in our roadmap. Simply put, a Snap is a program that runs on top of MetaMask in a sandboxed environment, and it extends the MetaMask core functionality without asking MetaMask or anyone else except for the user itself for permission to use the Snap. any developer can build a snap. That's why we refer to it as decentralized web, because it really allows a developer to make amazing things and to take Web3 development to the next level. So what can you actually build on Snap? So some example use cases. Let's say you want to connect to Solana or Terra Luna or any non-EVM compatible chain. At the moment, with MetaMask out of the box, this is not possible. But with Snap, you will be able to do it. Or if you want to connect to something like Filecoin, if you want to integrate the shards and metric in MetaMask, and really anything that you can think about it, you will probably be able to do it. So why Snap is so important for Web3? What Snap really does is empowers developers to implement things that are not currently present in MetaMask, are not available in MetaMask at the moment. But what I think is the most important thing is that by building a Snap, you can find a way to increase visibility to your product. You can contribute to the Web3 community, and you might think about a crazy way to monetize the Snap and make tons of money. And also, you will have access to a community of 35+ million users that use MetaMask monthly. And I cannot think of any other Web3 platform that is going to give you so much visibility and that it lets you reach such a broader audience. So yeah, a bit for the actual cool/boring part. So what is exactly a Snap? In a nutshell, a Snap is just an NPM package, contains some source code, which can be JavaScript, TypeScript, WebAssembly, and a set of metadata. Everything is then packed into a single JavaScript file, and you don't even have to bundle it, but we can provide tools for you to do that. So just, guys, think about this. Anyone that knows JavaScript, HTML, CSS, and has just a basic knowledge of blockchain and how MetaMask works can build his own Snap and can publish it. And this is actually what I said before. So as you can see, this is a Snap. This is the Filecoin built by the team at Protocol Labs. So as you can see, it's just an NPM package. And I will actually show you a few screenshots about the Snap. Before I do that, there is a bit of disclaimer. At the moment, the Snaps is not available in MetaMask production, the extension that you might be familiar with. But you can go to Google Chrome Store and search for Flask, which is just a canary distribution for MetaMask. So basically, anything that we are not ready to ship to production, we just hide it behind a build flag. And that's what Flask is. So if you go to the Chrome store, you can actually look for Flask, and you will see that it has a purple fox instead of an orange one. So yeah, this is the Filecoin Snap, what I was talking about before. So when you actually click on Connect to MetaMask, you will see, so you will see that it's asking me to connect to my account. Okay, I give permission to do that. And this is where the actual cool stuff starts to happen. So as you can see, this Snap is asking me, okay, do you want to access the internet, display confirmation in MetaMask, manage your Filecoin keys, store and manage data on your device? So that's what I was actually talking about before, that only Snap can ask, only this program can ask the user for permission to do these actions. Only the user can actually grant this permission. So, okay. So as you can see, where this is marked, this is an hyperlink. And when you click, it will redirect you to the NPM registry. We did this so you can actually check that the Snap you're trying to install is genuine and it's not malicious. So if I click on Approve and Install, yep. So it will ask again, are you sure you want to use this Snap? Okay, I'll click again on Approve Install, and boom. So this is my Filecoin account connected to my MetaMask. As you can see, I have my address, my public key, my balance, which is fairly low, and what I can also do is I can also access MetaMask core methods. So let's say I want to sign a message, yeah? So I can just come down here, write down hello MetaMask from chainsafe.io, click on sign, and this will call the MetaMask API. So it's asking me again, do you want to send this message? I click on approve, and this is the actual message signature. So yeah, this was just for you to have a taste of what you can do for snaps. But really, what I recommend is to go to this URL, or go to metamask.io, look for the snaps section, try to download Flask, maybe use the Filecoin snap, try to build something yourself. Yeah, wishing couple of months, couple of years, you can come back and tell me that you built something amazing and you have tons of users using it. Oh yeah, before I let you go, guys, and we are Consensus, we're hiring a lot of people, developer, designers, product manager, DevRel. So if you're interested, just look at the Consensus careers, or look around for me or for anyone else in the Consensus team. Yeah, that's it. Thank you so much.
Give it up for our diamond sponsor, MetaMask. Thank you very much, Mirko. We actually do have one more lightning talk. I have to pull it up real quick, so we'll start that in about 2 minutes. Thank you.
Yep. There we go.
All right, so I'm going to give it up to Annette from the Ethereum Standards Coordinator of Ethereum Magicians. I'll go ahead and let her introduce herself. Why devs should care about NFTs.
Okay. And
All you have to do is, yeah.
this? Okay, that's how it works. Okay, awesome. Hi guys, welcome. Thank you so much for staying so late at this conference, and thank you so much for coming to my talk. I'm going to very quickly talk about ERC since I have only 5 minutes. Just to quickly, I'm sure that everyone knows what NFTs are, so I'm not going to talk about that. But basically, all NFTs are running on Ethereum on ERC 721 or 1155 standards, and today I'm going to mention what are those standards. So quickly, what's ERC? ERC stands for Ethereum Request for Comments, and its on-chain application layer AIP. AIP is Ethereum Improvement Proposal, which is a standard of how things are being improved on-chain. And it's sort of like unification of standards and solidity functions on Ethereum, the chain itself. If you want to learn more about the ERCs, I wrote EIP FAQs, and there are ERCs as well. Mention this is the article, you can find it on my Medium. So quickly, what's ERC20? ERC20 is a token standard, which is the most popular standard on Ethereum chain, and it's the standard which most tokens are running on the Ethereum chain, and it's also kicked off the ICO craze in 2017. Back in the days, if you remember that. So the ERC 721 is the main Ethereum NFT standard, and it's the most popular one. There is also so much things to talk about this standard, but just to be very quickly, this is the smart contract token standard, which are being used for NFTs, and it was introduced in late 2017, so we all know that it's very old, and it's pretty unusable as a standard itself, because it's very simple and there are many issues with it which are causing that so many platforms are building their own custom solutions on the top of the 721 itself, and that's what is breaking the NFTs these days, and that's why NFTs are not really compatible between platforms and marketplaces, because they're so, the smart contract itself values so variable so much. there are like basically 721 functions, and since I don't have much time, I have to be very quick. So there is another NFT standard which is super popular, and it's 1155. This standard introduced us, it's sort of like ERC20 and 721 together, or like it's like very like something in between, and this standard mainly introduced the atomic swaps, multi-transfer and unification, which means that the main difference between 725 and 1155 is that the 1155, you can store like many NFTs in one contract. 721 only one NFT in one contract. That's like the main difference. And then also in 1155, every NFT is defined by token ID, and this allows us that we can even swap the NFTs between within each other in the one contract. So if you want to learn more about the standards, I wrote a huge wiki about all NFT related standards. Just make sure to check it out. It's a huge documentation of all NFT related ERCs. There are many groups, blogs, and we also have a working group on Telegram as well. And then there are many issues with NFTs as well, which we run into with 721. So these are the basic ones, and I have to be very quick. So just quickly, the main issue with 721 is the metadata, and the metadata are basically the token, the NFT attributes, which are the traits, which if you have like mainly PFP, you can see the attributes as like background or like the face or hair color or t-shirt color or anything like that. And metadata in 721 are defined by token URI, which points to storage URL like IPFS or RWLink, and it's like a JSON data blob, which is not even on chain, and that's like the main issue. And also in 721, the metadata is optional. Also, there is another standard which introduced only schemas, which defines like nothing, and it's not even helpful, and the standard is not even being used. And there are more about like what we need with the NFT metadata, but since I'm like over the time. Anyway, so music NFTs, there are many problems coming from the music NFT itself industry, but there is also a working group that is trying to create new music NFT standards. There are some proposals for new music NFT standards, which I actually wrote an article about, and these are just screenshots from my article. And since I'm over time, make sure to check out the wiki where you can find more information and articles, and this is my Twitter, so if you want to have more questions, feel free to reach out to me. I have the same handle on Telegram as well, so that's it. Thank you so much.
Absolutely fantastic, Anne. And let's get a round of applause for all of our sponsors again. We have 1inch Anchor, CoinMena, MetaMask, Syscoin, Yearn, I can never say this right, Moldau, Clayton, Clay City, Ton Capital, and Sushi. And that will wrap up ETHDubai 2022. Thank you, everybody. You've been an amazing crowd. And my name is Eric Bouchard. I am the Developer Relations Manager for MetaMask. If you'd like to reach me, I'm HTTP Junkie on Twitter. And this is Patrick, our organizer. So a round of applause for him, and thank you very much for coming.
Thanks everyone for coming, and we'll have a small picture with the speakers if you want to come on stage.
Speakers?
So I guess many of them must have left, but those that are still here, we'll take a small picture.
If you are a speaker at ETHDubai, if you can come up on the stage, we're going to take a final picture with everybody that is still here. If you're a speaker, please come up on stage. Thank you very much.
Annette? You also were a speaker.
Any other speakers? Thank you, everybody. Have a good night.
Hi. Yeah, I would also like to thank all the volunteers and all the people that help along the way. Eric and Ahmed.